Hello guys! Before starting the course and jumping into Linux administration, I want you to know what is the course outline so that you have a clear path ahead. This course has not only many hours of HD videos, but also tons of quizzes and practice challenges to help you keep track of your progress. They are broken down into sections so you can easily follow a logical learning process. Along the way, you'll watch me practice everything I teach you, and you can also practice yourself simultaneously with me. If you get stuck, don't hesitate to ask in the Q&A section or in the private group I've set up for this course. There are thousands of students just like you, eager to learn and answer your questions. After this introduction section, we'll start with setting up the environment. We'll discuss the Linux distributions and install in VirtualBox the latest versions of the most used ones, Ubuntu and CentOS. The concepts taught in this course are Linux distribution independent and can be applied to each flavor of Linux. However, we'll use mostly Ubuntu for common examples since it's more user-friendly and works well both as a desktop and as a server OS. But when things become different, I'll show you the same concept, tool or command on CentOS as well. The last lecture of this section will be about migrating completely to Linux. It's a step I've done more than 15 years ago and have never regretted. The next section is about the Linux terminal in depth. We'll talk about terminals, consoles, shells and commands, what is the structure of a typical Linux command, how to get help using man pages, and how to become efficient in the terminal using shortcuts, the tab key, or the history feature of the bash shell. At the end, we'll learn how to run commands as root. These are all Linux fundamentals, and by the end of this section, you'll feel more confident working in the terminal. Next, we'll have a big and important section ahead. It will be about the Linux file system. I'll teach you how the Linux file system is organized, what are the relative and absolute paths, how to combine multiple commands using piping and redirection, and we'll actually discuss and practice the most important Linux commands that are working with files and directories. You'll learn how to create new files and directories, how to delete, copy or move files and directories, what is an inode, and how to work with hard and symbolic links. You'll learn how to find files using locate and find, to search for text patterns in commands output and in files using grep, or how to archive and compress files and directories. At the end, we'll discuss one of the most used and popular Linux text editors, Vim. Once we get comfortable with working with the Linux file system and the major Linux commands, we'll move to the next section, User Account Management. You'll learn how users and groups are organized in Linux and how to manage them using specific shell commands, how to create admin users that can run commands as root, and how to monitor the users logged into the system. Then, we'll go to what I consider one of the most important parts of the course, the one considered the foundation of security in Linux, and I mean the section about file permissions. We'll learn together what file permissions represent, how are they displayed both in symbolic and in octal notation, how to change the permissions of files and directories, and how to change the file owner and group owner. We'll not just scratch the surface, but we'll go deep into special permissions such as set user ID, set group ID, or sticky bit. There's a lot of practice here. The next section is about Linux processes. You'll learn how to display the running processes, how to search for a specific process, or how to kill a process. By the end of this section, you'll know what a zombie or a daemon process is and how to make them immune to a closing terminal. In the next section, we'll dive into Linux networking. You'll learn about getting information about the configuration of network interfaces, setting IP addresses, the DNS servers, and the default gateway used by the system. I'll show you how to use, troubleshoot, and properly secure SSH. It will be the time to introduce some real useful Linux tools like SCP and rsync, the latest being probably my favorite Linux command. At the end, we'll talk about open ports and scanning other hosts and networks. This will be really fun. Next, we'll be talking about software management, how to install, upgrade or remove applications on both Ubuntu and CentOS using the package manager. I even show you to compile a server from source code so that you can customize your installation. Next, we'll move to system administration and talk about scheduling tasks using cron and anacron, mounting disks and managing services using systemd and systemctl. The next section is one of my favorites. We'll build a real project from scratch. We'll start by installing a Linux server in the DigitalOcean cloud, getting a domain name, and installing an authoritative DNS server to host the domain. We'll move ahead and install Apache, the most well-known open source web server in the world. Then, we'll configure it with virtual hosting and OpenSSL and digital certificates for encryption. PHP and MySQL server will be the next step, and after securing the MySQL server, I'll show you how to install and secure a web app like WordPress. The next section will be a large and advanced one. We'll dive into Bash shell scripting so that you can automate common administrative tasks. This is programming, and I'll try to make it as easy as possible for you. You'll learn about variables, flow control, command substitution, and many more. Take your time and stay on this section as long as you feel the need. And finally, there are some bonus sections on security that I find really useful and interesting as well. We'll discuss information gathering, reconnaissance, and traffic sniffing with a hands-on approach. You'll also learn about the standard Linux firewall, which is implemented by iptables and netfilter, so that at the end you'll be able to properly secure your Linux machine. SSH, public key authentication, is another bonus section that I find really useful in order to secure SSH, which is the de facto protocol for remote management. As you can see, there's a large amount of information to discuss, and in fact I've done my best to cover all major Linux topics that an effective Linux administrator must know in order to connect the dots and have a clear picture of the Linux OS. This lecture is about planning your learning experience. Let's see how to get the most out of this course so that at the end you'll be an effective and valuable Linux administrator. My first advice is to go through this training using a laptop or a PC, since you are going to work with lots of commands and applications and you are going to have to keep pace. Watching this course on a smartphone, even one with a large display, is something that I strongly do not recommend. This course consists of very important Linux concepts which should be well known by any effective Linux administrator. I've tried to include all the Linux key concepts that I've considered one must know. Of course, if you feel there's something I've missed out, get in touch with me. Your feedback is valuable and I'll update the course accordingly for the best learning experience. Have in mind that I'll continuously update the course with new and up-to-date content. And now comes something important. I've organized the course in sections as I wanted it to be as modular as possible. Please go through the course in the order I have provided. Only by doing so, I can guarantee you will benefit from a coherent and consistent learning experience. Order matters and helps you build a strong foundation. For every Linux command or key concept, you'll get not only a video, but also quizzes, challenge practice exercises, commands sections full of examples, and slides. I'd recommend you to watch the video first, exercise the practical part simultaneously with me, and if necessary repeat this process as many times as you feel the need. Look at the slides and at the command sections to deeply understand each concept. Then test your knowledge with quizzes and practice challenges. If there's something not clear, don't hesitate to get in touch with me or with the other students. Use the Q&A section of the course or write in the course private Facebook group. Keep in mind that Linux system administration is difficult in general. Try to practice every day and give yourself some time. Many studies have shown that an average of 1 year is necessary to build a strong foundation if you are a beginner and start it from scratch. No one became an expert overnight. Consistency is very important when you are learning a new technical skill. I'd recommend making a commitment to yourself to practice every day. Okay, enough talk, let's get started. In this lecture, we'll start talking about Linux distributions and which one is right for you. A Linux distribution, often abbreviated as distro, is an operating system made from a collection of software that is based upon the Linux kernel and often a package management system. This is the definition. The Linux operating system isn't produced only by a single organization, as in the case of Windows or Mac. Different organizations and people work on different parts of it. The operating system comprises the Linux kernel, the core of the operating system, which is common to all distributions and provides an interface between the hardware and the software and users. The GNU shell utilities, the terminal interface, and most of the command you use, the graphical desktop environment, and more. Distributed as source code, all of these components are open source and free software, and together they make up a specific Linux distribution. Even though they have different philosophies, the core and the main concepts are the same. In fact, if you learn how to use a specific Linux distribution, then you'll adapt and use another one with little or no effort. At the moment, there are hundreds and hundreds of distributions, each of them built for a specific purpose. Red Hat, CentOS, and even Ubuntu power the servers of the internet. Linux Mint is used for personal computers. OpenWRT runs on embedded devices like routers. Raspberry Pi OS is the system highly optimized for Raspberry Pi with ARM CPUs. And RUX cluster distribution is intended for high-performance computing clusters. Take a look at distrowatch.com. This website provides statistics and general information for various Linux distributions. This is the database of Linux distributions. DistroWatch creates a ranking of all the distributions out there based on the page hit ranking that shows the number of times a distribution page on distrowatch.com was accessed each day. This is a way of measuring the popularity of any Linux distributions. So if you are just starting out with Linux, you've probably already got overwhelmed. You just wanted to learn Linux, and now you find out that there are a bunch of Linux variants. If you want to use Linux for business or for building a career, then you should know that the most popular Linux distributions used in the industry today are Ubuntu and Red Hat Enterprise Linux. So to answer the question, which Linux distribution should I use, I make it really easy for you and tell you that you should choose between Red Hat and Ubuntu. You can forget about hundreds of other Linux distributions and choose one of those two or a distribution that is built on them. Large companies like banks, telecom, or retailers use Red Hat. However, Red Hat is a commercial distribution, so you have to pay a subscription fee in order to use it, and the fee is not low at all. By the way, Red Hat was acquired by IBM in July 2019 for $34 billion US. But the good news is that in order to run Red Hat, it's not mandatory to pay for the license, and I'm not talking about pirating Red Hat. You can simply run CentOS, sometimes pronounced CentOS, which is another Linux distribution completely free based on Red Hat Enterprise Linux. CentOS is in fact Red Hat without branding and support. On the other hand, Ubuntu, which initially was itself based on Debian, is completely free. Ubuntu is used by startups, small companies, social networks, or by cloud-based services. Note that there are many other popular Linux distributions based on Ubuntu or Debian. I want to mention just a few of them. Linux Mint is a user-friendly distribution with an interface similar to Windows. This is perfect for beginners. MX Linux is another desktop-oriented Linux distribution based on Debian, which is a lightweight operating system designed to combine an elegant and efficient desktop with high stability and low resource consumption. And finally, Kali Linux, based on Debian as well, is a distribution used for ethical hacking, advanced penetration testing, and security auditing. It contains hundreds of security tools that run out of the box. This course is about Linux. It's not a Red Hat or an Ubuntu course. I want you to become an effective Linux administrator who will be able to efficiently run any Linux distribution. In fact, in today's ecosystem, a system administrator runs multiple distributions of Linux in virtual machines or in the cloud. That's why the concepts taught in this course are Linux distribution independent and can be applied to each flavor of Linux. We'll install both Ubuntu and CentOS, but we'll use mostly Ubuntu for common examples since it's more user-friendly and works well both as a desktop and as a server OS. But when things become different, I'll show you the same concept or tool on CentOS as well. Remember that Linux is Linux at the core, and no matter what distribution you use, the Linux concepts will be the same. As a final thought, I want to tell you that if you already have some experience with a specific distribution, or for some reasons you want to learn a specific Linux distribution, just go ahead and install it for this course. Now that you have a good understanding of what is a Linux distribution and which are the most commonly used ones, we'll take a short break, and in the next lecture, I'll show you how to install Ubuntu in a VM step by step. Welcome back! In this lecture, I'll show you how to install Ubuntu in a virtual machine. We'll use VirtualBox because it's free, but you can use VMware as well. The hardware requirements for Ubuntu Desktop Edition are at least 2 GB of RAM and 20 GB free space on your disk. From my experience, I can tell you that an SSD hard drive is also very important for a smooth run. The first step is to download the VirtualBox installer for your OS, probably Windows or Mac. The installer can be found on the download page here. Download the binary version for Windows, Mac or Linux. It's downloading. It's done. After downloading it, run the executable to begin installing the software. The installation process is straightforward. Just click Next a few times and at the end, finish. We won't go deeper into this because it's really simple. After installing VirtualBox, it's recommended to install VirtualBox extension pack on the host machine to unlock advanced VirtualBox features such as support for USB devices, flash drives, and many more. So download the VirtualBox extension pack from the same address and install it. There's a single file for all platforms. This is the file. It was already downloaded. Double-click the file, confirm the installation, and click the Install button. We are done with VirtualBox and we'll go ahead and download Ubuntu. In case you are wondering, Ubuntu is an African word meaning humanity, and it's often translated as humanity towards others. The latest version of Ubuntu uses the GNOME shell as the default graphical user interface, and this makes a resourceful system. If you only have an older system available, you could try a lightweighter desktop environment such as XFCE that runs on Xubuntu, or LXDE which runs on Lubuntu. We are talking about the same system, only the GUI being different. I'm also a fan of Linux Mint, which has a very friendly user interface. If you have enough space on your disk, you can try them all. There are 3 possibilities for the installation. To install it as the main OS, and in this case, we download the provided ISO file, create a bootable USB disk using a special software, and then boot up the machine using the USB disk. I'd recommend you to do so only after you get used to it a little. The second option is to use it live, and that means that Ubuntu will not be installed on your machine, but will run directly from a USB disk. And the third option is to install it as a virtual machine. This is the recommended way for beginners because there's no risk of breaking your main system. You can also download and try many other Linux distributions to see which fits you better. The same steps shown in this video will apply to any other Linux distribution. We go ahead and download the latest LTS version of Ubuntu. LTS stands for long-term support, which means 5 years of free security and maintenance updates. Ubuntu 20.04 is available only as a 64 version. There isn't a 32-bit version. Note that Ubuntu follows a biannual release cycle, with one release coming in April and other in October. An Ubuntu release has the version number in the format year, that month. So Ubuntu 20.04 was released in the 4th month, April, of the year 2020. Besides the version number, each Ubuntu release has also a code name, Focal Fossa being the code name for Ubuntu 20.04. It's almost done. Note that you also need a good internet connection to download the Linux ISO file and update the software. I've already downloaded the ISO file to save time, and now it's on my desktop. Start VirtualBox and click on the new icon to create a new virtual machine. Give it a relevant name like Ubuntu 20.04. Its type will be Linux and its version Ubuntu 64-bit. Click Next. The next step is to allocate RAM to the VM. 4 GB is recommended, but if it's not possible, allocate at least 2 GB or something in between. Bear in mind, the more RAM you allocate, the faster it will run. Note that you can change this value anytime, so you can test different values. Now it's time to create a virtual disk. This serves as the hard disk of the virtual Linux system. It is where Ubuntu will store its files, and it's completely isolated in a single disk file. Click Next and leave the default selection for the hard disk file type. In this step, leave the default selection, which is dynamically allocated. The disk file will only use space on your physical hard disk as it fills up, till the maximum fixed size you'll be setting up in the next step. Now it's time to select the file location and size. I'd recommend you to use 20 GB or more. If possible, for maximum performance, the location should be on an SSD disk. I'll leave the default location and click Create. Now, it's time to boot the Ubuntu ISO we've just downloaded and install Linux as a virtual operating system. I'm selecting the VM and clicking Start. Now I have to select the startup file, which is the ISO file. I'll browse to its location on my desktop by clicking the folder icon. In this window, I'm clicking Add and going to my desktop to select it. The ISO file was selected and I'm clicking Choose and then Start. Now it's time when you can get an error related to AMDV or VTX while trying to start the VM. This means that the virtualization or VTX is disabled in your computer BIOS. Reboot your system and access the BIOS settings using a function key that is specific for a computer or laptop model. Look for something related to virtualization or VTX and enable it. Save, restart the system, and then start the VM again. Let's return to the Ubuntu installation. It has started, and in a few seconds I am presented with two options. I could try it as a live OS, or I could install it. And of course, I'm clicking Install Ubuntu. In this window, I can choose the keyboard layout. In my case, it's English US. In this window, I'll leave the default options, which are normal installation and download updates while installing Ubuntu. This option requires an active internet connection since it will update the system while installing it. The installation process will take a longer time. Now, depending on what you want to do and how quickly you want to install it, you can leave this option unchecked or not. You can also update the system anytime after installing it. I'll select both options and click Continue. If, like myself, you install Ubuntu in a VM, leave the default option and click Install Now. If you are installing Ubuntu as your main operating system, this step is very important. The default option will delete all your data and will format your disk. Maybe you want to try a custom installation type by selecting something else. You'll be able to manually select, create, and format your partitions. However, make a good backup of your files in this case. I'm clicking Install Now. Select your location and click Continue. And in the last step, write your name and your computer's. The computer name will be the host name that will be displayed as part of the prompter. Pick up a username and choose a password. Student and the password. And you are done. Depending on your hardware and your selections, it may take around 10 minutes to complete the installation. I'm pausing the recording until it's done. The installation is complete and I'll restart it to log into the system. If it gets stuck on this screen, you may choose to close VirtualBox. And if you want to save space on your disk, you can delete the ISO file. It's not necessary anymore. Once restarted, I can log into Ubuntu with the user and password specified at installation. Great! The network card is put into net mode, so I can access the internet as well. I'm starting Firefox. I'm also starting a terminal to check the internet connection. I want to ping an IP address. Ping is working. And let's check a popular website like youtube.com. If you can't maximize the window, don't worry, because I'll show you how to fix it in the next lecture. That's how you install Ubuntu as a VM in VirtualBox. In the next video, I'll show you the top things to do after installing it. See you in a second. The first thing to do after installing a Linux distribution is to update all installed applications to their latest version. When you installed Ubuntu, you've created a username with a password. This is the user and the password used to log in. Many, if not all administrative tasks, including updating or installing new software, must be started as root. Root is the Linux administrator, and we'll have a lot of talks about it in the next lectures. To run commands as root, which means with administrative rights, use the sudo command and the command you want to run as root. Let's see how this works. I want to run some administrative commands that fully update all installed applications. I'm clicking this Ubuntu menu, Show Applications, and searching for a terminal. And I'm opening it. Another quick way to open a terminal is to click on the desktop with the right mouse button. Then select and click Open in Terminal, and a new terminal window is opening. So in the terminal, write sudo apt update. It's asking for my password, and the command will run with root privileges. note that it requires an active internet connection. When it's done, I'll run a second command which will actually update all applications to their latest version. Sudo apt full -upgrade. It's prompting the user to enter Y to continue or N to stop. Note that this command requires a good internet connection since it's downloading a lot of software. As a conclusion, if you prefix a command with sudo, you are prompted for your own password and the command will run with root privileges. If you are a complete beginner, don't focus too much on this. Just update the system because we'll really dive deeper into this in the lectures to follow. We are waiting for it to finish. I'll pause the recording until it's done. And it's done. The system was fully updated. The second thing to do is to install the guest additions in the host VM, so in Ubuntu. They consist of device drivers and system applications that optimize the guest operating system for better performance and usability. The most important features are better mouse integration, shared folders and clipboard between the host and the guest operating systems, better video support, and so on. Go to Devices in the VirtualBox top menu and click on Insert Guest Additions CD image. This is provided as a single CD-ROM image file that is called vboxguestadditions.iso and is located in the installation directory of VirtualBox. So it comes with the VirtualBox and it's already available. A new window pops up and you can choose Run. It's asking for a password because it will run as the superuser, which is root. And it's installing the guest additions. It's adding some kernel modules and so on. And it's done. If there's any errors or you don't want it to run automatically, you can run it manually. In a terminal, move to the directory where the guest additions ISO file was mounted using the cd command. Cd, a white space, /media, my username, student, and I'm pressing the tab key for auto-completion. And I'm hitting enter. This is the directory where the guest additions file was mounted. Let's see the contents of this directory by running the ls command. Here we see some executable files for different operating systems, including Linux, Windows, and Mac. We are running Linux, so we are gonna run the Linux script, which is vbox linux additions.run. As root, I'm executing the script, sudo bash, and the name of the script. You can use tab for auto-completion. This is one way of executing scripts in Linux, and it's running. It's doing the same thing as before. After it has finished, it's recommended to restart the VM in order to load the new kernel modules. So you could simply execute the reboot command at this moment. I'm restarting the VM. After the system restarts, you will be able to resize the VirtualBox window and the Ubuntu screen resolution will be updated accordingly. Now it looks better. I can eject the VirtualBox additions. Also note that each version of VirtualBox, even minor releases, ship with their own version of the guest additions, while it's kept stable so that guest additions already installed in a VM should continue to work when VirtualBox is upgraded on the host, for best results it is recommended to keep the guest additions at the same version. So repeat the process of installing the guest additions after upgrading VirtualBox. And the last thing I'd recommend you to do is create a snapshot of the current state of the VM. This is a very powerful feature because snapshots allow you to save a particular state of a VM. This can be useful when you want to test something or you are about to make a change to the VM, and you need to be able to roll back to a working instance if something breaks. This is our case. We'll run lots of commands, install and update software, create and delete files, and many more. As we are learning by doing, there's the chance that something will break the Ubuntu system. Instead of installing it from scratch, we'll only roll it back to this working state. This is a serious time saver. So to create a snapshot of a running VM, go to the main menu of VirtualBox, click Machine, and take Snapshot. It's a good idea to fill out the name and the description because you might take multiple snapshots and you don't want to get confused when restoring only a specific one. It has created the snapshot. To see the snapshots, in the VirtualBox Manager, click this icon and then Snapshots. You'll be presented with the taken snapshots. Say you are working in your VM and you make a change that breaks the system. What are the required steps to roll it back to one of the previous snapshots? First, the VM must not be running. You can restore a snapshot only if the VM is either in a saved state or it's powered off. So, I'm powering off the machine. I'm selecting the VM from the left pane of VirtualBox Manager and clicking on Snapshots. I'm selecting the snapshot I want to restore and then click Restore. In this window, I can create a new snapshot of the current machine state or not. This is supposedly the broken state, so I'm not selecting this option. I'm restoring it. It was restored, so I can start it. I advise you to play around with snapshots, as in my opinion, this is a must-use feature when working with virtual machines. In this lecture, I'll show you how to install CentOS in a virtual machine. The first step is to download the CentOS ISO file from the official CentOS website. I'm installing the latest version of CentOS, which is 8 at the moment, and I'll select a mirror server that is geographically closer to me. These servers act like backup servers and provide fault tolerance and availability. And I'm downloading the ISO file. You can download the DVD file, which contains all the applications, or a smaller one, the boot file. I'm downloading the boot ISO file. In fact, I've already downloaded the file to save time, and now it's on my desktop. The next step is to start VirtualBox. I suppose you've already installed it. I've shown you how to do it when we have installed Ubuntu. If, for some reasons, you don't have it, just go to virtualbox.org, click the Downloads link, and then download and install VirtualBox for our platform. The installation is very simple and there's no point to show you this at the moment. Download and install VirtualBox extension pack as well. This is provided as a single file for all platforms. Let's return to CentOS installation. Go to Machine and click New. This will create a new virtual machine. Give it a relevant name like CentOS 8. Set its type to Linux and version to Red Hat 64-bit. I'm clicking Next. In this window, select the amount of RAM that will be used by CentOS. The recommended size is 2 GB, but the more you can give, the better it will be. Now it's time to create a virtual disk. This serves as the hard disk of the virtual Linux system. It is where CentOS will store its files, and it's completely isolated in a single disk file. Click Create and leave the default selection for the hard disk file and type. In this step, leave the default selection, which is dynamically allocated. The disk file will only use space on your physical hard disk as it fills up to the maximum fixed size you'll be setting up in the next step. Now it's time to select file location and size. I'd recommend you to use 20 GB. If possible, for maximum performance, the location should be on an SSD disk. I'll leave the default location and click Create. Now it's time to boot the ISO file we've just downloaded and install CentOS as a virtual operating system. I'm clicking the Start icon and then selecting the startup file, which is the ISO file. I'll browse to its location on my desktop by clicking the folder icon. In this window, I'm clicking Add and I'm going to my desktop to select it. The ISO file was selected and I'm clicking Choose and Start. It has started, and in a few seconds you'll be presented with the grab menu and some options. I'm selecting the first option, which is Install CentOS Linux 8. After hitting Enter, it's possible to get an error. If you get this error, which is related to AMD V or VTX, while trying to start the VM, it means that the virtualization or VTX is disabled in your computer BIOS. Reboot your system and access the BIOS settings using a function key that is specific for a computer or laptop model. Look for something related to virtualization or VTX and enable it. Save the settings, restart the system, and then start the VM again. Let's return to the CentOS installation. I'm hitting Enter. Note that when you click somewhere in CentOS, the mouse pointer will be captured by the guest OS. To return the ownership of the mouse to your host OS, VirtualBox reserves a special key, the host key. By default, this is the right control key on your keyboard. So to release the mouse pointer, I have to press on the control key. I'm selecting the language and I'm clicking Continue. In the next window, a summary of the installation is displayed. Before continuing, I have to complete the items marked with this exclamation mark icon. I'm clicking the installation destination, selecting the virtual hard drive, and leaving the storage configuration to its default values. So, to automatic. And I'm clicking Done. Next, I'll set the network, so I'm clicking the network and hostname. In this window, I'm enabling the network interface, which, at least in my case, was disabled. Now it's on. I'll also change the hostname to CentOS 8. I'm clicking Apply and Done. Next, I'll click the software selection. If you want to install CentOS server with a graphical user interface, then you don't have to do anything else. But if you want to install CentOS as a headless server or without a GUI, select the second option, this one. I'd recommend you to leave it as it is. And I'm clicking Done. Great, there's no exclamation mark. I can begin the installation. If you want to make other changes, like setting up the time and date, now it's the time to do it. I'm done, so I'll click on Begin Installation. The installation has started, and I have to set the root password and another non-privileged user. I'm setting the root password. And I'm creating a new non-privileged user. This is in fact the user that will be used to log into the system. Type his full name, username, and his password. I'd recommend you to select this option as well. Make this user administrator. And I'm done. The installation is still running. It will take a few minutes, maybe more than 10, depending on your hardware and internet speed. It's downloading a lot of software. I'm pausing the recording until it's done. And it's done. I'm rebooting it. After a successful installation, we need to restart the virtual machine. The ISO file used for installation was mounted on an optical drive or a CD-ROM. This time, we don't need the ISO file inserted in the optical drive, and I don't want it to boot up from that file again. So go to Devices, Optical Drives, and remove disk from virtual drive. If it says that's currently busy, then go ahead and force it to unmount. Restart the VM by going to Machine and Reset. Start the VM again, and it should probably boot into the new CentOS 8. Now it's booting into the new operating system. At the first boot, you have to accept the license. The distribution was released under GPL v2 license, which means it's completely free. I accept the license agreement and finish the configuration. And I'll be greeted with the welcome screen of CentOS. I'm logging in using the username and password created during installation. It will prompt you for some configuration like language, privacy, and so on. Just click on Next a few times. After that, it should display your desktop. Great. The network card is put into net mode, so I can access the internet as well. I'm opening Firefox. Let's see if I can access centos.org. And it's working. I have an active internet connection. If it's not working, check that your network interface is set to connect automatically. Go to this top arrow, Wired Connected, Wired Settings, and check that the wired interface is connected and set to connect automatically at boot time. Great! You now have a very nice Linux server distribution running. This lecture is only for people that may be thinking of switching to Linux completely. If you just want to learn Linux for a system administration job, then you can skip this lecture. I'm taking the perspective of a Windows user that may be thinking of migrating to Linux as its main desktop OS. You should know that I've done that more than 15 years ago and have never regretted it. Now, I'm using Windows just for some specific tasks, such as recording these videos. On the work PC and the laptop, I run only Linux. By migrating to Linux, you'll end up with a working and a more stable and secure operating system which is really free and open. No more problems with licenses or pirated software. If you want to make the step, I recommend you a Linux distribution that is user-friendly. I've been using for years Linux Mint, which is similar to Windows. The latest version of Ubuntu is also a good choice. So many say that Linux is more difficult than Windows, but I'd argue with that. A modern Linux distribution is not harder, even for non-savvy users, it's just different. Let me walk you through the most important features of Ubuntu. The first thing you may want to do is to access the settings. Go up to the top, click this small arrow, and you'll have access to the settings. Here, you can make all kinds of changes to the way Ubuntu looks and behaves. For example, go to Appearance and you'll find there options for the window colors: light, standard, and dark. Many people prefer the dark theme, so you can enable it if you wish. Let's talk about the dock, which is the bar on the far left of the screen that contains icons for the most popular applications or the applications that are running. This is the dock. In this window, you can change the dock settings. You can set it to hide when any active windows overlap with it. You can change the size of the icons or its position on the screen. At the moment, we have the settings on the dock, and that's because any active applications will appear on it. In fact, it will display a red dot before each application that's running. If I start the Firefox browser, a red dot will appear just before the icon. It's running. You can also go to Activities, and it will show you all running applications for easy access. You can also access active applications by pressing the Windows key, which is called the super key in Ubuntu. And of course, you can move between applications using Alt and Tab as in Windows. On the bottom of the dock, we have the Show Applications icon that will bring up all applications currently installed. We can scroll up and down if we wish, or search for an application name in the search box. I have searched for the calculator. I'm starting LibreOffice Writer, which is an open source replacement for Microsoft Office. If you want to add a favorite application to the dock for easy access, just search for that application, for example, Calc. Click with the mouse right button on it and select Add to Favorites. And the Calc is on the dock. And to remove an application from the dock, just click on it with the mouse right button and remove from Favorites. If you want to install new applications, just go to Ubuntu Software. Click on the suitcase icon on the dock and the Ubuntu software will open. The software catalog is being downloaded. This is the main interface of Ubuntu software with application categories, including editor specs. You can browse the categories or search for a specific application by clicking Search or pressing Ctrl and F. I'm searching for Spotify. To install an application, just select it and click on Install. You need administrative privileges, so you'll have to enter your password. Simply put, if you choose a modern Linux distribution like Ubuntu 20.04 or Linux Mint, the transition from Windows will be fairly smooth. Some of the problems that might appear are related to some licensed applications that are not available on Linux. For example, if you work as a graphic designer and use Adobe Photoshop a lot, then you should know that it doesn't run on Linux. Of course, there are some alternatives like GIMP or Inkscape, but it's not the original product. However, Most applications, like all major browsers, video conferencing software such as Zoom, or integrated development environment applications such as Visual Studio Code, run on Linux as well. And if you really need a Windows or a Mac application that's not available on Linux, you can always run Windows in a VM, install and start that application. And one final thought. Compared to proprietary operating systems like Windows or Mac, Linux has only one master, and that's you. Hello, and welcome to this lecture on the Linux terminal in depth. When someone starts to learn Linux, the first words he will hear about are command, console, or terminal. At first sight, they seem intimidating, especially for a complete beginner. But rest assured that at the end of this lecture, you'll know in detail what they are and what they do. Linux is an operating system highly oriented towards commands. Even though there are many graphical interfaces available, any effective Linux administrator will prefer running commands for different administration tasks. This is what makes Linux so powerful and flexible. There are hundreds of highly efficient commands, and knowing how to use and combine them makes you a highly efficient sysadmin. Let's see what a terminal is. It is actually called a terminal emulator and is a crucial part of any Linux system because it basically allows you to access the system through a shell. It's a program that opens a window and lets you write commands. There are a bunch of terminal programs available, but the most used one is the GNOME terminal, which is the default terminal in Ubuntu and CentOS. Other terminal emulator applications are Console, Xterm, Quake, or Terminator. Let's open the GNOME terminal. Go to Show Applications on the dock and search for Terminal. This is the GNOME terminal. Another quick way to open such a terminal is to click on the desktop with your right mouse button and then select Open in Terminal. Or the shortcut used to open a terminal is Ctrl, Alt, and T. I have started more than one terminal. Note that you can start as many as you wish as new windows or new tabs in the same window. If you want to start a new terminal in a tab, just click on this plus sign. In this window, there are 3 terminals running in 3 tabs. But what is a shell? Simply put, a shell is a program that takes commands from the user through the keyboard and gives them to the operating system's kernel to get executed. It's also called the command interpreter because it accepts commands from the user and then checks or interprets them to see if they are syntactically correct. And if they are, the shell will send them to the kernel for execution. The shell gets started when the user logs in a console or starts the terminal. In this terminal, the default shell was started. In this example, I've started a few terminals, and in each terminal the default shell has started and is waiting for the commands. I'm executing a few different commands. An important thing to know is that Linux is a case-sensitive operating system, which means that it's sensitive to the capitalization of letters. This is different compared to Windows, which is case-insensitive. From now on, we'll consider the commands and options as written in lowercase letters if I don't specify otherwise. So if I say run the IP address command, without specifying the case, it means the command should be written in lowercase letters. Let's get back to the shell. Imagine that any Linux command you want to execute, from a simple file copy operation to a full system upgrade, should be written into a shell, which in turn will check to see if the command exists and is syntactically correct before sending the command for execution. For example, this command .sa doesn't exist. There are several shells available, but the most widely used one is called bash. It is the default login shell for many Linux distributions, including Ubuntu, Linux Mint, Debian, CentOS, and macOS as well. If you run Windows Subsystem for Linux or WSL on Windows 10, Bash is also the default shell. Other shell applications besides Bash are Bourne Shell, C Shell, Korn Shell, or Z Shell. In this terminal, the Bash shell was started. We've discussed terminals and shells, but didn't say a word about consoles. What is a console? The console is a special sort of terminal that starts if no GUI was installed, so the terminal and the console are similar. You start a terminal in a graphical interface and a console in a text-only interface. Modern Linux systems provide more virtual consoles. These are usually accessed through key combinations, which are Ctrl, Alt, and F1 to F8. So there are 8 virtual consoles, but one of them is already used if there is a graphical interface that has started when you've logged in. However, if you installed Linux in VirtualBox, it may be possible that the key combinations will be caught by the guest OS, not by the host OS, and won't work. Let's recap in a nutshell. The terminal is the graphical application where the default shell will start. This is a terminal called GNOME terminal, and the default shell, which is Bash, has started. In the shell, which is the command interpreter, I can write commands, and the shell will send them to the kernel to get executed. And finally, a console is like a terminal but is started in a text-only environment where no GUI or graphical user interface was installed or started. Note that in Linux world, at the keyboard, the shell, the terminal, and the console can all look pretty much the same from the user's point of view. Many times the terms terminal and console are used interchangeably. It's common to say, I run the command at the console, even though the command was typed in a terminal. Note that the GNOME terminal is not the only one. I'll install a new terminal emulator called Terminator, which provides several features that the default terminal application does not support. A useful feature is the ability to create multiple terminals in one window. So, in the GNOME terminal, I'm writing sudo apt update && sudo apt install terminator. It's installing the terminator. Sorry, I've misspelled it. It's install written with double L. I'm confirming it. It's done. And I'm adding it to the dock as a favorite application. Terminator and add to favorites. I'm also adding the default terminal to the dock. This is the Terminator. I'll also change the default theme to a lighter one for you to see it better. This is better, at least for recording. And if I want another terminal in the same window, I'm just clicking with the right mouse button and then split horizontally or split vertically. And I have 2 terminals. Let's go ahead and discuss the structure of the Linux commands. To give a command to a Linux system, you type in a shell the command's name, its options, and arguments if required. Let's get started with an example. I'm opening a terminal and the default shell, which is Bash, was started. And I'm running ping -c1 8.8.8.8. As you probably already know, the ping command, which is available on Windows and Mac as well, is used to test the network connectivity to a destination host. For the moment, please don't focus on the actual command or on what it does. We'll have plenty of time to dive deep into each important command. Just focus on the structure of the command line and how I put things together. We notice that we have an active connection to 8.8.8.8, which, by the way, is a public DNS server from Google. This is how we check that the internet is working. If you have any issue with your internet connection, to continue with this example, you can ping your loopback interface IP address, which is 127.0.0.1. This is the IP address of your loopback interface. It will work even though you don't have an active network connection. Let's take a closer look at the command line. The name of the command is ping. C is one of the command's options, 1 is the options value, and the IP address, which was 127.0.0.1, is the command argument. It's important to know that all options are preceded by a hyphen, a minus sign. Note that the command name, its options and arguments are always separated by one or more white spaces. In fact, the shell knows that the command name ends where it sees the first white space. The command name has ended here, before -c. Note that it's common to separate the command name, its options and arguments by one white space, but there's nothing wrong if you write more white spaces. This is correct as well. It's fairly standard that the options must come after the command name and before any command arguments. However, there are variations and commands that permit options after the main argument, like this. I'm removing -c1 and I'm writing it at the end, -c1. By the way, it means that it will send only one ping packet to the destination. This is the same, but it's not common. In the examples of this course, we'll follow the standard and we'll write the options after the command name and before its arguments. In Linux, there are commands that require some options or arguments and return an error if they are run without arguments. And there are other commands that do not necessarily require options or arguments. For example, if I run the ping command again, this time without any option or argument, I'll get an error. It says destination address required. It's mandatory to specify an argument. But if we take another command, say ls, we'll see that we can run it both with and without options or arguments. By the way, ls is probably the most used Linux command. Its name comes from list and it displays or lists information about the file system. In this example, the ls command has displayed the contents of the current working directory. Now, let's run it with an option and an argument. -l option tells ls to use a long listing format, and /etc, which is the argument, indicates what directory to list. Using the options, we change the command's behavior. Note that some options can be written using a hyphen or a minus sign and a single character such as -l or double hyphens and an entire word. So ls -all and ls -a are similar. It's the same command. By the way, this option -a or -all will display the hidden files and directories as well. Note that we can use more options, not only one. In this example, I'm using both short and long options. And it's common to group all short options together like this. See how I've grouped the L and H options together. The last two commands have the same effect. They are equal. Let's see one last example. I'm running a command without any option. df. The same command with a single option in short format. the command with two options. Sorry, the command is df. Or I can group the options. I can also add a third option in long format. By the way, the df command displays information about the file system and the disk space usage. Okay, that's all about the Linux commands structure, options, and arguments. This lecture is really important if you're a complete beginner. Take your time to deeply understand each concept and rewatch the video until you feel confident about it. Linux comes with hundreds of commands, each of them with lots of options. It's impossible even for an experienced Linux administrator to remember all the commands and their options. Fortunately, Linux comes with its own help built-in system. In this lecture, we'll be talking about man pages. Man is short for manual, and a man page is simply the documentation of a program or command. You can use the man command to read the documentation of a specific command. To open the man page of a command, you type in the terminal man and the command's name. Let's open the man page of the ls command. I'm writing man ls. By default, man uses a program called ls to display the output. While you are in the man page, you can get additional help by typing the letter H. I've just typed H. You see this title, Summary of less commands. This means that the man command used the less command to display the help. For a beginner it could sound weird, but there's a command called less used to display the contents of the text files. It's a viewer or a pager. To get out of this screen, you press Q, and to exit or to get out of the man program, you press Q, which comes from quit again. Let's open the man page of ls again and see what is its main structure. You'll find the same structure for all man pages. The first line contains the name of the command you are reading about, along with a very short description. Then comes the synopsis of the command, which provides a formal description of how to run it. In this example, we run it as ls, some options, and some files as arguments. In a man page, everything that appears directly before three dots, which are also called ellipses, can be repeated. So you can repeat different options and also file names. This means that you can specify more than one option or file. Options and arguments are put between square brackets to indicate that they can be left out. They are not mandatory. This is the case of ls. We can run it both with or without options and arguments. Other conventions used in man pages are: when you see bold text, you are supposed to type in exactly as seen. But when you see an underline or italic text, you need to substitute it with something appropriate. Here we don't write size, S-I-Z-E, but we have to specify the size, the actual size. After the synopsis, a longer description of the command is given together with all its available options. When you see an option in short format, a comma and an option in long format, it means that you can use any form you wish. Note that some man pages contain an extra section called options, where the options are explained. Take a look at the man page of the df command. This is the options section. At the end of the man page, there are the author, the copyright, and see also sections. Let's go ahead and talk about the navigation within a man page. Let's see the most important navigation keys. Use the arrow keys to move a line up or down. Up and down. To forward one window, press on Ctrl and F or on the space key. I'm forwarding one window. I'm at the end. And if you want to move backwards a screen or a window, you press Ctrl and B. I'm moving backwards. And to go to the very beginning of the man page, type lowercase g, I'm at the beginning, and to go to the very end, type uppercase G, I'm at the end. Sometimes you want to search in the current man page for a specific option. Let's say we are in the man page of ls and we want to find matches for sort within that manual page. First, I'm going at the beginning, so I'm pressing G. What I'll do now is write a backslash and the string I want to search for. Sort. And I'm hitting enter. Any matches in the current man page will be highlighted. You can then navigate between matches with N, like this, or Shift N, or uppercase N. N will take you to the next match, and Shift N, or uppercase N, will go to the prior match. So backwards. When you search using a /, the searched term, it is searched forward. But if you are, for example, at the end of the man page, so I'm pressing an uppercase G to go to the end, and want to search backwards, then you type a question mark and the searched term. Or -u. I was searching backwards for -u and it found a match which says that the option is used not to sort file entries. Okay. Those were the most important things about man pages that I think you should know. Also note that there are two types of commands in Linux. Commands that are executable files on the disk and shell built-in commands. The last ones are built into the shell and most of the time they don't have a dedicated man page. I'm quitting, pressing Q. To check if a command is an executable file or a shell built-in, use the type command. So type df. It's displaying the path to the command. Or type apt. All these commands are executable files and have their own dedicated man pages. But commands like cd, alias, or umask are shell built-in and do not have a dedicated man page. All these commands are shell built-in. To see the help of such a command, instead of man, use the help command and the command name. So help cd. And you see its help. So cd is used to change the shell working directory. Note that you can use the help command only for shell built-in commands and not for commands that are executable files on the disk. So help ls is not working. But another way to get some help is to write the name of the command and --help. This is available for both shell built-in and executable files commands. So rm --help or ls --help or cd --help and so on. I'll introduce you a new command which is ifconfig. This is used to both display information about the network interfaces and configure them. If you want to see the IP or MAC address of a network interface, you have ifconfig at your disposal. ifconfig belongs to nettools package. If, when running ifconfig, it says command not found, then you should first install the nettools package. Run as root on Ubuntu, apt install nettools. So sudo, the command will run as root, apt install nettools. Or on CentOS, dnf install nettools. Sudo dnf install nettools. On CentOS, it's already installed. And a final trick I'd like to give you is how to search for a command, feature, or keyword in all man pages. To do that, use man -k and the keyword you are searching for. Let's say man -k ifconfig. Or man -k uname. You can also pass a string enclosed in double quotes as argument. Man -k copy files. It will search for the string copy files in all man pages. And it found 3 commands. Note that man-k is similar to the apropos command. So apropos and the command ifconfig, or apropos uname, x the same. In these examples, it has searched for ifconfig respectively uname in all man pages and has displayed the commands that contain references to the searched keyword. Now, if I want, I can check the man pages of those commands to dive deeper. For any Linux professional user, the command line is an essential and ultra powerful tool. In this lecture, I'll teach you how to be really efficient when using the terminal. The most important advice I could give you is to use the tab key for auto-completion. This is something you cannot live without. It will not only save you so much time at the Linux command line, but it will keep you from making mistakes as well. Tab is a feature supported by Bash and other shells as well. If you have to remember only one shortcut, this should be the chosen one. How it works is really simple. When typing at the Linux command line, just use tab to auto-complete commands, file names, or folder names. To use this feature, type the first few letters of the command you want to run or the file name you work with, followed by tab. Bash will scan the current directory as well as all other directories in the search path for matches to that name. If a single match is found, Bash will automatically complete the file name for you. If multiple matches are found, you have to press the tab key twice and it will show you all results, and you should continue typing until there's only one match. Let's see some practical examples. In my terminal, I write the letters IFC and press tab on my keyboard. The shell has automatically completed the command for me. Note that the letters IFC uniquely identifies the ifconfig command, and that's why it has automatically completed it. But if I write IF and press tab, nothing happens. Do you know why? Because there's more than one command beginning with the letters I and F, and the shell doesn't know which one I'm referring to. What I can do is press tab twice, and it will display all available commands that start with I and F. And there are 2. Then I can continue typing until it can uniquely identify the command and auto-complete it. Let's see another example. Tab is used to auto-complete both the commands and the files or directories. I'm writing cat, a white space, a /, and E, and I'm pressing tab. It has completed the etc directory from the root directory, which is / because there's only one directory that starts with the letter E, and that's etc. I continue and type the letters PA and press tab. Nothing happens because there's more than one file or directory beginning with PA, and the shell doesn't know which file or directory I want. But if I press tab 2 times, it will display all the files and directories that start with PA and are in the /etc directory. And there are 5. I'm typing the next letter, which is S, and pressing tab. Now the shell knows what I want and auto-completes the entire file name. By the way, the cat command displays the entire contents of the file at the terminal. Now it's time to tell you something really important, something that in my opinion is the key to not make serious mistakes while working in the Linux terminal. If tab does not complete automatically a command or a file name when it should, then there's a mistake. Do not continue writing the command or the file name, but stop and analyze what you have done up to that point. Tab doesn't complete because somehow, somewhere, there's an error. For example, let's suppose that by mistake, I'm writing a white space before the P letter like this. I'm hitting tab and nothing happens. it would be a mistake on my part to try to write the file name manually. I've got 2 errors. What I should do is analyze the command line and try to find the error, like this white space here. I'm removing it and then hitting tab, and it completes the file name. Another common mistake is to try to write the file and directory names manually instead of using tab. Let's suppose I want to remove a file in /var log directory. Like this. rm and the full path to that file. So /var log and the file. A random file, it doesn't matter. I won't remove it anyway. Don't focus on the rm command, which is used to remove files and directories, because we'll have plenty of time to talk about it later in the course. Instead of using tab auto-completion, like I actually did, I write the path manually. There's the chance that by mistake, I'll write a white space before the file name, like this. The effect will be that the rm command will consider that 2 arguments were given, /var/log and the file, and will try to remove them both. So instead of removing that specific file, you could remove the entire /var/log directory, which will break your entire system. Such a mistake is avoided if you always use tab completion. I hope that this lecture has provided you with a good understanding of how tab completion works and how to properly use it. A Linux administrator spends most of his work time in the terminal. In this lecture, I'll show you a list of useful bash shortcuts that every Linux admin should know if he wants to get things done faster. Let's get started. Ctrl and L clears the screen. If there's anything on the screen, you can clear it by pressing Ctrl and L. It's similar to running the clear command. Ctrl and D closes the bash shell. It's similar to running the exit command. I'm pressing Ctrl and D. The shell was closed. I'm opening the terminal again. You can also type exit. Ctrl and A moves the cursor to the beginning of the line. This is useful if we run a command on a file and then we want to run another command on the same file, like I'm running ls-l etc password, and now I want to run the cat command on the same file. Instead of writing the command again, I can press up the arrow key to recall the last command and then press on Ctrl and A to move the cursor to the beginning of the line. Now I can simply replace ls with cat and run the new command. Of course, I have to remove the -l option, which is an option of ls. By the way, up arrow key retrieves the previous command. If you press it constantly, it takes you through multiple commands in history, so you can find the one you want. Use the down arrow to move in the reverse direction through the history. Another useful shortcut is Ctrl and E, which moves the cursor to the end of the line. I'm pressing Ctrl and E, and the cursor was moved to the end. I can continue writing. Another useful shortcut is Ctrl and U, which deletes all characters before the cursor by cutting and adding them to the clipboard. Let's consider this command, and you want to execute another one. Instead of pressing on backspace multiple times, you could press Ctrl and U. Ctrl U is also useful when you type in a password and after a few characters you realize you made a mistake. I have typed a few characters and I've realized I did a mistake. Instead of pressing on backspace multiple times, I could press Ctrl U. The entire command line was deleted. Let's move on and see another shortcut. To interrupt the process running in the current terminal, press Ctrl and C. Let's say you run a command that takes some time and want to stop it. Then you press Ctrl and C. For example, I'm gonna download a very big file using wget, and after a few seconds I'll decide that I want to stop it. And I'm stopping the command, pressing Ctrl and C. It was stopped. Or another one. Ping and an IP address. Without any option, ping will send packets continuously. I'm stopping it by pressing on Ctrl and C. It was stopped. Note that Ctrl and Z does not stop the current running process as Ctrl C does, but only suspends or pauses it, and it can be resumed later on. I'm pressing on Ctrl and Z. The process was not interrupted, was just stopped. The difference being that I can resume it anytime later. For example, big G, %1, and the process was resumed. We'll talk more about these concepts in the process section. Let's talk about bash command history. The bash shell stores in the user's home directory the history of the commands each user has run in a file. The file is .bash_history by default. The number of commands that will be stored in the history file is controlled by an environment variable called hist_file_size, written in uppercase letters. Remember that in Linux, everything is case sensitive. To print the value of a variable, run echo, the $, and the variable name. In this case, hist_file_size. This is the variable. And we notice that this Linux system saves 2000 commands into the history file. You can print out the entire bash history to the screen by running a single command, which is history. I'm running history. These are all the commands saved in history. You are seeing a list of commands in your bash history along with a number to the left of each. The command with a 1 next to it is the oldest command in your bash history, while the command with the highest number is the most recent one. And of course, the most recent command run was history. Note that running the history command does not mean listing the entire contents of the history file. There's another variable called hist_size that controls how many commands from your bash history will be stored in the memory. Let's see its value. And it's 1000. So let's draw a conclusion. Bash will save maximum 2000 commands in the bash history file, in the user's home directory, and maximum 1000 commands in the memory. These are the commands displayed by the history command. So the history command will display only half of the commands saved in the history file. Also note that the history file is updated only when the user that ran the commands logged out. I'm running the command IP address show. The command is displayed by the history. Look, this is the command, but it's not in the history file. It's not there. Now I'll log out. I'm logging in again. I'm opening the terminal again and checking the history file. And the last command is in the history file. To run a specific command from the history by its number, use an exclamation mark and the command number. For example, I want to run the 17th command from my history, and I'll type an exclamation mark and the number 17. And to rerun the last command you ran, type 2 exclamation marks. This has the same effect as pressing the up arrow once to view the previous command and then pressing enter. You can also refer to a command from a certain number of lines back in the bash history. For example, an exclamation mark and -7 would run the last 7th command. The command was rm1 and it was an error. Let's try another example. I want to rerun the who command. So, an exclamation mark, -3. And the command was executed. To search for a command in your history and run it, type an exclamation mark and the command name. For example, I want to run the last ping command, and to do that, I'll type an exclamation mark and the command. And I'm hitting enter. And it's running the last ping command. I'm pressing Ctrl+C to stop the ping. Note that this can be also dangerous because you don't know exactly how the command was executed and there's the risk of executing another command. What you can do is append :p to the above expansion and bash will print out the command to the terminal without running it. This is useful if you want to confirm that you've selected the correct command before running it. Like this. It's just printing the command. It's not running it. And if the command is correct, I can run it. Let's move on and see how to walk through the command history. Ctrl and P or up arrow are used to go to the previous command in the command history. Press the shortcut multiple times to walk back through the history. And Ctrl N or down arrow will go to the next command in the command history. Press the shortcut multiple times to walk forward through the history. Bash also has a recall mode you can use to search for commands you've previously run. Press Ctrl and R and start typing a command to search your bash history for it. I'm pressing Ctrl and R and I'm typing PI and it has found the command. When you find the desired command, you press Enter or Ctrl and P to run it. I'm pressing Ctrl and R again, type cat, and now I do not want to run the command. And I'm pressing Ctrl and G to leave the history searching mode and clear the line. I'm pressing Ctrl and G. There may come a time when you want to remove some or all the commands in your history. If you want to delete a particular command, enter history -D and the line number. For example, I want to remove this command. So history -D and the line number. The command was removed from the history. It's not there anymore. To clear the entire contents of the history file, execute history -C. The entire history was removed. It's empty. At the end of this lecture, I have a small homework assignment for you. The command history is a very powerful feature of Bash, and using it efficiently saves you a lot of time. However, there are moments when you want to run a command without saving it to history. Let's suppose you want to copy or view a file you are not supposed to, connect to another machine you are not allowed, and so on. How can you run the command without leaving any trace? Think about it, try different ways to manage that, and even search on Google for a solution. We'll take a short break, and in the next lecture, I'll show you how to do it. Let's suppose we want to run a command that shouldn't be saved in history. For this example, I'll use wget and download a file locally. And I'll download the logo image of Google. This one. Copy image location, and in the terminal, I'm writing wget and I'm pasting the contents of the clipboard. The file was saved locally in the user's home directory. This is the file. Now the admin or other users that have access to this account can see the command I've run by executing history. What can I do? If I erase the history by running history -c, it will look suspicious. Why would someone erase his entire history? If you manually edit the history file, the command that opens the file for editing will be saved in the history as well, and it's not good. This will be saved in the history. It's not good. A possible solution is to type a space in front of a command before running it in the bash shell, and the command will run normally but won't appear in your history. Let's do it both on Ubuntu and CentOS. I'm running the who command, which will display the users logged into the system. And I'm checking the history. And of course, the command is there. Now, I write a white space and the command again. And I'm checking the history. And the command was not saved. Who -a was not saved. Let's do the same on CentOS. I'm writing a white space and the command. And I'm checking the history. This time the command is there even though I've added a white space before the command name. So we see that the behavior is not the same on different Linux distributions. Let me tell you in detail how that works. There's a special variable called histcontrol that allows you to ignore commands and not save them in bash history if you set the variable to ignore space. Let's see its value on both Ubuntu and CentOS. Echo, a $, and the variable name, histcontrol. So, histcontrol is set to ignore both on Ubuntu. And now, on CentOS. Don't forget to write a $, before the variable's name. On CentOS, the variable is set to ignore dups. Let's set it to ignore space on CentOS. Histcontrol, written in uppercase letters, equals ignore space. Ignore space, written in lowercase letters. Now, I'm running a command adding a white space before its name. Let's check the history. And the command was not recorded. But what will happen if I run the same command multiple times? Will it record each command or ignore duplicates? I'm running the cd command multiple times. 5 times. And I'm listing the history. We see that it has recorded each command, which maybe it's not what we really want. Maybe you want your history a bit cleaner by ignoring duplicate commands that can clutter it. You can set the histcontrol variable to ignore dups, which stands for ignore duplicates, the way the default in CentOS is not to save duplicate commands in history. So I'm modifying the variable. Histcontrol equals ignore dups. Ignore dups written in lowercase letters. And I'm running another command multiple times. Let's see the history. It was saved only once. Now to use both the ignore space and ignore dups features, set the histcontrol variable to ignore both like is the default in Ubuntu. It will save nor the commands that are prepended with a white space, neither duplicates. Note that bash variables you set will only persist for the current session. After you log out or restart your system, the settings will be lost. To save the settings after the system reboots or the user logs out, you have to add the settings to that bashrc file in the user's home directory. We'll talk more about that when we discuss editors and bash scripting. For the moment, the easiest way for you to do that is by running echo, the setting you want to save, histcontrol equals ignore both, double greater than symbol, and the path to the file, .bash rc. This command has appended this string to the end of the file. By default, the history command will display the output as the number of the command in the history and the command. This command didn't display at what time the commands were executed. For auditing purposes, it may be helpful to display the timestamp along with the command. To solve this problem, we'll set the environment variable called hist time format like this. Hist time format, written in uppercase letters, equals, and between double quotes, the following string. %d, a forward slash, %m, another forward slash, %y, a white space, and %t, capital T. %d represents the day, %m is the month, %y the year, and %t, capital T, the time. Of course, you can format it any way you wish. Now, let's run some commands, and then the history command again. And I'm running the history command. And we see date and time information attached to each command. In your case, before setting the hist time format variable, no time information was recorded in the history, so it couldn't know at which time those commands were executed. The history command is displaying the time the hist time format was set for all of those commands. So for all commands, run before setting the variable. In my case, you see the date and time information for all the commands because before recording this video, I was playing around with the variable. If you want the setting to be persistent after system restarts or the user logs out, you need to add it in the .bash rc file. So echo the command between double quotes, two greater than signs, and the file .bash rc. Let's see the file. Okay, the setting is there. From now on, it will record date and time information for all commands. Let's talk about Linux users, one of the key concepts in Linux. On each Linux system, there are two main categories of users: non-privileged users and root, which is also referred to as the super user or the administrator. Root exists on any Linux system. Root privileges are the powers that the root account has on the system. The root account is the most privileged on the system and has absolute power over it. Among its privileges are the ability to run any command or to access any file on the system. Actually, it can do anything on a Linux system, such as installing a new software or updating the existing ones, setting up the network, changing the ownership of files, managing other users' accounts, or administering any service that's running. On the other hand, all other users, which are called non-privileged or normal users, have no special rights on the system. They can only work in a directory called user home directory and cannot perform any administrative tasks like installing new software, creating other users, or running administrative commands. Because root is so powerful, it's not recommended to use it for ordinary tasks such as browsing the web, writing emails, or documents. Even a simple mistake, like for example a mistyped command, can cause problems to the entire system. So, for ordinary tasks, it's highly recommended to use a normal user account. And when root permissions are needed, you simply become root only to perform that particular administrative task. On many Linux distributions, like those based on Debian or Ubuntu, the direct logging in as root is prohibited. Let's see how to gain root access in the terminal. There are more approaches and I'll show you all of them. The first way to temporarily become root in a terminal is to run sudo su. By the way, sudo stands for superuser_do and su stands for substitute user. It's asking for the user's password, Note that this is not the root password, it's the non-privileged user's password that ran the command. I'm entering the password, and if the password is right, and the user is part of a specific group which is called sudo on Ubuntu and will on CentOS, then a new shell with root privileges starts and the user can run their administrative commands as root. You can say that you've temporarily become root in that terminal until you log out from it. To see the user you are currently logged in, run the id command. This command brings out the logged in user and the groups it belongs to. To log out, you type exit or press Ctrl and D. Note that when becoming root, if you add a white space and a hyphen after su, then the root working environment is activated. The current working directory was changed to the root home directory. This executed all of the root user's shell initialization scripts and set all environment variables as if the root user was logged into a fresh shell session. By convention, on Linux all users prompt ends in a $sign. Root is the exception as its prompt ends in a hash. A second way to run commands as root is without logging into the root account, but by using the sudo command and the command you want to run as root. If you prefix a command with sudo, you are prompted for your password, not the root password, and if your user belongs to a specific group, sudo on Ubuntu and will on CentOS, the command will run with root privileges. Let's see how this works. I want to run an administrative command that creates a new group. If I run it simply by typing the command, I'll get a permission denied error. Only root is allowed to run the group add command and create a new group on the system. I'm simply running the command. And I've got a permission denied error. Now let's write sudo before the command name. And the command was executed successfully. A new group was created. Note that I'm not logged in as root, but as the initial normal user. I'm student. Using sudo makes it much more difficult to forget that you are root since you are not logged into the root account and you don't need to log out after you've finished your job. Let's try to run a second command as root. This time I'm gonna create a new user on the system. Sudo user add John. And you notice that the command ran as root without asking for any password, as in the first example when I ran the sudo command. That's because the sudo policy caches for 5 minutes the credentials I've entered in the first place, and anytime I run the sudo command, the timestamp is updated to 5 minutes. In this example, after I ran the sudo user add command, I could run other commands as root without being asked for any password for exactly 5 minutes. By running sudo with the -v option, a user can update the cached credentials without running a command. And if I want to invalidate the user's cached credentials, I need to run sudo -k. In other words, the next time sudo is run, a password will be required. Let's create a new user. And a password is required. The last method of running commands as root is to temporarily become root in that terminal by running the su command and entering the root password. Note that on some distributions, like Ubuntu based, this method is by default disabled because direct access to root is locked. Remember that you have installed Ubuntu in the first place without setting a password for the root account. To unlock the root account on such a distribution, you simply have to set its password. Note that not having a password doesn't mean that without it you can log in as root, but on contrary, it means that you cannot log in at all. I'm setting the root password. The command used to change a password in Linux is pa_swd. So sudo pa_swd and the username, root. It's prompting for my password, so that the command will run as root. I'm entering my password. And now the new password for the root account. I enter it 2 times. Note that on Linux, when you are entering a password, it doesn't display it. It's a security measure so that no one can find out how long the password is. Type the password even though you don't see it. Now, I can temporarily log in as root by running su and entering the root password. So su, and I'm entering the new root password. And I'm root in this terminal. This method of becoming root is available only in a terminal. You are still not allowed to log in as root in the graphical environment. On CentOS, this method of becoming root is by default available, and the root password is the one you've set at installation time. I am entering the root password. And I'm root. Note that a user can change its own password by running the password command, and root can change the password of any user by running the password command, and the username whose password will be changed. Root is changing the password of a user called student. The password shouldn't be shorter than 8 characters. That's all. You've just learned how to run administrative commands as root in Linux. At the end of this lecture, I want to clear for you that the word root has also several additional related meanings when used as part of other terms. This can be a source of confusion for the newcomers to Linux systems. Let me give you some examples. One of the most frequently met terms is the root directory, which is the top-level directory of any Linux file system. All other directories and files reside in this directory. The root directory is designated by a /. This is the contents of the root directory. Another term is /root. This is the root user's home directory. A home directory is the primary directory of a user's file, and it's actually the directory in which a user finds itself when it logs into a system. /root is a subdirectory of the root directory as indicated by the / at the beginning, and it should not be confused with that directory. This is root, and this is /root. Home directories for users other than root are by default created in the /home directory, which is another standard subdirectory of the root directory. This is where the home directories of the other users are located. Hello, and welcome to this section on the Linux file system. A file system controls how data is stored and retrieved. Without a file system, data placed on a storage medium, like a hard disk drive or USB stick, would be one large body of data with no way of telling where one piece of it stops and where another one begins. By separating the data into pieces and giving each piece a name, the data is easily isolated and identified. Before computers, the term file system was used to describe a method of storing and retrieving paper documents. Now, each group of data is called a file, and the structure and the logic rules used to manage the files and their names are called file systems. In other words, a file system is a logical collection of files on a partition or disk. Your hard drive can have multiple partitions, which usually contain only one file system. On a Linux system, everything is considered to be a file, including physical devices like a USB stick. Even a directory is also a special kind of file, and if something is not a file, then it's a process. On Linux, the structure of the file system is hierarchical. Much like an upside-down tree, the root directory, which is a /, lies at the base of the file system, and all other directories are spreading from there. Note that most of the times, the terms folder and directory are interchangeable. Directory is a classical term used since the early times of the file systems, while folder is a sort of friendly name which may sound more familiar to Windows users. a directory is a file system concept, and the graphical user interface metaphor that is used to represent it is called folder. So a folder is more like a graphical interface object. However, I think that's not such a big deal if you use them interchangeably. There's also the concept of file system hierarchy standard, or FHS, which defines the directory structure and contents for Linux distributions. Let's go to the terminal and list the contents of the root directory. This is the contents of the root directory, the /. In the file system hierarchy standard, all files and directories appear under the root directory even if they are stored on different physical devices, like on different disks or partitions. This is one of the differences when comparing to Windows file system, where there isn't such a unique file system tree. Imagine that on Windows you can have more partitions or disks which are accessed as drive letters in my computer without a common directory at the base. In Linux, there is only one file system tree under the root directory at the very top. When you want to access an additional file system, like the one on a USB stick, you need to mount it or logically attach it to an existing directory of the unique file system. That directory is called mount point. Just to make it clear, I'll insert a USB stick. If you've installed VirtualBox extension pack, you'll be able to access the USB stick in the VM. To make it available to the guest OS, in the VirtualBox window, go to Devices and then select the USB drive. This is the drive. Now it's available on Ubuntu. On most modern Linux distributions, a USB drive will auto-mount when you insert it, but sometimes you may need to manually mount the drive. We'll discuss that in a future lecture where we'll talk about the system administration. For the moment, I just want to show you how the file system on the USB drive will be mounted in a directory of the existing file system. To see the mount point, you can run df-h. This is the disk. You notice how it has been automatically mounted in /media/student, the username, and the name of the disk. You can access its contents in that directory. This is the contents of the USB disk. You can access it in the graphical environment as well. Note that there are no drive letters like in Windows. Now that you have a basic idea about the Linux file system, we'll take a short break, and in the next lecture, I'll talk about the common directories of any Linux file system. See you in a second. The Linux directory structure is well defined and documented in the Linux File System Hierarchy Standard, or FHS, which is maintained by Linux Foundation. I'm listing the contents of the root directory of /. Most Linux distributions will show you the same or a very similar layout to what you can see in the output of the ls command. Let's get started and look at what each directory is used for. You can take a look at their contents running ls. In this video, I'll show you the directories both in the terminal and in the graphical file manager. To start the file manager, search for files and open it. Go to other locations and then access my computer. This is the root directory contents. The bin directory contains binaries or user executable files which are available to all users. For example, the ls command we've just run is in this directory, along with other basic tools for copying and removing files and directories, moving them around, and so on. This is the contents of bin. As you see, ls resides in this directory. There's another directory called sbin, which is similar to bin, but it contains applications that only the super user, hence the initial S, will need. These executables are used for system administration. Some examples are ifconfig, used for configure the network adapter, or fdisk used to manipulate disk partitions. This is xcontents. The boot directory contains files required for starting the system. You normally do not touch it. Home is where you will find your user's home directories. Under this directory, there's another directory for each user if that particular user has a home directory. In this example, the user called student has as home directory the directory called student under /home. It's common for the name of the home directory to be the same as the user's name. Note that tilde is the same as the user's home directory. So if I run ls tilde, it's the same as running ls home student. In this case, tilde equals /home/student, the current user's home directory. Note that root has its home directory separated from the rest of the user's home directories and is /root. This is the home directory of root. Of course, a non-privileged user is not allowed to see the contents of this directory. Let's take a look at other directories. Dev or dev contains device files. Many of these are generated at boot time or even on the fly. This directory contains the device files for every hardware device attached to the system, like a hard disk or a partition. These are not device drivers, rather they are files that represent each device on the computer and facilitate the access to those devices. Remember that in Linux, everything is a file and the disk partition is logically represented as a special file as well. Let's take a look at this file. /dev sda1. This is a file of type device that represents the first partition of the hard disk. Another interesting and well-known directory is etc. It gets its name from the earliest Unix operating systems, and it was literally etc. because it was the dumping ground for system files the system administrators were not sure where to put. On a modern Linux distribution, it contains most, if not all, system-wide configuration files. For example, the files that contain the users and their passwords, the groups, how the network is configured, or how a network service like a web or an email server is configured are all there. As a beginner, I'd recommend you not to touch it much, and it's always a good idea to make a copy or a backup of this directory. Let's take a look at another one. lib contains shared library files used by different applications. You don't touch this directory directly. The package manager can update it accordingly when you install, remove, or update an application. The media directory is where the external storage will be automatically mounted when you plug it and try to access it. When you insert an external hard disk or a USB stick, they will be automatically mounted and made available for you under /media. And MNT is like media, but it's not very often used these days. It was the mount point for the CD-ROMs or the floppy disks. However, when you need to quickly mount a partition and don't know where, you always have /MNT available. TMP. It contains temporary files, usually saved there by applications that are running. Non-privileged users may also store files there temporarily. Note that files stored in this directory may be deleted at any time without prior notice. nproc is a virtual directory. It contains information about your computer hardware, such as information about your CPU, RAM, memory, or kernel. The files and directories are generated when your computer starts or on the fly as your system is running and things change. For example, if I want to see information about the CPU, I can run cat/proc CPU info. And it has displayed information about the CPU. Or if I want to see information about the memory, cat/proc meminfo. This is the information about the memory. Sys contains information about devices, drivers, and some kernel features, and SRV contains data for servers. You use neither sys nor SRV directly. And the run directory is fairly new, and different distributions use it in different ways. It's a temporary file system which runs in RAM, so its contents will vanish when the system reboots. This directory is used only by processes. And USR was the initial user's home directory in the early days of Unix. However, these days, /home took its place, and USR contains many other subdirectories with binary files, shared libraries, and so on. On some distributions, like CentOS, many commands are saved in /usr/bin or in usr sbin instead of /bin and /sbin. On both Ubuntu and CentOS, /bin and /sbin are symlinks to /usr bin and /usr sbin respectively. And finally, var. It contains variable length files such as logs, which are files that register events that happen on the system. Let's display the contents of a log file. cat/var/log auth.log. This file contains information about authentication tries. It's possible that your Linux distribution may have more or less directories at its root because there are slight differences between distributions. However, we've discussed here the most important and used ones. In the next lecture, we'll be talking about absolute and relative paths and walking through the file system. The basic way to explore the Linux file system is to use the cd, pwd, and ls commands. cd stands for change directory and will take you to the directory you specify as argument. For example, cd/var/log will take me to the log directory that resides in var, which in turn resides in the root directory. If you get confused, just run pwd, which stands for print working directory, and it will tell you which directory you are in. The current directory is also part of the prompt. To see the contents of any directory, run ls and the directory as argument. If you run ls without any argument, it will display the contents of the current working directory. This is the contents of /var/log. To become proficient in working with the Linux file system, which by the way is extremely important for any effective system administrator, you need to deeply understand what is a path and how to use it. In my opinion, this is one of the most important concepts a beginner should learn. Unfortunately, many times it brings a lot of confusion. Take your time to exercise how to work with paths and do not go further until you master it. Let's see what is a path. A path is a unique location to a file or a directory in the file system of an operating system. In Linux, there are two types of path names: absolute and relative path names. An absolute path is defined by specifying the location of a file or directory from the root directory, which is /. It's a complete path and always starts with /. This is, for example, an absolute path because it starts with a /. To write an absolute path, start at the root directory and go deep into the file system, writing a / after every directory name. Linux uses forward slashes to separate directory names and does not use backslashes like Windows does. Let's see some examples of absolute paths. This is an absolute path. Another one. They are absolute because they start with a /. Use the tab key for auto-completion. This will help you save a lot of time and also prevent you from making mistakes. Or cd/home, student, and desktop written with capital D. This is the desktop directory. It's similar to tilde/desktop. It's the same. Remember that tilde means the user's home directory. So /home/student. And by the way, in Linux, the desktop directory is called desktop, written with a capital D, and is located in the user's home directory. I'm creating a new folder on the desktop using the graphical interface and then displaying it in the terminal. It was created, the folder is on my desktop, and I'm displaying it using the ls command. It's there. Let's move on and see another absolute path. /var/log/boot.log. I'm displaying the last lines of a file as root. Let's go ahead and see what is a relative path. A relative path is defined as the path related to the current working directory. It begins at your current directory and never starts with a /. Before going on with the relative paths, let's understand the special meanings of single dot and double dot used in a relative path. Simply put, a simple dot represents the directory you are in, and two successive dots or double dot represents the parent directory. On a Linux system, these items are automatically created in every directory and can be seen by using the ls command with the -a option. -a means show hidden files as well, and any file or directory that starts with a dot is hidden. For example, ls-la. I have displayed the contents of the current working directory, my desktop, and we see there the current directory, the single dot, the parent directory, double dot, or tilde, this is tilde, the user's home directory, and folder 1, the directory I've just created. ls-a, tilde, I'm listing the contents of tilde, the user's home directory. And we see there both the dot and double dot. Using a single or double dot, we can build the relative path to any file or directory from the current working directory. Let's try some examples. I'm moving to /etc directory. I've used an absolute path. I'm printing the current working directory by running pwd. And it's showing as being /etc. If I want to see the contents of a file named hosts in the current working directory, I'll simply run cat or other command used for displaying files and the name of the file, like cat hosts. This is a relative path that uses the current working directory as reference. It doesn't start with a /. Another way to use a relative path to the same file would be cat./hosts. It's the same. Note that I've used a dot character to represent the current working directory, which is the default anyway, and the // is the directory separator. In other words, what I'm saying is print at console the contents of the hosts file, which resides in the current working directory, in the single dot directory. The same command using an absolute path would be cat/etc/hosts. Next, I want to see the contents of cron.daily directory using a relative path, and the command is ls cron.daily. The same command using an absolute path would be ls/etc/cron.daily. Now, I want to display the log rotate file which resides in cron.daily using a relative path, and I'm running cat cron.daily, a /, the directory separator, and the name of the file, log rotate. And the same command using an absolute path would be cat/etc cron.daily log rotate. This is an absolute path. Let's see some more difficult examples. I'm moving to my home directory using an absolute path. I could have moved to the same directory by running cd without any argument, or by running cd and tilde. In Linux, tilde represents the home directory of the current user. Keep this in mind because it's important. From that directory, I want to list the contents of the home directory using a relative path. As I said earlier, two successive dots or double dot represents the parent directory, which is /home. So to see its contents, I run ls and double dot. This is the contents of /home, the parent directory. Now, if I want to see the contents of the root directory, I run ls /. This is the contents of the root directory of /. I'm moving up 2 levels. And a really complicated one. Let's display the contents of logrotate, which resides in /etc/cron.daily using a relative path. So cat, this is the home directory, this is the forward / directory, etc, cron.daily, and the file logrotate. You notice how the relative path has changed according to the current working directory. The absolute path to that directory always remains the same. This is the absolute path. Maybe you wonder if there's any difference between an absolute and a relative path, or when to use each of them. My answer is that there's no difference. When you have to do something like remove a file or create a new directory, it doesn't matter if you are using an absolute or a relative path. It's more like a matter of convenience. If you are already in /etc cron.daily, it's more convenient to refer to logrotate using a relative path than an absolute one. It's easier to refer to the file this way than this way. On the other hand, an absolute path is more reliable than a relative one. I cannot say move to cron.daily directory by typing cd cron.daily. This is a mistake. This path is a correct one only if the current directory is /etc. If the user is in any other directory, that path will be wrong. It's correct only if the user is in the /etc directory. Another nice command you can use to get used to paths is tree. Tree is a recursive directory listing tool that helps you see easier and clearer the parent and children directories. Unfortunately, tree is not installed by default on Ubuntu. Let's install it quickly. Sudo apt install tree. It was successfully installed. If you run it with no arguments, it will display the contents of the working directory recursively, showing subdirectories and files in tree-like format. When a directory is given as argument, tree lists all the files and directories found in that given directory. Tree/etc. It's listing all the files and directories that reside in /etc. Upon completion of listing all files and directories, tree returns the total number of files and directories listed. Some useful options are -d to print out only the directories and -f to print out the absolute path for each file and directory. It's printing only the directories. It's printing only the directories and an absolute path, and it's printing both the files and directories using an absolute path. At the end, I want to stress again the importance of relative and absolute paths. Practice as much as possible and don't go ahead with the course without a very good understanding of how to use paths in Linux. Let's dive deeper into the ls command, which is probably the most used command in Linux. As I'm sure you already know, ls is used to list the contents of a directory together with lots of other information about files and subdirectories. Even though ls is a common command, it's a complex one with plenty of options. Read its help or its man page if you are not sure what a specific option does. The syntax of the ls command is as follows: ls, option, and file. As option and file are between brackets, they are optional. Let's see some practical examples. If I simply run ls with no options or arguments, it will print the contents of the current working directory at the terminal. The files are listed in alphabetical order. To list the files in a specific directory, pass the path to that directory as argument to the ls command. And if you want to have your listing produced in a single column, use the -1 option. 1 means 1 file per line. And you can specify as many arguments you want. In this example, ls will display the contents of /etc, /var, and the current working directory, which is by convention a single dot. The real power of the ls command comes from its options. Let's take a look at the most frequently used options. -l will display the output in a long listing format, which means lots of information about files and directories. This is the current working directory, and this is the contents of /etc in long listing format. By the way, if you want to see information about a directory like /etc and not about its contents, then use the -d option. It's displaying information about the etc directory and not about its contents. Let's return to the output of ls-l and let me explain to you what you see. The first character indicates the file type. A hyphen as the first character indicates a normal file. D indicates a directory, and L indicates a symbolic link, which is sort of a shortcut. The 9 characters that follow indicate the file permissions for the owner, the group owner, and the others. Then comes the number of hard links, the owner, and the group owner of the file. The next field is the size, and finally the modification time and the file name. We'll dive deeper into each concept like links, file types, and so on in the next lectures. For the moment, it's enough if you know what each field means. When you run ls, it's common to group together more options in order to get the desired output. For example, adding the age option, ls will show the file size in human readable format. Take a look at this column. It's in human readable format. By default, the ls command will not show hidden files. In Linux, a hidden file or directory is any file or directory whose name begins with a dot. To display all files, including the hidden ones, use the A option. These are hidden files, and this is a hidden directory. They all begin with a dot. Another useful option is capital S, which sorts the files by size, and the largest file will come first. Files are sorted by size. I'm adding the H option to see the size in human readable format. This is the largest file in /etc. Note that ls does not display the real size of a directory, as you'd expect. It displays only the size of the inode structure. To see the size of a directory, use the du command instead. Du comes from disk usage. In this example, ls command says that the etc directory has only 12 kilobytes, but this is not the size of all its contents. To see its size, run du -sh and the path to the directory. This is its real size. By the way, in /etc there are some files that cannot be read by a non-privileged user, and that's why I've got these permission denied errors. Run the command as root to get rid of them and see the total space occupied. So sudo and the command will run as root. There's no error, and this is its size. To sort by extension, use the -x option written in uppercase. Files are sorted by extension. And if you want to omit certain files from the listing, use the -hide option. If you don't want to see the files which end in .conf in the listing, you can run this command. ls -hide equals star.conf and /etc. The star means any string of characters, and all those files that end in .conf will be omitted from the listing. There's no file that ends in .conf. With the -r option, you can list directories recursively. Recursively means that ls works its way through the entire directory tree below the starting directory and lists the files in each subdirectory. I'm listing the contents of /etc recursively. At the end, let me tell you something that will definitely surprise you. Up until now in the course, we've never actually run the original ls command. If you run type ls, you'll see that there's an alias called ls to ls --color equals auto. The --color equals auto is the option that provides the different colors for the different file types in the listing. That's why when you run ls-l, you see directories in blue, regular files in black, symlinks in cyan, or device files in yellow on a black background. If you want to run the original ls command without adding --color equals auto, run \ls and you'll see everything displayed in black. The / character cancels the alias. Let's go ahead and talk about file timestamps. Every file on Linux has 3 different timestamps: the access timestamp, or A-time, the modified timestamp, or M-time, and the changed timestamp, or C-time. Linux timestamps hold an integer number rather than a date and time. This number is the number of seconds since the unique epoch, which was midnight on January 1st, 1970 UTC. When Linux needs to display the date, it translates that number of seconds into a date and time. This makes it easier for humans to understand. To view these timestamps, use the stat command or ls with options. The stat command is showing statistics about the file, including the timestamps. You can see the access time, the modification time, and the changed time. ext4, which is the default file system on most Linux distributions, also allocates space for a file creation timestamp in its internal file system structures. But in most cases, this hasn't been implemented yet. In this example, file creation or birth hasn't been implemented yet. That's why we see a hyphen instead. Let's discuss what these timestamps mean. The access time, or A-time, is the last time the file was read. This means the time when someone used a program to display the contents of the file. It doesn't matter if the file contents were changed or not. The modification timestamp, or M-time, signifies the last time the contents of the file was modified. If someone used a text editor and changed something inside the file, M-time was updated. And finally, the change time, or C-time, is the time when some metadata related to the file, not the file contents, was changed. For example, changing the file's permissions or the file's owner will update the changed time. To see the timestamps with the ls command, run ls-l or ls-lt if you want to see the modification time, ls-lu to see the access time, and ls-lc to see the change time. Sometimes the ls-l is not displaying the timestamp with a maximum precision. In this example, we only know the month, the day, the hour, and the minute when the file was last modified. To see the entire timestamp that was saved, this means including the year and the second, use the --full -time option, like this: ls-l, --full -time, and etc, or the directory. And we are seeing the entire timestamp. Let's talk about changing the file timestamp. This is useful when you want a backup program to include or exclude some files, or when you simply do not want other users to know that you've read or modified the file. You can change the timestamp on a file using the touch command. the touch command is also used to create an empty file. So, if the file, which is the argument of the touch command, does not exist, touch will create it. But if it exists, touch will update the file timestamps to the computer's current time. This is the contents of the current directory, which is the user's home directory. And if I run touch linux.txt, it will create the file, since the file does not already exist. The file is there. Let's see the modification time. And stat linux.txt. These are the timestamps of the file. By the way, in Linux it's not recommended to use spaces or other special characters in file names. Separate multiple words with an underscore or a hyphen. But if for some reason you want to include a white space in the file name, then enclose the file name in a pair of double quotes, like this. The file name contains a white space. Now if I run touch linux.txt again, it will update all three timestamps of the file to the current time. Touch linux.txt and stat linux.txt. These are the new timestamps. Take a look, they are updated. 14:29 and now it's 14:30. If you want to change only the access time to the current time, use the -a option. So touch -a linux.txt and stat linux.txt. Note that the access time was updated to the current time. The changed time was also updated because metadata information of the file, like a time, was changed. This is normal behavior. To change the modification timestamp, you can use the -m option, touch -m and the file, and stat linux.txt. See how both mtime and change time were modified. If you want to set the access time or modification time to a specific time, not the system current time, you can use the -t option and a date time. Let's change the modification time to a date in the past. Touch -m and the date. Let's say 2018, 12 the month, 30 the day, the hour, the minute, and that the second. And the file. The format of the new timestamp is year, month, day, hour, and that seconds. Sorry, I've forgotten the -t option. This is very important. And the modification time was changed. If you want to change simultaneously both access and modification time, use the -d option like this. Touch -d, between double quotes a date, in this format, and the file. Both a time and m time were changed. Note that -d and -t options accept different time date formats. You can also use the -r option if you want to set the timestamps of one file to the timestamp values of another one. For example, I'm creating a new file, ubuntu.txt. These are its timestamps, and I'm setting the timestamps of linux.txt to the timestamps of ubuntu.txt. So touch linux.txt -r ubuntu.txt. Ubuntu.txt is the reference file, and stat linux.txt. They have the same timestamps. Note that it's not possible to modify only the changed time to a specific timestamp, but I'll tell you a trick. If you want to modify only the changed time to a specific time, then you set the system date and time to the desired changed time, run the command touch and the name of the file to change all the timestamps to the system current time, and then change back the access and modification times to the initial values. Changed time will remain at the desired value. You can do this as homework. Use the date command to both display the current date and time and set the system date and time. This is the date and time using the local time zone, East European time, and date -u is displaying the date and time using the coordinated universal time or UTC. Check Xmod page to see the format of the new date if you want to change it. Let's talk about sorting the output of the ls command by timestamp. This is a common task. By default, the ls-l command is showing the modification time, this is the modification time for each file, and sorting the output by name. And the ls command is listing the files in alphabetical order. If you want to sort by modification time, add the -t option. It will display the output sorted by modification time, newest files first. They are sorted by modification time. If to -lt option you add the -u option, then it will sort by and show access time. X sorting by and showing access time. The same option -u with L will show the access time and sort the files by name. This is the access time and the files are sorted by name in alphabetical order. If you want to reverse the order of sorting, add the -r or -- reverse option like this. -r or -- reverse. X showing and sorting by access time in reverse order. Note that you can group -r with other options, or use the long option format instead. In Linux, the file is a central key concept. When administering a Linux system, you have to deal with lots of files, and knowing their type is really important. In this lecture, we'll see what type of files are available. Linux determines the type of a file via a code in the file header. It doesn't depend on the file extension. In fact, it's quite common in Linux for files to not have any extension at all. These are only a few examples of important system files that do not have an extension. The shadow file, which stores the user's passwords, the group file, which stores the groups, and many more. They have no extension. Also, all executable files or commands do not have extensions. These executable files have no extension. In Windows, they would be .exe files. This is one of the differences between Linux and Windows. In Linux, file extensions do not matter so much. They are mostly for humans to find out visually what a specific file could represent. When you see a file name which ends in .log, then it's probably a log file, or a file which ends in .conf, it's probably a configuration file. This is probably a configuration file because it ends in .conf. I want to give you just one example that shows that extension doesn't matter. I have this image on my desktop and I run file and the path to the file to see its type. So file, desktop, linux.jpg. And it's a JPEG file. Now I'll rename the file to change its extension to PNG. The source file, linux.jpg, and the destination. This is how you rename a file in Linux. We'll have a dedicated lecture on this. Now it's a .png file. If I run the file command again, we'll see that the file type remains the same even though I've changed its extension. File and the path to the file. It's of type JPEG, image data. It's not a PNG file. Linux determines the file type via a piece of information in the file header. However, graphical applications might require the file to have a specific extension in order to open it. If you have a text file and change its extension to JPEG, then you cannot open that file anymore by double-clicking with the mouse on it. If I rename the file again and write .txt and try to open the file using the graphical environment, using a graphical application, it won't work. So extensions are useful only for graphical applications. It still contains JPEG image data. Let's take a closer look at the output of ls-l command, which is one way of finding what type a specific file is. This is indicated by the first character. If you see a hyphen, it means that's a regular file. -d indicates a directory, which is a special type of file. I'm listing the contents of /etc. -l indicates a symbolic link, which is like a shortcut, and other possible characters and file types are B, which means a block device. For example, ls-l/dev/sda1. This is a block device. And C indicates a char device. All of these files are of type char device. Device files represent logical hardware devices like a disk, a partition, or a serial console port. If you see an S, the file is of type socket. This is a socket. S on the first position. This is used by processes to communicate and has nothing to do with the socket term used in TCP/IP networking. And the last possible option for the first character is a P, which indicates a named pipe. Let's find a named pipe. This is a named pipe. The first character is P. Named pipes aren't used all that often. It's possible that you won't use them explicitly at all. However, a named pipe, like a socket, provides an easy way for the processes to communicate. Using named pipes, you could send the output from one command to another and end up with only the data you want to see without selecting and formatting the entire output. Another way to classify a file is to run ls with the capital F option. This will add a symbol after the file name according to its type. A / indicates a directory. No symbol added indicates a regular non-executable file. An @ sign indicates a symlink. And an equal sign indicates a socket. And a pipe, a vertical bar, indicates a named pipe. And if you find all of this confusing, you can run the file command to find out the type of any file. Note that none of the methods shown in this lecture determine the file type based on the file name extension. Let's see some examples with the file command. This is a directory. This is a regular file, an ASCII text file. By the way, -f will add a star, an asterisk, to executable files. Let's see a symlink. This is a symlink, so file /etc vtrgb, symbolic link, and file /run and an asterisk will show information about all the files in a directory. This is a socket, this is an empty file, this is a named pipe, this is a directory with the sticky bit set, and so on. The entire configuration of the Linux system is saved in text files. User accounts and their passwords, groups, the network configuration, the security policy, the configuration of any network service like a web, FTP, or an email server are all saved in text files. In this lecture, I'm going to show you different ways to read text files on a Linux system. Of course, there's always a graphical text editor if you have installed a graphical interface. For example, both on Ubuntu and CentOS, we have the gedit editor available. To open it, click on Show Applications, search for Editor, and open the text editor. This is gedit. You can edit any file, like you do with the Windows Notepad. However, since most of the administration work is done in the terminal, I want to show you what commands are available for viewing text files. The cat command is probably the most used one when reading files in Linux. It just displays the contents of the file in the terminal window and provides the prompt again. Let's see an example. cat/var log auth.log. This is a log file, and it has displayed the file contents on the screen. The syntax of the cat command is cat and the name of the file you want to see using the correct absolute or relative path. If you want, you can give more files as arguments, and cat will display all of them in the terminal. Let's display two files. Cat etc password etc group. It has displayed both files. This is the first one and the second file. When running the cat command, you don't usually specify any option. The single option I've sometimes used was -n to print out the number of the line as well. Cat -n etc password, and the line number was printed as well. Please note that cat shows the entire file at once. It's not interactive, and if the file is too long, the contents scroll off or exceed the screen. Like in this example, we don't see the entire file on the screen. For this reason, cat is the tool of choice when you want to display small files, like for example etc hosts. This is a small file and its entire contents fit the screen. Cat is short for word concatenate, so besides displaying the contents on the screen, it's also concatenating more files into a single one. Let's see how it works. I'm concatenating two files into a single one. Cat, the first file, etc hosts, the second file, etc host.conf, the greater than sign, and the resulting file. Let's see my host.txt. This was the first file, the second file, and the resulting file. The resulting file that was created contains the contents of both files. Let's take a look at the command that has concatenated the file again. This one. The greater than sign means output redirection and is used to redirect the output of the command to a file instead of printing it on the screen. So instead of printing the contents of the file on the screen, it redirects it to a new file which is created if it doesn't exist or overwritten if it already exists. In this case, the file was created. We'll have an entire lecture on command redirection later in this section. If the output of a text file exceeds the terminal window, you probably want to use the more or less commands instead of cat. Both tools are known as pagers and will take the input from a file and send it to the terminal one page at a time. Less extends the capabilities of more and is probably the most advanced and used reading tool that Linux provides. To view the contents of a file with less, you write less and the name of the file using a correct path, like say less/var log dmessage. This is the contents of the file. I've already discussed some rules and options when we've talked about man pages in the previous section of the course. When you run man and the command to see its man page, less is launched by default. For example, man rm, and the contents of the man page is displayed using less. Let's see the most important and used options again. While you are in a file, you can get additional help by typing the letter H. To exit the file, type Q. I'm opening it again. While in the file, you can use the arrow keys to move a line up or down. To forward one window, press on Ctrl and F or on the space key. I'm moving one window forward. And if you want to move backwards a screen or a window, you press Ctrl B. I'm moving backwards. I'm already at the beginning of the file. To go to the very beginning of the file, type lowercase g, while to go to the very end, type uppercase G. I'm at the end. Sometimes you want to search in the current file for a specific string. Let's say I want to search for the root string in this file. First, I'm going to the beginning of the file by pressing G. I'm at the beginning. And to search for the string, I write a / and the string I want to search for, root. And I'm hitting enter. Any matches in the current file will be highlighted. You can then navigate between matches with N, which means next occurrence, next, or Shift N, or uppercase N, which means the previous occurrence. So it searches backwards. I'm pressing capital N. This is the first occurrence. When you search by using a / and the searched term, it searches forward. But if you are, for example, at the end of the file and want to search backwards, then you type a question mark instead of a /. I'm going to the end of the file by pressing uppercase G, and I'm searching for the word kernel backwards. I'm hitting enter. It has searched backwards for the kernel word and it found more matches. Press on N and uppercase N to go from match to match. Backwards and forward. These were the most important options of less. Another useful command used for viewing files is tail. Using tail, you can view the last lines of a file, and by default it shows the last 10 lines. Tail etc password. These are the last 10 lines of the file, so the last 10 users. If it seems too basic, imagine that you are most of the time interested in the last events that took place. For example, the command I've just executed has shown the last 10 created users. Tail has several options that can be used to get the desired output. If you want to read a custom number of lines of a file, use -n and the number. For example, I want to see the last two groups that were created, tail -n2 and the path to the file, etc group. This is where the groups are saved. And these are the two groups that were created. Or, if I want to read the last lines starting with a specific line number, then I can use a command like this, tail -n plus 20 and the path to the file. For example, var log syslog. It will display the last lines of the file starting with the line number 20. So from line 20 to the end. Tail is really useful for reading a file in real time, like when you want to view the last n lines of a log file for important system messages. You use tail to watch log files as they are updated. Using the -f option, tail automatically brings new messages from an open file to the screen in real time. For example, to actively watch as users log in and out, I'll run the following command. Tail -f and the path to the file where authentication tries are saved. /var log auth.log. These are the last 10 lines of the file, and the contents of the file will be updated in real time. And in another terminal, I will log in into a shell as root. So sudo su. I'm entering the wrong password on purpose. See how tail has updated the file in real time. We can see the authentication failure message. The user student couldn't become root. Now I'll authenticate successfully. And this is the message. Session opened for user root by student. Student to root. When you are finished with tail, press Ctrl and C. The last command I'm gonna show you is head. It's the complementary of tail command, and as the name implies, brings the top n number of lines from a given file. Head is used to display the beginning of a file. head etc password. By default, it reads the first 10 lines of a file, so the previous command has printed out the first 10 users. You can change the number of lines displayed by specifying -n and the number, or simply the number of lines you want to see. Head -n3 /etc group. These are the first 3 groups. Or head -7 /etc group. The first 7 groups. And at the end, I'll introduce you to another Linux command which has nothing to do with viewing files, but could be very useful. If you want to run a command repeatedly, displaying its output and error, you use the watch command. It allows you to watch the program output change over time. I'm running ls repeatedly. Watch ls. This is the contents of the current working directory, the user's home directory. By default, the ls command is run every 2 seconds, and watch will run until interrupted. To interrupt it, hold Ctrl and press C. So Ctrl and C. Two interesting options are -d to highlight the differences between successive updates and -n and the number to specify the update interval. I'm running the ls-l command every 3 seconds, highlighting the differences. So watch -n3 -d ls -l. And in another terminal, I'm creating a file in the same directory. Touch abc.txt. See how it has highlighted the differences between updates. In the last example, I want to see how packets are sent and received by executing the ifconfig repeatedly. Watch -n1 -d ifconfig. I'm closing this terminal. You can generate some network traffic to see it clearer. I'm opening the Firefox browser and visit some websites. Okay, see the differences. See how the number of received and sent packets is updated. In this lecture, I'm gonna show you how to create new files and directories. To create a new file in Linux, you have to use the touch command. We've already discussed it in a previous lecture, so now we'll just recap it quickly. The touch command takes as argument 1 or more files. If those files already exist, touch will update the file's timestamps to the current system time. But if the files do not exist, then touch will create them. Touch report.txt. Touch logs. Since the files didn't exist, touch has created them. If I run it again with the same files as arguments, then touch will set the file's timestamps to the current time. Let's see the timestamps. These are the file's timestamps. And I'm running the touch command again. Touch, the first file, and the second one. And stat report.txt and logs. See how it updated the A time, M time, and C time. Note that you can change A time and M time individually as well. See the previous lecture where I've gone deeper into this if you feel the need. And if you want to create a new file that contains a white space in its name, then put the whole name between double quotes. So touch in user's home directory, it's the current directory anyway, and between double quotes, learning Linux. This is the name of the file. It contains more white spaces. However, Linux is not recommended to have file names that contain white spaces. Use an underscore instead if you wish a more readable name. So a more appropriate name would be something like this. Much better. Also remember that in Linux, case matters. So a file called report.txt, which starts with a capital R, is a complete new file. Or touch report.txt. there are 3 files called report.txt in the current directory. Only the capitalization differs. It's important to note that the user executing this command must have enough permissions to create the file in the parent directory, or he will get a permission denied error. For example, I'm logged in as student, a non-privileged user, and if I try touch /etc abc, I've got a permission denied error. This non-privileged user is not allowed to create the file called abc in /etc. Let's move on and see how to create new directories using the mkdir command. Mkdir comes from make directory. This is the command, and its syntax is mkdir, some options, and some directories. Let's see an example. In the current working directory, I'm going to create a directory called dir1. mkdir dir1. This is the new directory. In case you want mkdir to display some details about the operation it's performing, then add the -v option. -v comes from verbose. mkdir -v dir2. It has displayed this message and created the directory. And if you want to create more directories in one command, then give all directories you want to create as arguments. So mkdir dir3 dir1 /dir10, it means it will create a new directory called dir10 inside dir1, and /tmp tmp_dir, the third directory. In this example, I've created 3 directories at once. dir3, dir10 inside dir1, and another directory inside /tmp. Now, let's suppose I want to create a complete directory structure, and to do that I run mkdir, let's say first, second, third. So I want to create a new directory called first in the current directory, inside first another directory called second, and inside it a directory called third. Note that none of these directories exists. If I'm hitting enter, I'm getting an error. Cannot create a directory, no such file or directory. Maybe it's weird, but mkdir wanted to create the directories from right to left. So when it wanted to create the directory called third, this one, it noticed that its parent directory called second didn't exist. To solve this issue, just add the -p option, which comes from parents, and it will make the parent directories as needed. I'm adding the -p option between the command name and its arguments. And it has created all 3 directories. See how they look like. -p option is also good when the directory already exists and you don't want an error. In this example, there's already a directory called dir1 in the current working directory. I've just created it. If I try to make it again, I'll get an error. mkdir dir1. Cannot create directory dir1, file exists. Remember that a directory is a special type of file. But if I add the -p option, there will be no error. Okay, that's all about creating files and directories. Thank you. Let's move on and see how to copy files and directories using the cp command, which stands for copy. cp has 3 principal modes of operation depending on the number and the type of arguments passed. If the command has 2 arguments of type files, it copies the contents of the first file to the second file. If the second file does not exist, cp will create it. But if it already exists, cp will overwrite the destination file. I'm copying the password file from /etc directory to another file in the current working directory. So cp /etc password /users.txt. The destination file users.txt doesn't exist, so it will create it. This is the file in the current working directory. Now I'm trying to copy another file to the same destination. Copy etc group users.txt and cat users.txt. There's another content. The user.txt file already exists, so it has overwritten the file without prompting. To show files that are being copied, pass the -v option to the cp command. This brings the files and folders that are being copied to standard output. I'm running the last command again, this time passing the -v option. As usual, -v comes from verbose. And if you want it to prompt before overwriting, add the -i option. Let's run it again without any option. The users.txt file already exists and it's not prompting. This is the default behavior. But if I add -i, it will prompt. For beginners, what is the most important and difficult at the same time is to use the correct path for both the source and the destination. Always use the tab key for autocompletion. The second mode of operation is when cp has one or more arguments of type file, which is the source, and the last argument of type directory, which is the destination. In this case, it copies the source files to the destination directory, creating any files that do not already exist in the destination. Let's see an example. cp learning_linux logs users and the destination. The destination will be the directory called first. It will copy these three files to the destination directory. Add the -i option, which comes from interactive, if you want it to prompt before overwriting the destination file if it already exists. It's not prompting, and now it will prompt. And the third and the last mode of operation is when all arguments are of type directory. In this case, cp copies all files in the source directory to the destination directory, creating any files or directories needed. This requires -r, an option that indicates the recursive copying of directories. Let's see an example. sudo cp-r/etc /desktop. This command will be run as root because I'll copy the etc directory to my desktop. A non-privileged user is not allowed to read some of the files in the etc directory. Look how a directory called etc has appeared on my desktop. And of course, without the -r option, I would have got an error. It's not allowed to copy a directory without specifying this option. Let me show you one last example. Consider this file called users.txt, which belongs to the user student. Student is the file's owner, and another user that has read access wants to copy that file. I'll copy the file as root, so sudo cp users.txt u.txt ls-l. This is the new file. What do you notice? When copying a file, the user that runs the cp command becomes the file's owner, and that's not good in some cases. To preserve file attributes, permissions, group, and user ownership, pass the -p option, which stands for preserve. By default, the permissions, ownership, and timestamps are not preserved. I'll copy that file again, this time adding the -p option. Let's say u1 and cp-p. Pay attention to these three files. The permissions, owner, and timestamps were preserved for u1.txt because I've used the -p option. In this video, I'll be showing you how to move and rename files and directories in Linux. We'll talk about the mv command. The mv command is a command line utility that moves one or more files or directories from one place to another. This command has two distinct functions. It moves files and directories, or it renames files and directories. Yes, there's no mistake. You can use mv both for moving and for renaming files. Before starting with an example, I will delete all the files and directories that I've created in the last lecture in the user's home directory. Now I'm creating a new directory tree structure for this lab, mkdir -pdir1 and dir2 inside, and I'll create a file in each directory. So touch dir1 a.txt, dir1 dir2 b.txt, and c.txt in the current working directory. Let's move a file into a directory. I'm moving b.txt, which is in dir2, to dir1. So mv, the path to the file, dir1 dir2 b.txt, and the destination path, the destination directory, dir1. The file was moved. Let's see how to move multiple files into a directory. For this, I'm gonna specify all the files I want to move as arguments, and the last argument will be the destination directory. mv c.txt in the current working directory, dir1 a.txt, dir1 b.txt, and the destination will be dir1 dir2. So in fact, I'm moving all these three files into a directory called dir2, into this one. Sorry, 3, dir1. The files were moved. You can also use a pattern matching like this, mv dir1 dir2 star.txt dir1. I'm moving all the files which end in .txt from dir2 to dir1. And if you want to move a directory, you move it as you would any other file. I'm creating a new directory, mkdir dir1 dir2 dir3. And I'm moving dir3 into dir1. So mv, the source, dir1 dir2 dir3, and the destination. dir3 was moved. Now it's in dir1. Now let's see what happens if the destination file already exists. I'm creating a new file called a.txt in dir2. Touch dir1 dir2 a.txt. This is a new file. And I'll move it to dir1. So mv dir1 dir2 a.txt dir1. a.txt will be moved from dir2 to dir1. And the file was moved and the destination was overwritten without prompting. To prompt before overwriting a file, the -i option can be used. -i comes from interactive. I'm creating a file called a.txt in dir2 again. And I'm moving it. And it's prompting. I'm pressing Ctrl+C. I'm aborting the operation. To prevent an existing file from being overwritten, use the -n option. This causes the mv command to ignore anything that would overwrite an existing file. I'm creating a file called a.txt again. And now I'm running mv -n dir1 dir2 a.txt dir1. It didn't move the file because the destination already existed and it would have overwritten the file. Another useful option is -u or --update. When using this option, it will move only when the source file is newer than the destination file or when the destination file is missing. This guarantees that only newer files will be moved. This is especially useful in shell scripts. In dir2, I'll create a new file called b.txt. Touch dir1 dir2 b.txt. And mv -u dir1 b.txt, dir1, dir2. I want to move the file called b.txt from dir1 to dir2. And there's already a file called b.txt in dir2. I've just created it. What do you think? Has it moved the file? Let's check it. And b.txt was not moved. It's still in dir1. That's because b.txt is not newer than the destination. As I said at the beginning of this lecture, mv can be used to both move and rename files. If the source file is in the same directory as the destination file, then mv will rename it. I'm renaming a.txt from dir1 to abc.txt. So mv dir1 a.txt and the destination dir1 abc.txt. The file will be renamed. The source and the destination directory is the same. It was renamed. And you can rename a directory in the same way. I have renamed dir1 to dir10. And the last example, you can even move the file to a different directory and rename it at the same time. I'm moving c.txt from dir10 to dir2, renaming it at the same time. mv, the source, dir10 and c.txt, and the destination, dir10, dir2, and the new name of the file. Let's say cc.txt. The file was moved and renamed at the same time. That's all about the mv command. Thank you. Now that you know how to create files and directories, how to copy, move, and rename them, it's time to see how to remove them. In Linux, to remove files or directories from the command line, use the rm command. Be extra careful when removing files or directories, because once the file is deleted with the rm command, it cannot be easily recovered. There isn't such a concept as a recycle bin or trash for the files that were removed from the command line. To remove one or more files, give them as arguments to the rm command. I'll remove this file, abc.txt, and a.txt from dir2. So rm, the first file, I'm using a correct relative path, dir10 abc.txt, and the second file, dir10 dir2 a.txt. Always use the tab key for auto-completion. I'm doing it myself as well. Note that the files were removed immediately without prompting. To prompt for confirmation when removing a file, use the -i option. It's the same option we've seen at cp and mv commands and comes from interactive. It will cause rm to ask for confirmation. If confirmation is given, the file is removed. And if it's not given, the file removal is skipped. Let's try to remove b.txt from dir2 using the -i option. rm -i and the file dir10 dir2 b.txt. And it's asking for my confirmation, and I want to remove it. To show more information when removing a file, add the -v option, which comes from verbose. rm -v dir10 b.txt. I'm removing this one. And it has displayed a message about what it did. Let's see how to remove directories. If you try to remove a directory as you would a file, you'll get an error. rm dir10. Cannot remove dir10 is a directory. To remove directories, use the -r or ---- recursive option to make removal recursive. So, rm -r dir10. Sorry, -r, not -f. If you try to remove a write-protected file with rm, by default it will prompt for a confirmation. As root, I'm creating a new file in the current working directory. This file belongs to root, but the student user is allowed to remove it because it's in its home directory. rm a.txt. and it's prompting for my confirmation. Remove write protected regular empty file, yes or no. And it was removed. Just imagine that you have to remove hundreds of files from a directory and you have to confirm each removal. It's impractical. To force removal and not receive a prompt, press the -F option. -F stands for force, like rm -rf music and pictures. I'm removing two directories that are in my current working directory, and they were removed. Sometimes it's common to combine R and F together to remove both files and directories without a confirmation, like I did in the last example. I'd like to say a little bit more about this command. If you run it as root and make a mistake, then your files are gone. You cannot recover them. As I said before, there isn't such a thing as recycle bin, a trash, or the undo remove command. To stay in the safe zone, my advice for you is pay special attention when removing files as root and always, but always use tab for autocompletion. Let me show you an example of why you should do that. Let's suppose that as root, you want to remove an ordinary file from the user's home directory. I'm creating a file and I want to remove it as root. So sudo rm -rf and the path to the file. So /home student a.txt. I'm using an absolute path. Maybe the root user is not in the user's home directory, so in /home/student. Of course, I have used the tab key for autocompletion. But suppose you say that it's not necessary to use tab for autocompletion because you can write quite fast anyway. And by mistake, you write a white space after /home, like this. There is such a probability, especially if you do it often enough. What will happen is that the rm command will consider that it has two arguments, /home, the first directory, and then another file called a.txt, which resides in a directory called student, and will try to remove them both. Such a mistake is disastrous, because it will remove the entire /home directory. This one. Such a mistake could be avoided by always using the tab key. If you, by mistake, type a white space somewhere in the path, then tab will not complete the path. I'm pressing tab and it's not completing the path. There's a mistake. My second advice is to pay special attention when using pattern matches and wildcards like asterisks, ducks, or question marks. This is also applicable to other possible destructive commands, not only rm. Before running a command like rm *.txt, execute echo and the pattern to see exactly what are the files that will be matched. Sometimes these patterns expand in names you don't expect to. So before executing this command, execute echo and the pattern to see which files will be matched. And it's okay. There's a file called a.txt, a single file. At the end, I'll tell you something really important. The rm command does not actually delete a file. Instead, it unlinks it, meaning the data is still on disk. The space on disk occupied by the deleted file is marked as being free and can be used by other file or process. Now, depending on different factors, there are professional solutions that make the recovery of the deleted files possible. This is available to any other operating system, including Windows, Mac, or Android. So, if you remove a file, you can't be 100% sure that no one will ever recover it. This is, for example, just a free tool that can recover deleted files. You can try it on Windows. What you can do is use the shred command instead. Shred overwrites a file to hide its contents many times before removing. Let's see an example. I'm copying the password file from /etc to the current directory. And shred -vu -n 100 and the file. Great. -v means verbose, or showing the process, and u means removing the files after overwriting. and -n and an integer number overwrites the file n times instead of the default, which is 3. The file was overwritten with random contents before removing. In my opinion, even though shred is good enough in the secure removal of files, if you want to keep your confidential data secure, you have to encrypt it. You cannot rely on simply deleting a file and suppose that no one could ever recover and access it. In this lecture, I'll be talking about pipes, which are one of the most useful command line features in Linux. Pipes are used in countless ways and are just about everywhere. The Unix and Linux design philosophy is to have many small utilities that perform very well just one dedicated function without needless functionality. In Linux, you write programs to do one thing and to do it well, and then you make them work together. Let's take a look at this image. Every command or program we run has 3 data streams connected to it. stdin or standard input, which represents data fed into the program or the data the program is working with. stdout or standard output, which is data printed by the program by default to the terminal, and stderr or standard error for error messages and also defaults to the terminal. Using the pipe symbol, which is a vertical bar, we can connect 2 or more commands at a time. This supports the initial Unix philosophy of chaining programs together to complete complex tasks. So a pipe lets us send the output of one command as input to another one. Piping and redirection are the means by which we may connect these streams, input, output, and error, among programs and files to direct data in interesting and useful ways. Let's take a look at this mechanism. I'm running ls -l capital S h /etc. The command has listed all files in the etc directory sorted by size in human readable. There are lots of files, and I finished up seeing only the last ones, the smallest files. The largest ones are at the beginning, and I have to scroll to see them. What I could do is connect the ls command with the head command. Using a pipe, I'll send the output of the first command, which is ls, as input to the second command, which is head, like this. Pipe, head. And we are seeing only the head, or the first 10 files of the output, and those are the largest ones. It's common and recommended to add a white space before and after the pipe symbol. But that's not, however, mandatory. This isn't an error. We can pipe together as many commands as we wish. In the next example, I'll filter and display only the 20th file of the output. It's just an example to see how it works. So head -n20, pipe, tail -n1. This is the 20th line of the output. Let's take a closer look. The output of the ls command becomes the input for head, which will display the first 20 lines. These first 20 lines, which are the output, are fed as input into the next command, which is tail, and the tail command will display only the last one, which is in fact the 20th line of the output. So the pipe takes the output from one command and uses it as input for another one. And the last example, I want to find out how many authentication failures took place. There isn't such a command in Linux, so I have to build my own using pipes. First, using cat, I'm displaying the entire file. Cat var log auth.log. This is the file where authentications are saved. This is the file. I can also add a -n to see the line numbers. Then, the output of the cat command will be given as input to another command called grep. Grep is a command line utility that searches for a string inside a file or a text and displays the lines containing the string. So pipe grep -a and the string I'm searching for. authentication failure. And there are some matches. There are more lines that contain the string. These are all authentication failures. And finally, I want to see how many lines were found. The output of the grep command will be given to another command called wc, which counts how many lines were given. So pipe wc minus l. And it returned 6. So there were 6 authentication failures saved in the log file. Let me tell you a few words about wc, which is short for word count. It brings new line, word, and byte counts for each file. wc etc password. There are 48 lines, 83 words, and 2825 characters in that file. This command is used to get different statistics. I've just found out that there are 48 accounts on the system. If you only want to see the line counts, then use option -l, wc -l etc group. There are 76 groups on the system. wc -w will display only the word counts and -c only the character counts. So wc -w, USR, share, dict, American English. This is a standard dictionary that you'll find on Ubuntu. And there's this number of words in this American English dictionary file. Let's see how many characters are in the file. And there are almost 1 million characters in the file. You can also use it with a pipe. Let's see how many users are logged in. Who is displaying? The logged in users. So who? Pipe wc -l. There's only one user logged in. One of the main purposes of piping is filtering. You use piping to filter the contents of a large file to find a particular string or a word. For example, note that when you use a pipe, you are not running a single command, but each command in the pipe starts. So, in this example, in this one, I've started 3 processes, each command starting a process: cat, grep, and wc. Take your time to exercise and deeply understand how pipes work, because this is a key concept in Linux and you'll find it everywhere. The pipe is one of the most used shell features. We'll continue our discussion and see how to redirect a command output to a file. A short recap. Every command you run has 3 data streams connected to it: stdin or standard input, stdout or standard output, and stdrr or standard error. Normally, when you run a command, we want to see the output on the screen in the terminal. This is convenient most of the time, but sometimes we may wish to save it to a file to keep it for the record, feed it into another program, or send it to someone else. To redirect the output of a command to a file, there's the output redirection operator, which is the greater than sign. It indicates to the command that we wish the output to be saved in a file instead of being printed on the screen. Let's see an example, and we'll start with a simple one. I'm running the ls command, which, as expected, has printed out the output on the screen. Now, I'm gonna use the output redirection to save it to a file. ls-l greater than ls.txt. Let's talk about what has happened. The greater than sign, which is the output redirection operator, has redirected the output to the file instead of printing it on the screen. See how a new file called ls.txt was created in the current working directory. And you notice that we didn't have to create the file before saving it. It has been created automatically. If I display its contents, I'll find there the output of the ls command. Now, let's see what will happen if we redirect it again to the same file. I'm redirecting the output of another command to the same file. I'll redirect the output of ifconfig. So ifconfig greater than and the name of the file. And I'm listing the file contents. cat ls.txt. And we notice something very important. The file was overwritten. The output of the first command is not there anymore. So you can draw a conclusion. When using the output redirection, we'll have two case scenarios. The file is created if it doesn't exist, or it is overwritten if it already exists. If we don't want to overwrite the file, we can instead append or add to the end of the file by using the double greater than operator. Let's run the same commands again. ls-l greater than, so output redirection, output.txt. And ifconfig double greater than output.txt and cat output.txt. This is the file's contents. We see the output of both commands. The output of the second one was appended to the file. This is a big difference and it's important. Let's see another example. Who, double greater than operator, and users.txt. Of course, that file didn't exist. So, the double greater than operator creates the file if it doesn't exist, or appends to it if it already exists. Up until now in the course, I said many times that everything is a file in Linux or is treated as a file. To emphasize this concept, I'll show you how even the terminal is treated as a file. To see the file behind a terminal, run the tty command, tty. And we notice the file. This is the file. It's called 0 in pts directory, which resides in dev. I'm opening another terminal and I'll redirect the output of a command to the file that represents the other terminal. For example, ifconfig greater than /dev pts and 0. Very nice. We see how the output of the command was written to the file that represents the terminal and appeared in the first terminal. This is like a basic instant messaging, like this: hello, how are you? The string appeared in the other terminal. By the way, the echo command simply displays a line of text. Let's go ahead and talk about error redirection. The three streams attached to any Linux command actually have numbers associated with them. You see the numbers between parentheses. stderr, or standard error, is stream number 2, and we use these numbers to identify the streams. If we place a number before the greater than operator, then it will redirect that stream. If we don't use a number, like we have been doing so far, then it defaults to stream 1, which is standard output. Let's see some examples. I'm running a command which will return an error. tail -n3 /etc shadow. Permission denied. A non-privileged user cannot see the file. To redirect the error message to a file, I'll use to, which is the ID of stderr, and the greater than operator. So to, greater than, and the file. error.txt. It's not allowed to put any space between to and greater than. This is not allowed. And cat error.txt. We notice how the error was redirected to the file, which was also created because it didn't exist. In fact, the same rules from the output redirection apply to the error redirection as well. If you want to append to the file instead of overwriting it, use to and the double greater than sign operator. I'm executing the same command again, this time using to and double greater than sign. Like this. And cat error.txt. The error message was appended to the end of the file. This is another error, to double greater than error.txt. It was appended to the file. It's also possible to redirect both the normal output and the error messages of the same command. The same command could produce both normal output and errors. For example, tail -n2 etc password, and the second file, the second argument, etc shadow. It has printed the last two lines of the first file, these are the lines, but an error for the second file. It's not allowed to read the file. And I'm redirecting the output to a file called output.txt and the errors to error.txt. The files were created or overwritten. This is the output and this is the error. Okay, in the next example, I'll show you how to redirect both standard output and standard error to the same file. What I'll do is redirect standard output to a file and standard error to standard output. So, I'm running the command again. This is the command. I'm redirecting the standard output to output.txt and standard error to standard output. &1. 1 being the ID of standard output. Cat output.txt. Note that the file contains both the output and the errors. One remark here. We've redirected to a stream by placing an ampersand in front of the stream number. Otherwise, it would have redirected to a file called 1. Now, the standard error was redirected to a file called 1. So this ampersand here is very important. You can also combine command redirection with pipes. Let's take a look at an example. Let's filter the line that contains the MAC address using a pipe. So ifconfig pipe grep ether. This is the MAC address, and I want to see the lines that contain the string ether. Great. We are seeing the output, and I'll save the output to a file greater than mac.txt. The output of the command was saved into a file instead of printed in the terminal. By the way, if you just want to get the MAC address without extra strings, you could try. I'm using a second pipe, cat -d, a space between double quotes, -f10. This is the MAC address, and I'm redirecting it to a file. By the way, I have introduced a new command which is cut. It cuts out sections from each line using a field delimiter, in this case a white space, and the section or the field number to cut. In this example, it was 10 because there are 10 white spaces till the field I wanted to cut, which was the MAC address. Just to get used to the cut command, you can try another simple example. Let's consider the password file. And I want to cut the first field, which represents the users, using a colon as a delimiter. So cut -d colon -f1, the first field, and the file. And we see only the users. Or I'll cut the user ID, which is the third field. Okay, let's go ahead. What can we do if at the same time we want to store and view the output of any command? If I use the redirection command, the output will be redirected to a file without displaying it in the terminal. For example, who greater than users.txt. I'm not seeing the output. Here comes into play the T command. Its name comes from the T-splitter used in plumbing. It basically breaks the output of a program so that it can be both displayed and saved in a file. Let's see an example. ifconfig pipe grep ether. This is displaying the output only on the screen. And this command is saving the output only to a file. I want a combination of these two commands. So instead of using the output redirection, I'll use another pipe and T. This command, with the help of the T command, writes the output both to the screen and to the file. I want you to see that a new file will be created. This is the output on the screen and cat m.txt. the same output was saved into the file. By default, the t command overwrites the file. You can instruct t to append to the file using the option -a as in the next example. Who pipe t -a m.txt and cat m.txt. The output was appended to the end of the file. And you can also write the output to multiple files. Let's see the kernel version. uname -r. This is the running kernel version. Pipe t -a mac.txt and kernel.txt. Oh, sorry, I've forgotten the command. So uname -r. uname -r and pipe t -a and the files. The output was displayed on the screen and appended to both files. Thanks, that's all about command redirection and piping. Linux is a file-centric operating system, and finding files and directories is a common administrative task. There are two commands used to find them: locate and find. In this video, we'll see how to use locate, and then we'll learn about find. Even though locate is a classical command from the early days of Unix, it's not by default installed on Ubuntu as it is on CentOS. To install it on Ubuntu, just run apt install mlocate as root. So sudo apt install mlocate. By the way, mlocate is the new implementation of locate. So at least on the latest versions of Ubuntu, when you run locate, it actually runs mlocate. Locate is faster than find because it doesn't search in the file system in real time. It uses a previously built database, whereas the find command searches in the real system through all the actual directories and files. On the other hand, the find command has more options available. The locate command searches by name and returns a list of path names containing that name in their path. The database used by locate should be updated periodically. It can be done automatically on a daily basis from cron, or you do it manually by running update db as root. Sudo update db. I'm updating the database used by locate. We'll talk about cron jobs later in the course. The database created by update db that will be searched by the locate command is in /var lib mlocate, and its name is mlocate.db. To see its path together with some statistics, like how many files and directories are indexed, run locate with the capital S option. So locate -S. The basic usage of the command is locate and the name of the file or directory you want to find, like locate passwords. And it has returned a list with all path names that contain the passwords string. Pay attention that it searches for the string in the entire absolute path name. For example, if I search for, let's say, EA horse, okay, it will find all files and directories that have that string in their absolute path name. So it searches the whole path name. To search only the base name against the specified pattern, use the -b option. This is the opposite of the default option, which is -w or -- whole name. So locate -b EA horse. The selected file will not be found anymore. EA horse is not in its base name. Now it will find only files and directories that contain the string in their base name. When you search for a name, it will replace that name with *name* implicitly. So if you search for EA horse, it will replace that name with EA horse and will also find the files called chhorse. To disable this behavior and search for a file by the exact name, use a / before the name like this. Locate -b \name. Backslash is a globbing character that disables the implicit replacement of name by *name*. So, of course, there's no such a file, but I'll try to find something like this. \EA horse. And it didn't find anything because there's no file or directory with that exact name. Let's see another example. Locate -b, shadow. It found all files that have the string shadow in their base name, like rain shadow. But \shadow will find only the files with that exact name. Rain shadow is not there anymore. As I said earlier, the locate command does not search for a file in the file system, but in its own database, which should be updated periodically. I'm creating a new file with a unique name. Touch my file 123x. I suppose this name is unique. And I'm searching for it using locate. So locate and the name of the file. My file 123x. And as expected, the locate command didn't find anything because the new file doesn't exist in its database. I'm updating the database to reflect the latest changes in the file system. Sudo update db. And I'm searching again for the same file. And this time it found the file. If I remove the file and then search again for it, locate will still find it. I'm removing the file and I'm searching for it again. It was found even if the file was removed. To avoid this false positive result, the finding of a file that does not exist anymore, I can use the -e option or --existing so that it will check if the file really exists. So locate -e, my file 123x. And nothing was found. Note that when you update the mlocate database, it keeps timestamp information in the database. This allows mlocate to know if the contents of a directory changed without reading the contents again and makes updates to the database faster. Let's go ahead. Another useful option is -i, which will make locate ignore the case. Linux is a case-sensitive operating system and locate makes no distinction. So locate rain shadow. Nothing was found, but locate -i rain shadow will find a few files. It has ignored the case. And the last option we'll discuss is -r, which comes from regex. It allows you to search by using simple regular expressions. This is an advanced topic and we'll go deeper into it later in the course. For the moment, you should know that a regular expression or a regex is a way of defining complex search patterns. Let me show you one example. Locate -b -r caret shadow \dot and between square brackets 0 -9. This is a regex or a regular expression. I'm searching for all the files and directories whose base name start with the shadow string, then the dot sign, and any digit between 0 and 9. Any other characters can follow. And these are the files. At the end, I want to tell you a few words about another small command called which. The which command locates a command and returns the absolute path of the executable that is called when the command is run. It does this by searching the path for executable files. This can be useful in finding the location of an executable command when you intend to create a shortcut or run it using its absolute path. For example, typing which rm displays the path to the rm command. Which ls. By default, it only displays the first matching executable, and if you want to display all matching executables, if there are more, use the -a option with the command. So which -a find. ls-l bin find. ls-ld bin. In fact, /bin is a symbolic link to /usr/bin. We'll have an entire lecture on symlinks later in this section. To search for more executables at once, all you have to do is to give the executables as arguments to the which command. So which, pwd, ifconfig, find, grep, and Firefox. The locate command used to search for files and directories is very fast, but has two major drawbacks. It has only a few options, and most importantly, it doesn't do real-time search of the file system, but of its own database file, which should be constantly updated. Another Linux command used to search for files is find. It's a complex command line utility that searches for files in a directory and recursively through its subdirectories as well. Using find, you can search for files by name, owner, group, type, permissions, date, and other criteria. The syntax of the find command is find, path, and criteria. Let's see some examples. I'm creating a new directory with two files, mkdir projects and touch projects, report.txt, and another file in the same directory, todo.txt. This is the directory tree. And find the path, the directory, it will search in the current directory by name. So name todo.txt. And it has found the file. As anything else in Linux, the name of the file is case sensitive. Another option is iname, which is similar to name, but the match is case insensitive. So instead of name, I'll use iname, and the search will be case insensitive. If you want to specify only a part of the file name, find will search by that exact name. So find dot the current working directory minus name to do, and hasn't found anything. The name of the file is todo.txt, but I can search like this: todo and a star. It found all files whose names start with the string todo. Star asterisk here means any character, and when you use shell meta characters, it's recommended to enclose them in double quotes. So it's better to specify the searched string like this. It's better. Let's try another one. Find minus name star rep star and the closing double quote. And it found a few files. All the files contain the string rep in their file names. To find and delete a file, pass the minus delete option to find. This will delete the file with no possibility of recovering it, so be very careful. Find dot minus name todo.txt minus delete. And the file was found and deleted. If you search a location your user is not allowed to see, you'll get a permission denied error. Find /etc minus name PASSWD. In this example, I've searched for the files named PASSWD in the etc directory recursively, and there are some directories whose contents are not readable by the non-privileged user that ran the command. To search in those directories as well, I need to run the command as root. Another option you can pass to find is -ls, and it will execute the ls command on each file it will find. -ls. It executed ls on both files. Let's see how to search files by type, and for that there's the -type option. I'm searching for directories in /etc. Find /etc minus type d. Minus type d means directory. In fact, I'm listing all directories from /etc and its subdirectories recursively. This is its default behavior, which is time and resource consuming. However, you can specify the depth of a directory traversal using -max depth option. -max depth This command will search for directories in /etc and will go maximum 2 levels deep. Let's add another option. -perm 755. I've introduced a new option, -perm, which will search by those exact permissions. Let's see how many directories we have found. So pipe wc -l. And there are 254 directories. And if I go 3 levels deep, I'll have more directories. Now there are 343 directories. We can ignore these permission denied errors. I've already explained to you what they mean. Note that when you specify more options or search criteria, those criteria should be true at the same time. In fact, there's a logical end between them. Let's see other useful options. To search by size, use the -size option and the number. Find /var -type f -size 100k -ls. It will search the var directory recursively for files with the size of 1 kilobytes rounded up to the next unit. I'll execute the command as root, so sudo. And there are 3 files. By the way, the size value displayed by ls seems bigger, but that is because the k suffix displays the size in units of 1024 bytes, not in units of 1000 bytes. So it's only a display issue. You can also use the plus and minus prefixes to signify greater than and less than the size of n units. I'm searching for all files that are greater than 10 megabytes. So plus 10 and m. And there are a lot of files. Or I'm searching for the files that are smaller than 10 kilobytes. -10k. These are the files. They are smaller than 10 kilobytes. You can also use the size option many times in the same command. Let's find all files in /var between 5 and 10 megabytes. So plus 5m and -size minus 10m. These are the files. They are between 5 and 10 megabytes. Let's go ahead and see how to search by time, access time, modification time, or change time. To search by timestamps recorded on the files, use the -a time, -m time, or -c time options and the number that represents the number of days. Let's find all files that were modified in the last 24 hours or a day. Find /var. By the way, a / at the end doesn't matter. So -type f -m time 0 -ls. These are the files modified in the last 24 hours. Maybe you wonder why I've used 0 as value for m time. That's because any fractional part is ignored. So if a file was modified 12 hours ago, in days it means 0.5 days and the fractional part is ignored. So in fact it means 0 days. Let's see another example. I'm writing 1 instead of 0. If I use -m time 1, it means files modified between 1 and 2 days ago. Another example. Find /var -type f -a time plus 1 ls. It will find the files that were accessed at least 2 days ago. Plus 1 means greater than 1 and 2 is the next number greater than 1. So the file was accessed at least 2 days ago. If you want to search by minute instead of day, use the -amin, mmin, or cmin options. For example, the next command will find the files that were modified in the last hour. And I'm searching in var. -type f, -mmin, -60. So the modification time is less than 60 minutes. These are the files. I'm running the command as root. They were modified in the last hour. Let's see other search options. To search by owner, use the -user option, and to search by group, use the -group option. I'm searching in /var directory for files that belong to the gdm user. -user, gdm, and -ls. I'll run all of these commands as root. These are the files that belong to this user. And to negate an option, use -not before the option. For example, let's see all files that do not belong to the root group. Root is both a user and a group in Linux. The only user that belongs to the root group is root. I'm searching in /etc. I'm searching for files, -not, -group, root. These are the files that do not belong to the root group. Sometimes you want to operate or execute a command on the files that are found. This is really useful. There's the -exec option that does that. Exec comes from execute. Let's see how it works. I want to see the contents of the files in the /etc directory that were modified in the last 24 hours. There are two steps. First, I'll find those files. Find /etc -type f -mtime 0. Okay, I always forget to run the commands as root. These are the files modified on the last day. The second step is to add the -exec option and the shell command I want to execute on each found file. I'll write the entire command and then I'll explain it to you in detail. So -exec cat, a pair of curly braces, a white space, / semicolon. This command will run cat on each file found by find. The cat command requires as argument the file to display. I do not know what name to write, and I'm writing a pair of curly braces. In this construction, the pair of curly braces will expand to the file found by the find command. The command after -exec ends when / semicolon appears. That's always there at the end. It's the syntax of this construction. I have displayed the contents of all those files. Let's do another example. I want to backup or make a copy of all configuration files from /etc that were modified in the last week. As root, I'm creating a new directory called backup in /root. mkdir /root backup. And sudo find /etc -mtime 7 -type f -exec and the command cp the file to copy, and I write a pair of curly braces, and the destination root backup space / semicolon. The files were copied. Sudo ls -l /root backup. Okay, there's no file because I should have written -7, not 7. -7 means in the last 7 days, so in the last week. And 7 means exactly 7 days. So like this. Okay, there are a lot of files. All of these files were modified in the last week. Let me explain to you what happens here. For each file found by the find command, the cp command is executed. cp requires more arguments, at least 2, a source and a destination. The source will be the file found by find, or the pair of curly braces, and the destination the backup directory. So the braces are in the place where the file should be. Note that there's also the -OK option, which does the same as -exec, but interactively, as it asks the user first. If the user agrees, it runs the command that follows. Otherwise, it just returns false. So instead of -exec, I'm writing -OK, and it's asking for every file if it copies the file or not. This can be very useful if you run a potentially dangerous command and want to see exactly on which file the command will operate. That's all. In this lecture, I'll show you how to search for a string pattern in a text file. This is especially useful because the Linux configuration and log files are of type text and is common to search for a specific option, message or error. We'll talk about the grep command. Grep is one of the most useful Linux commands, even though it was created by Ken Thompson, one of the pioneers of computer science, as a private utility more than 45 years ago. The grep command searches in a text file or output of another command for a pattern referenced to as a regular expression and prints out all lines that contain the pattern. To search for a pattern in a file, you write grep, optionally some desired options, the pattern to search for, and the name of the file as a correct absolute or relative path. I'm searching in the configuration file of the SSH client for the string user. Grep, the string, the pattern, and the file, etc ssh_config. And it displayed all the lines that contain the string user. There are 2 lines. If the pattern contains spaces, you should enclose it in quotes, like grep, and between double quotes, let's say command line, and the file, the same file. And it found the lines that contain the pattern. To ignore the letter case, use the -i option. Grep, SSH, written in capitals, and the file. And it didn't find a thing. Now I'm gonna search it by ignoring the case. So I'm adding the -i option. -i comes from insensitive. And it found a lot of lines. To print the line numbers on which the pattern was found, add the -n option. So -n. And it printed out the line number as well. Of course, you can group multiple options, like this. It's the same. To search for whole words, use the W option. Let's say grep, body, etc, password. And you see that grep searches for any sequence of characters, not only whole words. And it found the line that contains the string nobody. Now I'm adding the -w option. And it searched for whole words and didn't find a thing. To invert the sense of matching, so to select non-matching lines, use the -v option. V comes from inverse. So grep kernel /var log dmessage. It found a lot of lines that contain the string kernel. And now I'll invert the match. And it found all the lines that do not contain the string kernel. If you want to search for a string in a binary file as if it were a text file, use the -a option. Grep root /var log auth.log. And it says binary file, the name of the file, matches. This is in fact a data file, a special kind of text file. To search for a string in such a file, I have to add the -a option. And it found all the lines that contain the string root. If you want to search for a string in a directory, it will return an error. I'm searching for the loopback interface IP address in /etc. So grep the IP address of the loopback interface 127.0.0.1 and /etc, the directory. And it says /etc is a directory. What I can do is tell grep to go recursively in /etc and search for the pattern in every text file in that directory and all its subdirectories. I'll use the -R option. And it displayed all files that contain that string, which is the loopback interface IP address. Of course, grep doesn't have the permissions to read all the files, but I can run the command as root. By the way, if you want to suppress error messages about non-existing or unreadable files, add the -s option, like this. If you just want to see the number of the matches, use the -c option. I'm searching for the string error in a log file. So grep -c error, the pattern I'm searching for, and the file. varlog syslog. And it found 9 matches. So there are 9 lines that contain the string error. Of course, I could get the same result by using a pipe and the wc-l command. So grep error, the file, these are the lines, and I'll pipe the output to wc-l. Now there are 10 lines. A new line was written to that file. The grep command can be used to search in the output of another command as well. In the next example, I'll display the kernel ring buffer using the dmessage command and then search for possible error messages. Dmessage. This is the kernel ring buffer. It's printing out the kernel ring buffer. These are kernel logs in the RAM, most of them produced by the device drivers. So I'm filtering the lines that contain the string error. Dmessage, pipe, grep, and error. And there's a single line. If you want to see a context, and that means a few lines before and after the match, I can run grep -a, let's say 3, and -b 4. It printed out 4 lines before the match and 3 lines after it. This is what the -a and -b options do. You can also use -c from context and the number, and it will print out the same number of lines before and after the match. I want to see 3 lines before and after the match. So -c 3. 3 lines before and 3 lines after. Another common example is to check what program is listening on a specific port. To display all ports, run netstat with some options. Run it as root. So sudo netstat -tupan, and it has displayed all open ports. And to check if there's something that's listening on port 53, filter the output using grep, like this. Pipe grep 53. And there are some processes that listen on that port. Let's check if port 80 is open. And there's no process listening on port 80. Let's see the last example. ls-r and f /etc. I'm listing the etc directory recursively using the -F option, which adds a character at the end of the file depending on its type. This is the output. This is an executable file, this is a symlink, and these are directories. The output will be piped to grep, which will exclude lines that contain a /. These are the directories. So pipe grep /. And -v to inverse the match. I want to exclude directories. There's no directory in the output. Then I'll exclude the empty lines. To do that, I'll use something special called the regular expression. So pipe grep -v, I'm excluding the empty lines. And now the regex for an empty line. Caret and $. Caret means the beginning of the line, and $, means the end of the line. So in fact, I'm excluding the lines that have a character between the beginning and the end. No empty lines. Let's see how many they are. I'll pipe the output to wc-l. And there's this number. I can ignore those permission denied errors, or I can run the command as root. And finally, to sort the files by name, I run the sort command on the output. Pipe sort -r. -r will do a reverse sorting without wc-l, like this. And the output was sorted by name in reverse alphabetical order. To see it better, I can pipe everything to less. Without the -r option, it will sort the output in ascending alphabetical order. All files that start in A, then the files that start in B, C, and so on. And I can redirect the entire output to a file as well. See how I'm using multiple different commands and pipes to get the data I want. That's all. Take your time to deeply understand how grep works. It's one of the most useful Linux commands. The grep command searches for strings in text files. However, not only text files contain ASCII characters. Binary files such as executables may contain strings in human-readable text. In the compilation process, ASCII characters are embedded into the binary files, and sometimes when an application is deployed, some ASCII text is packed into the binary file by the developer. This contains useful information about the binary, like a short help or copyright information. There are also binary files used by different applications that embed sensitive information as credentials. The strings command extracts printable characters from binary files. It prints out character sequences that are at least 4 characters long. Let's see the printable characters from the ls command. First, I want to see its path, which ls, and strings /usr/bin ls. These are the ASCII characters embedded into ls. I'll use pipe and less to navigate through the output. So pipe less. And I'm searching for the string help. I'm pressing N to see the next occurrence. Okay, and I found the help of the command embedded into the command itself. I could also print out ASCII characters from the device file that represents a disk partition. Let's see the partition that is mounted on the root directory. This is the partition. It's /dev/sda5. And I run the command as root, sudo strings -a and the file. I'm printing all characters on the partition using the low-level device file. It's printing all ASCII characters. -a option scans the whole file, which is in most cases the default behavior. I'm interrupting it by pressing Ctrl and C. And the last example, which I find interesting, is to search directly into the machine physical memory, ls-l/dev mem. This is a character device file that is an image of the main memory of the computer, and strings /dev mem, pipeless. I've got a permission denied error because only root can search into the computer's memory. I'm using sudo before the command's name. These are the printable characters in the physical memory. It's the computer's memory. Interesting, isn't it? There are other options available, and you can find them in the man page. In this video, we'll cover different ways of comparing files' contents. This is especially useful when you want to compare either the output of the same command at different moments or the differences between a backup configuration file and the one currently used by the system. Let's take a look at the first example. I'm redirecting the output of the ifconfig command to two files at different moments. So ifconfig greater than, so command redirection, A. I'm generating some network traffic, ping 8.8.8.8. I'm stopping it by pressing Ctrl and C. And I'm redirecting the output of the same command to another file called B. A and B were created in the current working directory. The files contain the output of the command, but also the differences between the runs. To see if there was any difference between the two runs of the command, I can compare the file's contents. If you only want to know if there is a difference, run the cmp command, so cmp A and B. CMP compares the files byte by byte and displays the location of the first mismatch. It doesn't say how the files differ, and if they are identical, no message is displayed. A is equal to A. I'm copying the ls command to the current directory. So cp usr bin ls and that, the current working directory. This is the ls binary in the current directory. And I want to see if it's identical to the original one. cmp usr bin ls and ./ls. ls from the current working directory. It's the same with simply writing ls. It's the same. And they're identical. Nothing was displayed. So note that cmp can be used to compare binary files as well. By the way, another way to compare two binary files to see if they are identical is to calculate and compare their hash. The hash is a unique cryptographic ID for each file. Let's calculate the hashes of the ls files using SHA-256. So SHA-256 sum, this is the name of the command, and the path to the file. So usr bin ls and ls in the current working directory. And they have the same hash, meaning they are identical. If even a single bit were different, the hashes would be different. Now, I'm changing the copied file. I'm appending something at the end. For example, echo A greater than ls. Let's see if the binaries are still identical. cmp usr bin ls and ls in the current working directory. And they are not identical anymore. They differ on the first line. And the hashes? The hashes aren't identical either. Now, if you want to go deeper and see exactly how they differ, you should run the diff command. It's used only for text files. So diff A and B. Diff stands for difference and is used to display the differences in the files by comparing them line by line. So, from its output, it can be seen that the lines that differ are those related to the received and transmitted packets. This is normal because there was network traffic between the runs of the ifconfig command. I've run the ping command. Let's take another look of the output of the diff command. Let me explain to you how to interpret the output of the diff command in another example. First, I'll install the OpenSSH server or daemon because we'll need it anyway later in the course. So sudo apt install SSH. And it's installing the OpenSSH server. It's done. I'm copying the configuration file of the SSH daemon in the current working directory cp/etc ssh /d_config and the destination the current directory. This is the configuration file of the daemon that will be copied in the current directory. I'm opening the file and changing the port option. Of course, I'm opening the copy. And instead of port 22, I'm writing port 29. And I'm saving the file. If you don't know how to use VI, edit the file using gedit, the graphical editor available on Ubuntu. This one. Just go to etc, SSH, and open the sshd_config file. This is the file. However, we'll go really deep into the VI editor in the next lectures. And I'm running the diff command on the files. Diff, the original file, etc sshd_config, and the file in my current working directory, the file I've modified. Let's take a closer look at the output. It's showing us the line that differs and the line number. In this example, it's line 15. The character C after 15 indicates that we have to change or replace the line 15 in the first file by the line 15 in the second file to make them identical. Two other meaningful characters are A and D, where A means add or append and D means delete. Lines preceded by a less than sign are lines from the first file, and the lines preceded by a greater than sign are lines from the second file. In fact, the diff command helps us make the files identical and indicates exactly what should be done. This is used by the patch command to patch a program that has a bug. Let me tell you a few words about it. Suppose a new bug, which is a programming error, was discovered. The solution to make things right is the developer to change the source code. Instead of releasing an entire program, the developer releases only a patch, which is in fact a file that contains the differences between the file that has the bug and the file where the bug was solved. This file, and I mean the patch, was generated by the diff command after calculating the differences between the two source files. You can then apply the patch to the file that contains the bug using the patch tool. The patch file indicates how the file should be changed so that it becomes identical to the other file, the right one. Other useful options of the diff command are capital B to ignore blank lines, W to ignore white spaces, and I to ignore case differences in file contents, and C for a more detailed comparison. And the last option, which is Y, if we want to display the entire file's contents on two columns side by side, indicating the differences. So diff -Y and the files. Here's the difference. Of course, a pipe to the less command would be much better. To configure or change anything on Linux, you need to edit a specific configuration file. To write or edit files, you need a text editor. There are text editors that work in graphical mode and text editors that work in the terminal without a graphical interface. Since most of the administration work is done in the terminal, you need to learn how to use a text editor that doesn't require a graphical interface. They are called CLI or command line interface editors. There are a lot of such editors, and among them we can mention VI, Vim, Nano, Pico, or Emacs. In this course, we are going to use a text editor called Vim, which is, by the way, the most used editor and the default one for many Linux distributions. Vim stands for VI Improved, as Vim is based on VI, and VI is the original text editor on Unix released more than 40 years ago. Everything in VI is available in Vim, plus some extra features. If VI is always available on any flavor of Linux or Unix, depending on your distribution, Vim should be installed or not. To install or update Vim on Ubuntu, I'm running sudo apt install vim. And it's installing it. And on CentOS, sudo dnf install vim. Vim is a very powerful text editor and it offers extensive text editing options. However, in this introduction, we are going to focus on exploring some of the more basic functions and commands, the ones that are required for basic file editing. Keep in mind that Vim is not so easy at first sight, but once you learn how to use it, you'll love it. If you try to open a file using vi, like vi and the file name, it just opens it in Vim because vi is an alias or a symlink to Vim, both on Ubuntu and on CentOS. In this example, the file was opened with Vim. I'm exiting the file, typing :wq. As you notice, vi is an alias to Vim. Let's get started with Vim. To use Vim on a file, you type in Vim and the name of the file using a correct absolute or relative path. If the file already exists, Vim will open it for editing, but if it doesn't exist, then Vim will create the file. I'll make a copy of an existing file to show you the basics of Vim. I'm copying the SSH server configuration file from /etc/ssh to the current directory. So cp etc /sshd _config and the destination the current directory. And I'm opening it with Vim and the path to the file. Vim is a model editor and that means it has three basic modes of operation: command, insert and last line modes. When you open a file in Vim, you are in the command mode. In this mode, characters you type get interpreted as commands. Like X will delete the character currently under the cursor, or R will replace the character under the cursor. I'm pressing R and 6. And it replaced 1 with 6. To get back to this mode from any other mode, just press ESC 1 or more times. I'll tell you a secret. When you are in a mode and get stuck, press a few times the escape key and it will take you to the command mode. To start writing text as in a normal text editor, you need to enter into another mode called insert. To enter into insert mode, from command mode, press lowercase I and it will insert the text before the cursor until you press ESC. So I'm pressing I, I'm in the insert mode, and I can write like in any other text editor until I press ESC. Remember that when you hit ESC, it enters the command mode. Now I'm in the command mode because I've pressed ESC. If I press the uppercase I, it will start inserting the text at the beginning of the current line until ESC is hit. I'm in the command mode again. If I press A, the lowercase a, Vim will append the text after the cursor until ESC is hit. An uppercase A will make it append the text to the end of the current line. And the last two keys are lowercase o to write the text on a new line below the current line and uppercase O to write on a new line above the current line. So in a nutshell, to enter insert mode from command mode, type I, A and O, both lower and uppercase. The third Vim mode is known as Vim last line mode. You can only get to the last line mode from command mode, and you get into last line by pressing the colon key like this. I'm in the last line mode. After pressing this key, you'll see a colon character appearing at the beginning of the last line of your Vim editor window, and the cursor will be moved to that position. From Vim last line mode, you can do all sorts of things like saving the file, quitting the file without saving it, and so on. Let's quit Vim without saving the file. I'm writing Q and an exclamation mark, and I'm hitting enter. I quit without saving. I'm opening the file again and making some changes. I'm typing O to write on the next line. When I'm done, I'm pressing ESC to go to the command mode again. From the command mode, I'm pressing colon and I'm in the last line mode. To save the file without closing it, I write W and an exclamation mark. And I'm hitting enter. The file was saved. If you want to save the file and then close it, in the last line mode, type WQ and an exclamation mark. I'm opening it again. One of my preferred shortcuts or commands while in the command mode is to save and quit the file quickly and easily by typing Shift and Z. So I'm pressing Shift and Z 2 times. That was the basics of Vim. You can now perform basic file editing. To go deeper into Vim or just practice it, run vim tutor and Vim will open a tutorial file. You can freely work on it because it's a copy. Next time you'll run Vim tutor, it will open the same original file without any of the changes you have done. I'm making some changes. And I'm saving and exiting the file. I'm running Vim tutor again. And I'm seeing the original file. In the next lecture, we'll dive deeper into it and I'll show you many other useful Vim features. See you in a second. Let's dive deeper into Vim. I'm opening a text file for editing using Vim. You can run a shell command from within your Vim editor session like this. Go to the Vim last line mode by typing a colon, an exclamation mark, and then the shell command. Say ls, and the command was run. One more time, colon, a question mark, and the command, ifconfig. To search for a string or a pattern in the command mode, type a / and the string you search for, and then hit enter. SSH, and enter. Any matches in the current window will be highlighted. You can then navigate between matches with N, I'm hitting N, or Shift N. N will go to the next match, and Shift N or uppercase N will go to the prior match. This works exactly the same as for the less command. When you search by using a / followed by the searched term, it searches forward. But if you are, for example, at the end of the file and want to search backwards, then you type a question mark instead of an exclamation mark and the searched term. I'm going to the end of the file by typing capital G. I'm at the end. And I'm writing an exclamation mark and the searched term, for example, port. And it found the string. Another quick way to find the next occurrence of the word under cursor is to press an asterisk. The word under the cursor is yes, and I'm pressing asterisk, a star. And it found the next occurrence. And the next one, I'm pressing asterisk. The previous occurrence of the word under the cursor is found with a hash sign. The word under the cursor is no, and I'm pressing hash. And it found the previous occurrence. It's searching backwards. I'm pressing the hash sign multiple times. To search for a pattern and replace all occurrences, in the last line mode, write. I'm in the last line mode and I'm writing %s, lowercase s, the searched term, for example, no, this is just an example, the term or the string I want to replace with, for example, XXX and G. I'm replacing all occurrences of no to XXX. Now, I think that was a mistake and I can undo till the last saved version of the document by typing E and an exclamation mark in the last line mode. So colon, E, and an exclamation mark. And I'm hitting enter. Note that it didn't undo only your last operation, but up till the moment you've last saved the file. To undo the last operation only, in command mode, type U. This is equivalent to Ctrl and Z in a graphical text editor. And to redo the previous operation, type Ctrl and R. Let's talk about cutting, copying, and pasting a text. If you want to cut a line, press D 2 times. So double D. The line was not simply deleted, but copied to the clipboard. To paste it somewhere else in the document, move the cursor to that position and press P. I'm pressing P. The line was pasted there. To cut more than one line, type the number and then DD, so double D. For example, I'm cutting 10 lines below the cursor and I'm writing 10 and double D. And the lines were cut. This could be a simple deletion, or I could paste them in another part of the document. I'm moving to that position and pressing P. Okay, let's move on and see how to copy and paste the text. The first step is to position the cursor where you want to begin copying. Press lowercase v to select characters, uppercase V to select whole lines, or Ctrl and V to select rectangular blocks. Use the arrow keys to define the selection. For example, I'm pressing the capital V, the line was selected, and now I'm using the arrow keys to define the selection. I'm going down. After selecting the text, press Y. I'm pressing Y. Y stands for Young in Vim, which in other editors is usually called copy. Now move to where you like to paste. For example, at the end. Press capital P to paste before the cursor or small p to paste after. I'm pressing lowercase p. And the text was pasted after the cursor. In the last line mode, you can run many Vim configuration commands, such as for example the command that tells Vim to show line numbers in your current editor window. So colon set NU from numbers. And it has displayed the line numbers. If you don't want to display the line number, which is useful when you want to copy and paste from Vim into another editor and don't want to take the line number as well, run set no NU. So colon set no NU. It comes from no numbers. Okay. Another useful feature is syntax highlighting, which is nothing but a feature of Vim that displays a text, especially a source code, in different colors and fonts. To enable or disable syntax colors in last line mode, run syntax on to enable syntax highlighting, respectively syntax off to disable it. I'm writing syntax off. And syntax highlighting was disabled. Now I'm enabling it. Syntax on. Note that these changes are not permanent. If I exit Vim and then open it again, I'll notice that neither the line numbers nor the syntax highlighting were saved. I'm exiting Vim and saving the file. So colon W Q and I'm hitting enter. I'm opening the file again and I don't see the line numbers. To make the changes permanent, in the user's home directory, create or edit a file called .vimrc. This is a hidden file because it starts with a dot. And in that file, write all commands you normally write in last line mode. So I'm exiting Vim and I'm opening a file in user's home directory called .vimrc. And in this file, I'll write the Vim commands. For example, set NU and syntax on. I'm saving and exiting the file. Now the changes are permanent because each time Vim is opened, it will run the commands in that file. See that? The line numbers are there. Let me show you a few more useful shortcuts. If you want to move to a specific line, in last line mode, type the line number and press enter. For example, I'm moving to line 100. This is useful when you get an error in a shell script or configuration file and it says that the error is on a specific line, like on line 250, and you want to move there to see what's all about. To move to the end of the file, type capital G. Okay, I'm at the end. To move to the beginning of the file, type double G, lowercase g, or move to the first line, as I've already shown you. I'm typing G 2 times. I'm at the beginning. Or colon 1 and I'm hitting enter. It's the same. Let's see how to work with multiple files at once. This is useful when you want to copy and paste between files or to visually compare the file contents. You can open more files like this, vim and the file names. I'm quickly creating 2 files using a redirection, ifconfig greater than a and who minus a greater than and b. So I've redirected the output of ifconfig to a and the output of who minus a to b. This is a and this is b. And I'm opening both files, so vim a and b. It's displaying the first file, but I can move to the next one by typing n or next in the last line mode. So colon n and I'm hitting enter. This is the next file. To access the previous file, type prev or capital N in the last line mode. So colon prev and I'm hitting enter. This is the previous file. Another way to work with multiple files at the same time is to use the -o option, which will split the window and open a window for each file. This is known as stacked windows. I'm exiting this session of vim. And I'm writing vim -o, a and b. You can move between windows by pressing Ctrl and W. I'm in the second file, and now I'm in the first one. This is a convenient way to copy and paste or to do other operations on both files. For example, I'm pressing Shift and V, I have selected the line. Now I'm pressing Y, I've copied to the clipboard, Ctrl and W to move to the next window, and P to paste the line. Okay, sometimes it's useful to view 2 files side by side and see the differences between them. This is especially useful when you change some configuration options of a service and after a while you want to compare the file with a baseline, with the original one. I'm exiting vim. Let's take a look at an example. I'm copying the configuration file of the SSH server again in the current working directory to have the original file. And I'll do some changes. I'm opening the file and change port 22 to port 29. I'm saving the file. Now I want to open both files to see the changes. To do that, I'll use the -d option, vim -d, the original file, and the copy. You see both files opened in stacked windows and the lines that are different are highlighted. Now you can move between files by using Ctrl and W. I'm exiting. There's also a wrapper called vimdiff that calls vim with the required options. So vimdiff and the files. It's the same as running vim -d. I'm exiting without saving. One last thing. If you exit vim without properly closing it, so without using a command or a shortcut, like closing the terminal or pressing Ctrl and Z, next time when you open the same file, you'll be presented with a message. I'm opening a file, this one. And instead of exiting using a shortcut, I'm pressing Ctrl and Z. This isn't a vim shortcut. Or I can close the terminal, the entire terminal. I'm pressing Ctrl and Z. Now I want to open the file again. And I'm presented with this message. What I can do, I can try to recover the file by pressing R and then saving it normally, or I can simply delete the swap file that was created. This one. So I'm typing enter, I'm exiting, and I'm removing the swap file. This one. And next time I can open the file normally. In this lecture, you'll learn how to archive and compress files and directories in Linux. tar is the most widely used command to create compressed archive files that can be moved easily from one disk or machine to another. This command has a large number of options, but you need to remember only a few of them so you can quickly work with it. tar is a complex tool used to both archive and compress files as well as extract the resulting archives. Before continuing, I want to make a distinction between two terms, archiving and compressing. Archiving means that if you take 10 files of 100 kilobytes and archive them, the resulting single file is 1000 kilobytes. On the other hand, if you compress those 10 files, you might find that the resulting file has a wide range from only a few kilobytes to close to the original size depending on the original file type. In general, text files have a higher compression ratio. tar alone only archives the files. It does not compress them as well. But using specific options, tar can pass the files to the compression algorithm and the final result will be compressed without using another dedicated command for that. Let's get practical and see the most used options. The most important ones are C, which creates an archive, X, which extracts the archives, and T, which displays the contents of the archives or its table of contents. In the next example, I'll compress an entire directory into a single file. It will also compress every other directory inside the specified directory itself. In other words, it works recursively. I'll run the command as root because I'll compress the /etc directory and there are files that can be read only by root. tar -c z vf, the name of the archive, etc.tar.gz, and the path to the directory, /etc. I'm hitting enter. Now you are seeing in the terminal the process of the command. This is what the -v option, which means verbose, does. This is optional, but it's helpful. If I run the command again without the -v option, it will run quietly without displaying anything on the screen. I'm running it again without v. It hasn't displayed its progress. By the way, these archive files are called tarballs. Let's take a closer look at each option. C means create an archive. Z tells tar to also compress the archive using gzip or GNU-zip compression. This is the most used compression protocol on Linux. By the way, that's why the resulting file has a .tar.gz extension, a double extension. However, sometimes a .tgz extension is used instead. Note that the type of the file is not given by its extension. It's only helpful to visually find out what kind the specific file is. In this case, it's an archive that was further compressed with gzip. And F allows you to specify the file name of the archive. In other Linux commands, it doesn't matter the order of the options, but in the case of tar, it's mandatory to specify the archive file name after the option F. If I write the -f option at the beginning, I'll get an error, like this. The archive was created in the current directory, but you can create it anywhere else by specifying a path. For example, I'm creating the archive in /tmp. Another useful compression algorithm is bzip2, which creates smaller files but at the cost of speed. However, nowadays computers are so fast that most users won't notice much of a difference between the times taken by gzip or bzip2 to compress a group of files. To use bzip2 instead of gzip, simply use the J option instead of Z. it's common to use .tar.bz2 for such an archive. tar.bz2. Tar is frequently used to compress a single directory, but you could also use it to compress multiple directories, multiple individual files, or both. Just provide a list of files or directories instead of a single one. Like this, tar-czvf archive.tar.gz and the files etc password, etc group, var log, the message. I have archived and compressed 3 files. Of course, I can add the directory as well. There are some permission denied errors. So I run the command again with sudo. In some cases, it's useful to exclude some files from the archive. Imagine that you make a backup of a directory and want to exclude music, video, or other non-important files. To do that, use one or more exclude options, like this, tar ---- exclude equals and the files to exclude. For example, star.mkv. Another one, ---- exclude equals .config. And ---- exclude equals .cache. Now the options, the name of the archive, and the name of the directory, the user's home directory, /home/student. It will exclude these files from the archive. Perfect. Once you have an archive, you can extract it with the same command, which is tar. I'm going to extract the contents of an archive in the current working directory. So tar -x, which comes from extract, and the same options, zvf, and the name of the archive. The archive was extracted in the current directory. This is its contents, etc. The etc directory. If you want to extract an archive into another directory, use the C option and the destination directory. I'm creating a new directory called my backup, and I'll extract the contents of the bzip2 archive in that directory, mkdir my backup, and tar x j vf, the name of the archive, etc.tar.bz2, C, and the destination directory, using a correct path. And it was extracted in that directory. Let's check which algorithm has compressed better. And sudo du -sh etc. Okay. Let's take a look at the archives. We notice that bzip2 is better. 1.1 divided by 1.3 multiplied by 100. I did the math and found out that bzip2 occupies only 85% of the space occupied by the gzip archive, and the size of the original directory is 12 megabytes. So the compression ratio was 1.1 divided by 12. Approximately 90%. Note that these two compression algorithms are incompatible. If you want to extract a gzip archive using the -j option, which is the option for archives of type bzip2, you'll get an error. Specify the correct option, which is Z for gzip and J for bzip2, or allow tar to auto-detect the compression type by specifying no option for the compression algorithm. So tar -xzvf and the bzip2 archive. We cannot use Z for archives of type bz2. Specify J or no option at all. To see the contents of an archive, use the -t option, which comes from the table of contents. When you want to check if a specific file is in the archive, pipe the output of the previous command to grep. I want to check that the configuration file of the SSH daemon is in the archive. So tar tf, the name of the archive, and pipe grep sshd _config. And it's there. But the configuration file of the Apache web server is not there. There's this directory, but it's not the configuration file of the web server. The examples shown in this lecture are extremely useful because the etc directory contains the configuration files of the entire system. In my opinion, it's mandatory to have a backup of this directory so it can be restored if after an update or change something goes wrong. And I'll show you a trick. If you want to have versions which are backups made in different days, then you need to insert the date into the backup file name. For that, you need to do a command substitution like this. tar -cjvf, the name of the archive, etc minus, and now the trick. A $sign, a pair of parentheses, and between parentheses, a shell command. Date, a white space, plus %F. .tar.bz2, and the name of the directory. And I'll run it as root. See how a new archive with the current date in the file name was created. What the command did was substitute the date command with its output. So date, white space, plus %F. The command was substituted with this output. We'll dive deeper into this in the shell scripting section. Lately, I've seen more and more files with the .xz extension. These are files compressed with the LZMA algorithm, and tar will auto-detect the compression type and extract the archive. Let me show you a quick example. I'll download an archive of type XZ from gnu.org. It's the core utils archive. It contains all the basic Linux commands. The archive is in the current directory, and tar -xvf, and the name of the archive. And it's extracting the archive. In most cases, you'll use tar to compress files using different compression protocols. However, note that there are also dedicated commands that only compress or extract files and directories using gzip and bzip2. Gzip is used to compress a file or a directory. Gunzip is used to extract a gzip archive. Then there's bzip2 and bunzip2. In this lecture, we'll discuss inodes and harlinks. Each file on disk has a data structure called index node or inode associated with it, which is fixed in length. This structure stores metadata information about the file, such as the type, file's permission, file's owner and group, timestamp information, file size, and so on. You can see most of the information stored in a file's inode in the output of ls-l. The inode structure contains all file information except the file contents and the name. Each inode is uniquely identified by an integer number called inode number. To see it, run ls with the -i option. You can combine it with other options as well. Yes, you heard me right. The file name and the file contents are not part of the inode. In the inode structure, there are only some pointers to the data blocks where the file contents are saved. But where's the file name if it's not in the file's inode structure? A file name is an entry in a directory. Basically, directories are two-column tables where the first column is the file name and the second column is the inode number. Something like this. This is a column and this is another. This is a simplified approach, but I think it's a good one for you to understand. I'm creating a new file using the touch command. When I refer to a file, like say cat a.txt, it will search in the current directory for the corresponding inode number of a.txt for this number. Having that number, the kernel can identify the file and all the information about it. So, as a conclusion, the file name doesn't belong to the file structure. It's just a string, and the pointing between the file structure and the file name happens through the data structure of the directory that contains the file name. An association between a file structure and a file name is called hard link. In fact, this is a hard link. In the current directory, a.txt was associated with this number. By the way, that's what this one means. It means one hard link. You can have more associations, and I mean names, to the same file structure on disk. So the same file can be accessed through many names in the same directory or different ones. To see the number of hard links, run ls-l or stat. This regular file has one hard link. You can create a new hard link by running the ln command. ln comes from link. At this moment, the file called a.txt has only one hard link because there's one name that points to the inode structure. To create a new link to the same file structure, I run ln, the existing name, and the new name, like ln a.txt b.txt. So in fact, I've created a new file name for the same file structure. We can see that both files have the same inode number, and the number of hard links is now 2. Note that b.txt is not a copy of a.txt. The information on the disk is saved only once, and both files point to the same data. If I change one of them, the other will be changed as well. For example, I'm using a redirection I've configured greater than a.txt. I'm changing a.txt. I have redirected the output of the command to the file. The other file name to the same structure has the same contents. It's the same. You can also create a hard link in another directory. For example, ln, the existing file, b.txt, and the new hard link, my backup, c.txt. Now, there are 3 hard links, or 3 names, to the same file structure on the disk. You see, there are 3 links. And it's the same inode number. If you delete a file using rm, then only the entry from the directory that contains the file is removed and the link count of the inode is decremented. Only when it reaches 0, the disk space associated with the inode and the inode itself is freed for further reuse. I'm removing a.txt. They have the same inode number, and the number of hard links is 2. You know that there are 2 hard links for the file to which b.txt points and want to find out the other one. Suppose you don't know that c.txt in my backup is a hard link. To do that, use the find command with the -inum option, like this. Find the current directory, inum, and the inode number. And it found all the links. Also note that you cannot create a hard link to a directory or a hard link to a file on a different partition or disk. A hard link cannot cross the file system boundaries. Let's try to create a hard link to /etc. Hard link not allowed for directory. However, if you run the ls-l command on a directory, like this, you notice a very large number of links. The etc directory has 130 hard links. Maybe you wonder how that's possible. And the answer is that there are 130 names to the same structure, the etc directory. One is etc, Another reference is the dot which belongs to each directory and its reference to itself. This one. This is the second link. And then there are 128 subdirectories, and each of them contains the double dot, which is a reference to its parent. So in this case, to etc. If I take any directory from /etc, for example this one, and I run ls -lia, and the directory, you'll notice there the double dot, this one. This is in fact etc. So another hard link. This is its inode number, which is equal to the inode number of /etc. It's the same number. One useful application of the hard links is to allow files, programs, and scripts to be easily accessed in different directories without making copies of the same file. And if you want to find files by the number of hard links, use the find command with the -links option. Let's find all the files in /usr with more than one link. Find /usr -typef -links +1. All these files have more than one link. Let's add the -ls option. 5 hard links, 10 hard links, 3, and so on. The number is always greater than 1. Besides hard links, there's another type of link called soft link, symbolic link, or symlink. We'll take a short break, and in the next lecture, we'll discuss symlinks. We've just seen what is a hard link and what are its properties and use cases. Let's move on and talk about soft links, also called symbolic links or symlinks. They are similar to shortcuts in Windows and behave differently compared to hard links. Let's take a look at this picture. If a hard link is an association between an inode structure and the file name in a directory, a symlink is just a special file type that points to or contains a reference to another file or directory. So a hard link references the file's inode, and a symlink references another file. If you delete a hard link, the remaining files point to the same space or inode in the file system, and they will still contain the data stored on the disk. But if you delete the file the symlink points to, the symlink will be useless or broken. To create a symlink, we use the same command as for creating hard links, which is ln, but with the -s option. I'm creating a symlink. ln-s, the existing file, /etc password, and a symlink in the current directory pswd. I've just created a symlink called pswd to etc password. See how ls-l is indicating that pswd is a symlink, and it's also displaying the file it points to. Let's see another example. I'm creating a new file using a redirection. ps-aux greater than processes.txt. By the way, ps-aux is displaying all running processes. And the output was redirected to this file. And I'm creating both a hard link and a symlink to the newly created file. So ln processes.txt p.txt. This is a hard link. And now a symlink. ln-s processes.txt and symlink _p.txt. I'm running ls-li. This is the original file, processes.txt. This is the hard link. They have the same inode number, this number. And this is another file, the symlink. I can access the contents of processes.txt using the symlink. If I move processes.txt to another directory, p.txt, the hard link, will not be affected, but the symlink will be broken. Let's do it. mv processes.txt and the destination directory. I'm moving the file to my desktop. and cat p.txt, the hard link. And it's working. There's no problem. ls-l, it's showing that the symlink is broken. The symlink points to nothing. Cat symlink.txt. No such file or directory. Symlinks are used more than hard links, and we can say that many services, like the web server Apache2, use symlinks extensively in their configuration. Other properties of symlinks are: you can create a symlink to a directory, ln-s/etc etc symlink. I've created a symlink to /etc in the current directory. However, you cannot create a hard link to a directory. This will be an error. A symlink can cross the file system. However, a hard link is locally to the file system or the partition. The symlink has its own inode structure. See how the inode number of the file and the symlink are different. However, all hard links have the same inode structure and inode number. A symlink contains only the path to the original file or directory, not its contents. The permissions of symlinks don't matter because the permissions of the target file will be checked. You'll see that a symlink has all permissions. Take your time to practice and understand how symlinks work and how to create them. They are used heavily in real-world applications. In this lecture, we'll discuss how the Linux system performs authentication. There are two files of particular interest to us: etc password and etc shadow. The etc password file contains basic information about each user account on the system. Let's see the contents of the file. I'm opening it using less. Each line of the file represents a single account of type normal user or system user, and there are 7 fields on each line. Let's take these fields one by one. The first field is the user's login name. The second field at the beginning of the Unix era used to contain an encrypted password. Nowadays, it contains the letter X to denote that a password has been assigned but was saved in another file, the shadow file. If this second field is blank, the user does not need to enter a password to log in. The third field is the user ID, a positive integer number assigned to the user, followed by the group ID in the fourth field. The fifth field is a comment. Sometimes it is left blank. The next field is the user's home directory, and finally, the last field is the default shell, usually set to bin bash. If instead of bash you see there no login or false, it means that is a system user that's not allowed to log into the system. That was the format of etc password. I'm exiting the file by pressing on Q. Let's go ahead and take a look at the format of etc shadow. This is the file. It stores the actual passwords of the users in an encrypted format. In fact, there is the hash of the password with additional properties related to users' passwords, like password expiration dates. The etc password file is word readable, and that means that any user can read it, but the shadow file, this file, is only readable by the root account. Let's take a deeper look at the content of the shadow file. Each line of the file contains 9 comma-separated fields. The first field is the username, and this is how a line in the shadow file is connected to the corresponding line in the password file. The second field represents the password, the entire string between these two colons. This is the password. Then come 7 fields related to password expiration dates, like last password change, minimum and maximum password age, and so on. I won't dive deeper into this, but if you are interested, you can find a full description of these fields in the man page of the shadow file. Man shadow. You find here a full description of each field. Let's get back to the shadow file. If the password field contains an asterisk or an exclamation point, the user will not be able to log in to the system using the password authentication. Other login methods like key-based authentication or switching to the user are still allowed. This is the case of root in the latest version of Kali Linux. Let's take a deeper look at the password field. This selected field. Usually, the password format is set to $type, in this case $6, $salt, and $hash. The type 6 in this case is the cryptographic hash algorithm used and can have the following values. 1 means MD5, 2A means blowfish, 2Y means X blowfish, 5 means SHA-256, and 6, this case, means SHA-512. Then comes the salt, this part, and then the hash of the password and the salt together, this part. This is the hash calculated using, in this case, SHA-512, which is an extremely strong algorithm. Let me tell you a few words about the salt, this field in this example. A salt combined with the password is added to the hashing process to enforce the uniqueness of the output hash, or in other words, the same password will give different hashes because of this random salt. This mitigates password attacks like rainbow tables. The salt is randomly generated for each password, but it's not secret like the password is. If through having the hash an attacker can find the clear text password, all the other similar passwords of other users are still secure because their hash is different. To make it crystal clear, let me show you an example. I'm exiting the shadow file by pressing on Q, and I'll create 2 user accounts. They will have the same password. I'm creating the first user named user1 and then set its password to test. User add, user1. The user was created. Let's set its password to test. Password, user1. And I'm typing test 2 times. Let's create the second user named user2 with the same password, test. User add, user2, passwd, user2. And I'm typing test 2 times. Now, let's check the hashes in the shadow file. I'm printing out the last 10 lines. These are the lines related to the users I've just created. And we notice that even though both users have the same password, the saved hash is different. It is unique. That's because it has computed the hash using both the common password and the salt, which is unique for each user. Now, if a hacker manages to find the password of the first user having the hash, the hacker doesn't know that the second user has the same password because there's another hash in the file. One last thing I want to tell you is that these files, password and shadow, should not be edited by hand unless you know what you are doing. Always use a command that is designed for this purpose. That's all. Now that you know where the passwords are stored on a Linux system, I'll go ahead and show you in the next lectures how the Linux groups are organized and how to manage users and groups. Let's talk a little bit about groups. The main purpose of the groups is to define a set of privileges or permissions, like read, write, or execute, for a given file that can be shared among the users within the group. You have to add a user to a group if you wanted to have the privileges of the group. In Linux, there are two types of groups that a user can belong to. Primary or login group is the group that is assigned to the files that are created by the user. The group ID of the primary group is stored in /etc password and the group name in /etc group. When a user creates a file, the user will be the owner of the file and its primary group will be the group owner of the file. Remember that in Linux, a file is owned by both a user and the group. I'm creating a new file using touch and ls-l and the name of the file. The user that runs the touch command is the owner and its primary group, having usually the same name as the user, is the group owner. Note that each user must belong exactly to one primary group. And there are secondary or supplementary groups. A user can be a member of none or more secondary groups. The secondary groups are stored in /etc group. Let's see how to find out the groups where a user belongs to. To deeply understand how the user and the groups are connected, I'll show you directly in the files. Then we'll take a look at the dedicated commands used to display the groups. Let's take the current user and see its entry in /etc password. So grep the username student and the file /etc password. This is its entry. The third field indicates the user ID and the fourth field indicates the primary group ID. So from the fourth field, we know that the primary group of this user has the ID 1000. Let's search the group file for that ID. So grep 1000 and the group file. So the user's primary group is a group with the same name, student in this case. Typically no other user will belong to this group. Now let's find out the secondary groups of the user. To do that, I'll search for the username in the group file. In fact, I'm opening it with less and searching for student. The last field of each line indicates the users that belong to that group as a secondary group. If there are more users belonging to the same group, which is quite common, then they are separated by a comma. Take a look at this line. Both syslog and student users belong to the ADM group. Normally, you don't search through these files to find out to which groups a user belongs. There's the groups command that does the job for you. I'm running groups. When executed without any arguments, the command will print out a list of all groups the current user belongs to. And the first group is the primary one. To get a list of all groups a specific user belongs to, provide the username to the groups command as argument, like groups root. And the user root belongs to only one group called root. Or groups student. It belongs to these groups. Another useful command is ID. It prints information about the specified user and its groups, and as the group command, if the username is omitted, it shows information for the current user. The command is showing the user ID 1000, the user's primary group and group ID, and the user's secondary groups and their IDs. We'll take a short break, and in the next lecture, I'll show you how to create new user accounts. In this lecture, I'll be showing you how to create new user accounts. In Linux, you need root privileges to create, change, or delete an account. To create a new account, you run the usered command. Run man usered, and you'll see lots of options. To create a new user without specifying any options, just run usered and the new username. So sudo usered u1. Let's see the last 5 user accounts, tail -n5, and the password file, /etc password. And the last user is Yuan, the user I've just created. The user was created using the default options from /etc default usered. By default, for the new user, a group with the same name as the username was also created. Let's see the groups to which Yuan belongs. So groups, Yuan. And it belongs to only one group called Yuan. This is its primary group. Note that the default behavior of usered can differ from distribution to distribution. Usered also reads the contents of the file etc login.defs. This file contains options for the shadow password, such as password expiration policy, ranges of user IDs used when creating system and regular users, and more. To be able to log in as the newly created user, you need to set the user's password. To do that, run the passwd command followed by the username. So sudo passwd and the username, Yuan. Now the user has a password and can log in. Now let's create a user by giving it the most common options manually. If a user is created without any option, its home directory is not created as well. There's no home directory for Yuan. If you want to create the user's home directory, use the -m option. So sudo usered -m. The directory name will be the same as the username and will be created in /home. If you want to give it another name or create it in another location, add the -d option, like -d /home James. If you want to add a comment to the user entry in /etc password file, add the -c option and a comment between quotes. This comment is typically a short description like the user's full name or the contact information. So -c and between quotes, let's say C++ developer. To create the user with a specific login shell, add the -s option and the absolute path to that shell. That shell will be automatically launched when the user logs in or opens a terminal. I suppose you want the user to have the bash shell as the default, so -s/bin bash. By default, the primary group of the user will be a group with the same name as the user. If you want to add this user to another primary group, use the -g option and the name of the group. However, this is not common. What is common is to add the user to some secondary groups as well. To do that, use the G option and the secondary groups with a comma between them. Let's say sudo adm and mail. Note that the groups should already exist or you'll get an error. And finally, the username, James. The user was created with those specified options. Don't forget to set a password for the user if you want it to be able to log in. If you want to create a temporary user, then you should specify an expiration date, the date on which the user account will be disabled. Use the -e option and the date in the format year, -month, -day, like this. Sudo usered, -e and the date, the year, the month and the day. And finally, the username, u2. If you want to change or list the user's password expire policy of an existing user, run the ch command and the username. So ch and the username. To show the aging information of an account, add the -l option, like -l James. Of course, I have to run it as root. And the password expire policy of u2. And the account will expire at the end of the year. If you take a look in /etc password, you'll see that some accounts have as shell something like /usr/sbin no login or /bin false. I'm sure it looks pretty strange, so I want to explain to you what it means. Sometimes you need a system account to be used only to run a service such as a web server. In Linux, every daemon or process should be run as a specific user, and it's recommended not to be root. This is an important security consideration. To have such a limited user account that never logs in, you set its shell as being false or no login. If no login is set as the user's shell, when the user tries to log in, it will get a message saying this account is currently not available. And false is just a binary that immediately exits, returning false when called. That's why when someone that has false as shell logs in, is immediately logged out. There isn't actually such a big difference between no login and false. On some distributions, especially those based on Ubuntu, you'll see another command called adduser. So what's the difference between user_add and adduser? User_add is a native binary compiled with any Linux system, but adduser is just a Perl script which uses user_add binary as a backend. Adduser is more user-friendly and interactive than its backend user_add. There's no actual difference in features provided. You've learned how to use the user_add command instead of adduser because it's recommended to know a general way of creating users that works on any Linux distribution. Now that you know how to create a user on Linux, let's see how to change the properties of an existing user. All the information about a user is stored in the following files: etc password, etc shadow that can be displayed only by root, etc group, and etc g shadow. There's also etc login.defs, which contains the default options of a new user if they are not specified when creating that user. Such an example is the fact that it's not explicitly indicated if the home directory is created or not. The shell commands that create, change, or remove a user or a group are in fact only modifying these files. Usermod is the shell command used to change the properties of an existing user. Fortunately, it uses the same options as user_add, just that instead of creating a user with the specified options, it changes those options. I'm changing or adding a comment for an existing user. Sudo usermod -c and a new comment. For example, golang developer. James, the name of the user. And grep James, etc password. And the value of the comment field was changed. To change the primary group of a user, use the -g option and the group name. For example, sudo usermod -g daemon James. Let's see X groups. Groups James. X primary group is now daemon. Note that the group name, in this case daemon, must already exist. If you want to add a user to some secondary groups, use the capital G option. I'm creating two new groups and then adding the user to those groups. So group add developers, of course, as root. And group add managers. And sudo usermod -G developers, comma, managers, and the username, James. Each group is separated from the next one by a comma, with no intervening white space. Let's see X groups. Groups James. Note that the primary group was not modified, and the user belongs only to those two groups as X secondary groups. Now I'll tell you something very important. If the user is currently a member of a group, which is not specified as an option of capital G, then the user will be removed from that group. Or in other words, after running the command, the user will be a member of those groups only. In this case, developers and managers groups. The user is not anymore a member of ADM, mail, or sudo. This behavior can be changed via -a option, which appends the user to the current secondary group list. For example, if I want the user to remain part of the groups it already belongs to, and supplementary, I want to add it to the sudo group, I'm executing usermod -a capital G sudo and James, the username, and groups James. The user James was added to the sudo group. Let's go ahead and see how to delete users. In Linux, you can delete a user account and all its associated files by using the userdel command. It also deletes the group with the same name as the user only if no other user is a member of that group. Let's delete an account. I'm removing u1. Sudo userdel u1. The account was removed, but its home directory is still there. To remove a user along with its home and mail spool directory, use the -r option, like this. I'm removing the user called James along with its home directory. This is its home directory, this one, and I'm running sudo userdel -r James. The user was removed, its home directory was removed, but the group with the same name called James was not removed because it was not the primary group of the user. Remember that I've changed it at the beginning of this lecture. Note that the command didn't delete any other files that belong to the user and are located in other places. You have to search for and delete them manually. As with useradd, userdel is a low-level utility, but Debian and Ubuntu distributions have a friendlier command called del user. It just uses userdel as a backend. A common administrative task is to give a user the possibility to run administrative commands as root. By default, only the user created at system installation time can run commands as root by prefixing them with sudo. There are two predefined group names, sudo on Debian and Ubuntu-based distributions, and will on Red Hat and CentOS-based distributions. If the user is part of this group, then it can run commands as root. I'm creating a new user called Tor and then check if it can run commands as root. So sudo useradd -m -s, the shell bin bash, and the username Tor. The user was created. Now I'll set its password. And I'm becoming Tor. Tor. It's asking for his password. And I'm Tor. Let's see if it can run administrative commands. So cat etc shadow. Only root can see this file. Permission denied. Let's run the command with sudo. I'm entering the correct password and it's not allowed. I'm logging out. But I want the newly created user to have administrative rights and I'm adding it to the sudo group. By the way, this is true for the new versions of Ubuntu. In older versions, the group name was admin. So sudo usermod -a capital G sudo and Tor. I'm becoming Tor. And I'll try to run the same administrative command as root. So sudo cat etc shadow. I'm entering the password. And it's working. It was allowed to run the command as root. That's because the user belongs to the sudo group. Note that on CentOS, the group name is will. Create the group if it doesn't exist, add any user to the group, and the user will be able to run administrative commands as root. Let's talk about group management. To create a new group, use the group add command. In its simplest form, you just specify the group name as argument. I'm creating a new group called engineering. Of course, I'm running the command as root. And the group was added to the group file. Let's see the last three groups. This is the newly created group. If you want to list all groups, just display the entire contents of the group file. Cat etc group. These are all the groups. Once the group is created, you can start adding users to the group. Use the usermod command with the capital G option. I'm creating a new user using the default options and then adding it to the group. So sudo user add u1. I can also add the user to the group when I'm creating it. Like this, user add minus capital G, engineering, the group name, and the username, u2. u2 already exists, so u3. And groups, u3. It belongs to u3 as its primary group and to engineering as its secondary group. To add a user to the new group as a secondary group, use the capital G option. Sudo usermod minus G engineering and the username u1. Don't forget to use the -a option to append the user to the group, so the user will remain part of all the other groups to which it already belongs to. So -a. Of course, it's engineering with double E. And groups u1. I've added the user to the group. Now the user is part of the engineering group. To change the name of the group, use the group mod command like this. Sudo group mod -n engineers, the new group name, and the old group name. The group name I'm renaming, engineering. In fact, I have renamed the group. To delete a group, run the group del command followed by the group name. Let's delete the group called engineers. Sudo group del engineers. On success, the group del command does not print any output. If the group you want to remove doesn't exist, the system will print an error message saying that the group does not exist. I'm running the command again. And it says group engineers does not exist. It was already deleted. Note that it's not possible to remove the primary group of an existing user without first removing the user. In this lecture, we'll be talking about user account monitoring, which means finding out who's logged into the system and what the users do. Because in Linux you can log in as a user and become another one by running the su command, there are two concepts, the real user ID and the effective user ID. The real user ID, or RUID, is the ID of the user who initially logs in and never changes. On the other hand, EUID, or effective user ID, is the ID of the user who executes a command in the shell. Maybe this seems weird, so let me show you practically what I mean. In this terminal, I'm logged in as student. This is the real user ID. But I can become root by running sudo su. Now, the effective user ID is root. Let's move ahead to user monitoring. The first command we'll cover is whoami. As its name suggests, the whoami command written in one word prints out the username of the effective user ID, who is root in this case. Who am I? Root. It's equivalent to ID minus un. To display the name of the real user ID, run who. The name of the user who initially logged in is student. Another useful command is id, which brings the effective user and its groups. If you want to find out who's logged into your system, run who. What the who command does is parsing and displaying the contents of /var run utmp. This is the file which logs the current users on the system. There's also another file called wtmp in /var log, which is like a history for the utmp file. It doesn't look too good. It maintains the logs of all logged in and logged out users in the past. This is the file. At this moment, there's only one user logged in. But I have another VM where CentOS is running, and using SSH, I'm gonna connect to this Ubuntu VM. In order to be able to do that, the SSH daemon should be running on Ubuntu. Install it if you haven't done yet by running sudo apt install OpenSSH-server. And check that the service is running by executing sudo systemctl status ssh. And it's running. I'm already logged in as root, so it's not necessary to run the commands by prefixing them with sudo. Use sudo only if you run the command as a non-privileged user. Check the network connectivity by pinging Ubuntu from CentOS. Let's see what's the IP address of Ubuntu. 192.168.0.112. So from CentOS, I'm pinging Ubuntu. And it's working. In order to be able to ping and connect using SSH, you have to put the network interfaces into bridged mode on both the Ubuntu and CentOS VMs. So here go to network settings, and the network should be put into the bridged mode. I'm connecting using SSH to Ubuntu. SSH, the username, student, and its IP address. I'm in. If I run the who command again, we'll see what users are logged in. Who minus capital H. Note that it's displaying the IP address of the logged in user and the time when it logged in. You can also add the A option to display more information. For a little more context about users, the simple W command provides a list of who's logged in and what they are doing, what's their current process. The header shows, in this order, the current time, how long the system has been running, 8 hours and 32 minutes, how many users are currently logged in, and the system load average for the past 1, 5, and 15 minutes. Note that the values for these load averages should be below 1 or there's a problem. The same information can be displayed running the uptime command. Each time a user logs into the system, a record for that session is written to a file x/var log wtmp. The last command we'll cover is last. It's very useful when you need to track users' activity or investigate a possible security breach. It shows a listing of the last logged in users. Last reads the wtmp file, this one, and prints information about the logins and logouts of the users. Records are printed in reverse time order, starting from the most recent ones. And if you want to restrict the output to a specific user, give that username as argument to last. For example, last student or last root, last reboot. The command has some options that could prove useful sometimes, and you can find more information about them in the man page of the command. In Linux, the access to the file system is managed through the ownership and file permissions. File permissions or file modes specify who can access, change, or execute a file on a Linux system. It ensures that only authorized users and processes can access files and directories. This is a key concept related to the entire system security. In this lecture, we'll discuss the basics of Linux permissions model. Each file has an owner and a group. By default, the owner is the user who creates the file, and the group is the primary group of that user. Note that it's not mandatory for the owner of the file to belong to the group owner of the same file. The ownership of a file or directory can be changed only by root using the change owner and change group commands. We'll take a look at them later in this section. For each file of the system, the permissions are assigned to 3 different categories of users: the file owner, the group owner, and others, anyone else or the whole world. There are 3 file permissions types that apply to each category: the read permission, or R, the write permission, or W, and the execute permission, or X. This concept allows you to specify which users are allowed to read a file, write a file, or execute a file. Note that the permissions have a different effect on directories compared to files. So in a nutshell, there are 3 permissions, read, write, and execute, for 3 categories of users: owner, group, and others. To view the file's permissions, run the ls-l command. Now, let me explain to you the part of the output that is related to file permissions. After the first character, which indicates the file type, come 9 characters which represent the file's permissions. The first triplet shows the owner permissions, the second one the group permissions, and the last triplet shows everybody else's permissions. The permissions for each class are always represented in a precise order: read, write, and execute. Let's take another example. The file owner, which is root, has read and write permissions, but doesn't have the execute permission. A hyphen indicates the absence of a permission. The group and the others have only the read permission. See how there's a hyphen instead of write and execute for both the group and the others. Let's see some more examples to deeply understand these concepts. In the next examples, I'll change the file's permissions using the chmod command, but please don't focus on the command. I'll show you how to change the file's permissions and come back to the use of this command in the next lecture. Just focus on how the permissions are represented and what do they mean to a file. As an unprivileged user, I'm creating a file and then I want to see its permissions. I'm using a redirection, users.txt, and let's see the permissions of the file. These are the file's permissions. The owner has both read and write permissions, so it can view and modify the file. The user is allowed to view the file's contents. And let's say w greater than users.txt. The user is allowed to modify the file contents as well. Now, I'll remove the read permission for the user. chmod u-r and the file. Now you see a hyphen instead of letter R for the user's read permission. I'm trying to view the file's contents, cat users.txt, and the user is not allowed to view the file contents anymore. Note that the user is still allowed to change the file contents. It still has the write permission. Now, I'll remove the write permission as well. chmod u-w users.txt. there are no permissions for the user, for the owner, and the user cannot modify the file anymore. The same rules are applicable to the group owner and the others categories. Note that read and write permissions are not applicable to the root user. Even though root does not have those permissions, it can both view and change the files. I'm temporarily becoming root by executing sudo su. I'm root. I'm creating a new file using a redirection. And I'm removing all files permissions. chmod 000 and the name of the file. You can see that nobody has any permissions. I'm trying to display the file's contents, cat interfaces.txt, and root was allowed to see the file contents, or ls greater than interfaces.txt. It was allowed to modify the file. As a conclusion, we can say that the file's read and write permissions are only for non-privileged users. And the last permission is execute. A file which has this permission is a shell script or a command. All Linux commands have the execute permission set. If a file which represents a command doesn't have the execute permission set, then it cannot be executed, it cannot be run. We'll take a short break, and in the next lecture, I'll teach you how to represent files permissions in numeric format. Linux file permissions are represented either in symbolic or in octal notation. In the last lecture, we've talked about the symbolic notation, which means using the R, W, and X letters for each set of permissions assigned to each user category. A hyphen is used if a specific permission is not set. The most common form of seeing the symbol notation is to run the ls-l command. I'll run the commands as a non-privileged user. Another method of representing Linux permissions is an octal or base 8 notation. You can see this notation as well as the symbolic one by running the stat command. For example, stat etc password. And you see here the file's permissions, both in octal and symbolic notation. The number that represents the permission in base 8 can be either a 3 or a 4-digit number with digits from 0 to 7. In fact, you can omit the first 0 value, so a 4-digit number with a leading 0 can be represented as a 3-digit number without that leading 0. So 0755 is equal to 755, or 0644 is equal to 644. When a 3-digit number is used, the first digit represents the permissions of the file's owner, the second one the file's group, and the last one the permissions of the others class. In this number notation, the values R, W, and X have their own fixed number value. R or read equals 4, W or write equals 2, and X or execute equals 1. A hyphen, which means no permission, equals 0. The permissions number of a specific user class is represented by the sum of the values of the permissions for that category. Let's take some examples. Let's suppose that a category has R, W, X permissions. In octal notation, that means 4, R is 4, plus 2, W is 2, plus 1. Because X is 1. So in fact, X 7. Another one, R, W, and a hyphen. That category doesn't have the execute permission. And that means 4 plus 2 plus 0 equals 6. Or if you have R hyphen hyphen, it means 4 for read, and then 0 for both write and execute. So equals 4. Now let's try some examples with all permissions. What is its octal notation? And it means 4 plus 2 plus 0 for the user, for the owner, 4 plus 2 plus 0 for the group, and 4 plus 0 plus 0 for the others. So the files permissions in the octal notation are 664. Let's take another one. This is not so common, but is correct. A file can have any possible permissions. And it means 4 plus 2 plus 1 equals 7 for the owner, 4 plus 0 plus 0 equals 4 for the group, and 0 plus 2 plus 1 equals 3 for the others. And the last one? And we have 4 plus 2 plus 1 for the user, 4 plus 0 plus 1 for the group, 5, and 4 plus 0 plus 0 for the others. Until you understand how to transform the permission represented in the symbol notation into the numeric one, you can always check both systems using stat. The octal notation and the symbolic one. This is the octal notation and this is the symbolic one. This D here is for directory, for the files type. It doesn't belong to the files permissions. If you need more examples, you can take a look at this wiki page and see all possible combinations. Chmod or chmod is a command in Linux that allows you to change the permissions or the access mode of a file or a directory using either the symbolic or the numeric system. Note that only root or the file's owner can change the file's permissions. Let's take a look at the command's general structure. There's the command chmod, who, operation, permissions, and the file name. Who signifies the user's category whose permissions will be changed. Some letters are used, and the possible ones are U for the user that owns the file, G for the group that the file belongs to, and O for the other users. The operation flags define whether the permissions are to be removed, added, or set. A hyphen means remove the specified permissions. The plus sign means add the specified permissions. And equal means change the current permissions to the specified permissions. The permissions are specified using the letters R, W, and X. I'm gonna show you a bunch of examples so you can deeply understand it. As an unprivileged user, I'm creating a new file. And let's see the file's permissions. These are default permissions of the newly created file. And I'm removing the right permission for the owner. All other permissions remain unchanged. So chmod, the owner uses the symbol U, it comes from the word user, minus W and the name of the file. The right permission of the owner was removed. Now you see a hyphen instead. I'm adding the read, write, and execute permissions for the owner. The permissions of the group and others remain unchanged. Chmod, U plus R, W, X, and the file. The owner has all permissions. And another one. I'm removing the execute permission for the owner, U minus X. I'm adding the write permission for the group, G plus W, and I'm removing all the permissions for the others, so O minus R, W, X, and the file. If you want to be verbose or display a message for each operation, add the -v option after the command name. Let's go ahead. I'm removing the read permission for both the owner and the group. Owner group -r. I'm adding the execute permission for the owner, so comma u plus x, and I'm removing all the permissions for the others, comma o minus r wx, and the file. If you want to change a permission for all categories, use the A letter. I'm adding read and removing write and execute for all user classes. The final permissions of the file will be read only for all user categories. So chmod A plus R, comma, A minus WX, and the name of the file. So we notice that plus is adding permissions and minus is removing permissions. You can also change the current permissions to the specified permissions using the equal sign and the required permissions. chmod UG, owner and group, equals RW, read and write, comma O, so others, equals, and an empty space, and the name of the file. This command will give the owner and the group the permissions to read and write the file, and the others will have no permissions at all. So the final permissions of the file will be RW hyphen RW hyphen 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 hyphen. Perfect. Note that if no permissions are specified after the equal symbol, all permissions from the specified user class are removed. Sometimes it's easier to change the permissions using the numeric method. This is also known as the absolute changing mode because you set the permissions for all three user classes, owner, group, and others, at the same time. Let's see some examples. In the next example, I'll give to the file's owner the read and write permissions, and only the read permissions to the group and all the other users. So chmod 644 and the file. I'm giving all permissions to all categories of users. And the last one, I want the owner to have only the read permission and the group and the others to have no permissions at all. So chmod 400 and the file. To recursively operate on all files and directories under a given directory, use the capital R option. I'm creating a new directory structure with some directories and files inside. This is the new directory structure. Let's see the permissions of all files and directories. I'm using the capital R option of ls to display the directory recursively. And this is the permissions. And I want to change the permissions of all files and subdirectories under the dir1 directory to 750. So chmod minus capital R 750 and the directory name, dir1. And I'm displaying the permissions of its contents again. Note that such a command is not recommended since the permissions of files have different effects as the permissions of directories. In Linux, a file does not have the same permissions as a directory. And in the last example of this lecture, I'll show you how to set the file's permissions to be the same as those of a specified reference file. For example, the following command will assign the permissions of one file to another one. I'm creating a new file. Okay, I've got a permission denied error because probably the file already exists and it's owned by root. Let's check it. Okay, there's the file. I'm creating it under another name. I'll simply write i.txt. This is the first file and this is the second. And I want the user.txt to have the permissions of i.txt. So chmod --reference the reference file, i.txt, and the file. Let's see the file's permissions. Now they have the same permissions. We'll take a break and we'll see in the next lecture what do the permissions of directories actually mean. See you in 2 seconds. Let's move ahead and talk about the effect of the permissions on directories. As you'll notice, the permissions on directories have a completely different effect as the permissions on files. I'm going straight to the point with an example. I'm creating a new directory with a file and another directory inside it. So mkdir, Linux, and Ubuntu. I'll add the -p option because I want to create the directories simultaneously. And let's say who -a greater than Linux users.txt. I'll set only the read permission on the directory. So chmod 400 and the directory name Linux. Let's see its permissions ls-ld and the name of the directory. I have used the D option to see information about the directory and not about its contents. So the Linux directory has only the read permission set for the owner, and the user I'm logged in as is the owner. Let's try to list the contents of the directory. And surprise! We see the name of the file and the directory that resides within my directory, but some errors and strange question marks as well. I'm moving into the directory using cd. And I can't. I'm not allowed to enter the directory. I'm trying to remove a file from the directory, rm-rf, Linux, and the file. As I'm the owner of the file, I should be able to remove it. But surprise, I'm not allowed. So the read permission on a directory only means that the directory's contents can be shown by running ls. It doesn't give you access to the contents of the directory. That's why I couldn't remove the file or move into the directory. I don't have access to the directory's contents. Imagine the directory as a glass box where you can see what's inside it, but you cannot touch it. Now if read means showing the directory's contents, why did I get that error when I was running ls-l? When you run ls-l, the command tries to access the contents to see the type, permissions, owner, and so on, and it's not allowed. The ls command was not allowed to read the contents metadata, hence that error. And when you run ls with no options, you run in fact an alias which is ls --color equals auto. The --color option tries to identify the file's type to display its name colored based on its type. For example, you see directories in blue and regular files in black, and that was not allowed. This option was the problem. If instead of the alias I run the original ls command and not the alias by writing a backslash before its name, then I'll get no error. \ls and the directory name. Note that you can rename the directory, that being allowed as you have the required permissions on its parent. I'm renaming it back. Let's add the right permission for the owner. chmod 600 and the directory's name. Now the owner has both read and write permissions. And I'll try to do the same as before. ls-l linux, ls linux. I can see the name of the files and the subdirectories, but no other information. cd linux, I can't enter the directory. rm linux users.txt. And I cannot remove or create files in the directory. At first sight, it seems that the write permission didn't change a thing, and that's exactly so. if the execute permission is not set, the write permission has no effect. But if you set both write and execute, write means that the directory's contents can be modified, create new files or subdirectories, rename or delete existing files or subdirectories. So, as a conclusion, the write permission has effect only along with the execute permission. And finally, the execute permission on a directory means access to that directory's contents. I can move into the directory using cd, I can remove or create new files. So chmod 700 and the directory's name. Now I can do anything. ls linux, ls-l, I can enter the directory, I can remove files or create other files. I have a total control on that directory. At the end, I have a question for you. What will it happen if a directory has all the permissions for a user's class, but a file inside it has no permissions at all? Could, for example, a user from that class remove the file? Let's test it. So, the Linux directory has all the permissions for the owner. But the file inside the directory will have no permissions at all. So chmod 000 linux a.txt. The user has no permissions on a.txt. And I'm trying to delete the file rm linux a.txt. It says that's a write protected regular file, but I continue and try to remove it. And the file was removed. We notice that the user had no problem removing the file, even though the file's permissions didn't allow that. So the permissions of the parent directory were more important than the file's permissions. Keep this in mind. We've just seen that permissions have different effects on files and directories. If you want to recursively set the permissions of all files to a specific value, then you should somehow exclude the directories in the path. If not, the directories will have the same permissions as the files, and this is not good. Just imagine a directory that has only the read and write permissions. It will be unusable. So I cannot simply run something like chmod -r644 and tilde being my home directory. It will change the permissions of both the files and the directories. And I just wanted to change the file's permissions. The solution to this problem, which believe me, it's a very common one, is to combine find and chmod together. You search for a file or a directory type and execute chmod with different values for each type. In the next example, I'll set the permissions of all the files in my home directory to 640 and the permissions of all directories to 750. First, I'll find all the files in my home directory. So find home directory, type F. Minus type F. These are all the files. And then I write exec chmod, the permissions 640, a pair of curly braces, a white space, and \semicolon. We have discussed this structure in the lecture about find. Take a look there if you feel the need. The pair of curly braces represents the file found by find, and \semicolon ends the command that needs to be executed. Take it as the syntax. And it changed the permissions of the files to that value. I've got some permission denied errors because there are files owned by root. I have created them in the previous lectures, for example this one. You see, it's owned by root, and the non-privileged user student cannot change its permission. Now I'll change the permissions of all directories to 750. So the same command, just I have type D, I'm searching for directories, and the permission value will be 750. Now all the files in the home directory have 640 and all directories 750. and you see the file's permissions, 640, and the directory's permissions. Instead of type F, I write type D. And their permissions are 7, 5, 0. In Linux, all files are associated with an owner and a group owner and assigned with permissions for the file owner, the group members, and the others. In this lecture, I'll show you how to change the user and the group ownership of files and directories using the change owner and change group commands. Before going on, you should know that only root can change the file owner, so change owner or chown is a root-only command. And in regards to changing the group, normal users can change the group of a file only if they own that file and only to a group of which they are a member of. Root can access the group ownership of all files. To see the owner and the group of a file or a directory, you normally run the ls-l command. Let's practice the change owner command. To change the owner of a file or a directory, run the change owner command followed by the username of the new owner and the target file or directory as an argument. Let's create a file as a non-privileged user and then change the ownership. This command will list information about the CPU, and I'm redirecting everything to a file. This is the owner and this is the group owner. If I try to change the owner of the file as a non-privileged user, I'll get an error, even though I'm the current owner. It's not possible to disown a file. Let's find the user that we have created in the last sections. There's a user called Tor. You can use any other user that exists on your system. So change owner, Tor, and the file. And I've got an operation not permitted there. And as root, I'll change the owner to another user. I'll run the same command as root by prefixing it with sudo. And the owner was changed. Remember that it's not mandatory for the owner of the file to be part of the group owner of the same file. In this example, Tor does not belong to the student group. It belongs only to two groups, Tor and sudo. If you want to change the owner of more than one file, just specify the files as arguments to the change owner command, like this. Sudo chown, the new owner, Tor, and the files and directories. cpu.txt, interfaces.txt, i.txt, and the directory, Linux. And I've changed the owner of all of those files and directories. Also, the numeric user ID can be used instead of the username. Let's see a user ID. For example, the user called U1 has the user ID 1005. The following example will change the ownership of the file to a new owner with the user ID 1005. So sudo chown, the user ID 1005, and the file. Now the user with that ID is the owner. If a user ID exists having the same value as a username, in this example, suppose there's also a username called 1005, then the ownership will be transferred to the username. To avoid this confusion, prefix the user ID with a plus sign, like this. This is much better. It had the same effect. The change owner command can be used to change both the owner and the group of a file or a directory. Just use a colon between the new owner and the group of the file. Sudo change owner, student, colon, daemon, cpu.txt. Both the owner and the group should already exist. On some Linux distributions, you can also use the dot symbol instead of the colon symbol to separate the owner from the group. Like this. To change only the group ownership of a file or a directory, invoke the change group command or chgrp followed by the new group name and then the target file or directory as argument. For example, I'm only changing the group of the cpu.txt file to sudo group. Sudo chgrp, the new group, sudo, and the file. The new group of the file is sudo. You can get the same result by running the change owner command followed by a colon and then the new group with no space between them. So sudo change owner, colon, the new group, and the file. This command will have the same effect as the last one. To recursively operate on all files and directories under a given directory, use the capital R option. I'm changing both the owner and the group of all the files and directories in my home directory to my current user and its primary group. So sudo chown-r student :student and the directory, my home directory. Let's dive deeper into Linux file permissions. Besides read, write, and execute for the owner, the group, and the others, there are 3 extra special permissions for each file or directory. These are suid or set user ID, sgid or set group ID, and sticky bit. These special modes are for a file or a directory overall, not just for a user category. Let's see what they mean and start with the first one, which is suid. By default, Linux commands and programs run with the same exact permissions of the user who executes them. Let's take a common Linux command such as cat. The cat command runs with the permissions of the user who executes it. If the user has the rights to view a file, which means the read permission, then the cat command will also have the right and will display the file's contents. It doesn't matter that the owner of the cat executable binary is root. The owner of the executable is root, but the program will run with the privileges of the user who executes it. This is how Linux works, and this is really important in regards to the whole system security, since each user has very limited access and all the commands run by a user will have the same access in the system. Sometimes it's required to temporarily treat users as root or as another user, and this is where the suid or set user ID bit comes into play. When an executable file with suid is executed, the resulting process will have the permissions of the owner of the command, not the permissions of the user who executes the command. This is very important. Keep this in mind. Let's return to the cat command. If the cat binary has the suid bit set, then the cat command will run only with root privileges, no matter who runs it. That's because root is the owner of the executable file. Let me demonstrate this with an example. As a non-privileged user, I'll try to display the contents of the shadow file using cat. So cat etc shadow. And of course, I've got permission denied because the cat command ran with the permissions of the user who executed it, and that was a non-privileged user. If we display the file's permissions, we'll see that the user called student, the current user, belongs to the others class and has no permissions at all. Hence cat has no permissions at all on that file. But if I set suid on the cat binary, the command will have the permissions of its owner, which is root, no matter who runs it. Let's set suid on the cat executable file. There are 2 ways to do that. If you want to use the numerical mode, then simply prepend 4 to the existing permissions. Let's see the existing permissions of cat. Now, the existing permissions in numerical mode are 0, 7, 5, 5, or simply said 7, 5, 5, and the new permissions will be 4755. By the way, if you run the stat command on a file, you'll see a 0 before the 3 digits that represents the permissions. That means that the file has no special permissions like SUID, SGID or sticky bit. I'm setting the SUID bit on the file, of course as root. You can verify if SUID bit is applied or not on a file by using the ls-l command. The file is displayed in another color. Simply look at the position of the execution permission for the owner. The letter S at that position means SUID bit. In some cases, you will see a capital S instead of a small s. Capital S indicates that there's no executable permission applied to that file. I'm removing the execution permission. You'll see a capital S on that position. I'm putting back the execution permission for the owner. You can also check the SUID bit by running the stat command. You see a 4 on the first position and S on the execute position of the owner. The second way to set the SUID bit on a file is to use the symbolic mode. Sudo chmod u plus s and the path to the file. Now the cat command has the SUID bit set, and that means that it will have the permissions of its owner, which is root, no matter who will execute it. As a non-privileged user, I'll try to see the contents of the shadow file again. And this time, the file contents were displayed because the command ran with root privileges, even though a non-privileged user had executed it. In fact, at this moment, any non-privileged user can see any file of the system. Now, if you've followed this example, it's important to remove the SUID bit because otherwise bad things could happen in the future. And I'm checking the permissions. Oh, sorry, I have removed the execution permission instead of SUID. No problem, I'll put it back. My mistake. So minus S to remove SUID. So these are the correct permissions. 7, 5, 5. And cat etc shadow, and as expected, I've got the permission denied error. Now that you know what SUID means, how to set and display it, maybe wonder why is that necessary? At first sight, it seems a security risk. Let's think about the passwords. On Linux, stored passwords are saved in a file, and only someone with root privileges can access the file that contains the passwords. This is the file that contains the passwords. That might sound fine, but if only root can access stored passwords, how do non-privileged users have access to change their own passwords? And the answer is SUID. The command, which in this case is PASSWD, this command, has the SUID bit set, and that means that when someone runs the command, this command is run with root privileges, and not with the limited privileges of the one that executes it, because root is the owner. Let's check if that's true. Root is the owner, and the program has the SUID bit set. There are lots of Linux commands that use the SUID bit to give the command elevated privileges when run by a regular user. To find all commands that have the SUID bit set, run the find command with the -perm option like this. Find the path usr bin, for example, -perm 4000. This means find all files that have at least these permissions. I need to put a minus sign before the permissions because I'm searching for all files that have at least these permissions. All of these executable files have the SUID bit set. Also note that programs that run with elevated privileges or have the SUID bit set can pose security risks if they are not created with a security by design mindset. The problem is that if intruders find an executable file that belongs to the root user and has the SUID bit set, they can use that to exploit the system. It's necessary to ensure that insecure programs with the SUID bit set are not installed on the system. Another special permission is called sgid or setGroupID. It's very similar to SUID, the only difference being that the executable file having sgid configured will run with the same permissions as the group owner. In practice, we'll explicitly set sgid mainly to directories. If you set up sgid on directories, all files and subdirectories created inside that directory will be owned by the same group owner of the directory where sgid was configured. This is very useful in creating shared directories, which are directories that are writable at the group level. I'm going straight to the point with a practical example. I'm creating a new group called programmers and 2 new users that will belong to this group as their secondary group. They will also belong to other secondary groups. I'm becoming root, sudo su. So group add, programmers. And user add, -s the shell bin bash, pr1, the first programmer. And the second programmer, pr2, programmer 2. I'm adding the new users to the programmers group I've just created. User mod -a capital G, programmers, and the users, pr1 and pr2. I'm creating a new directory for the group. I want the directory to be shared to the group, but no other users to be able to work on it. So mkdir/programming. This will be the shared directory. The owner of the directory will be one of the programmers and the group owner the programmers group. So change owner pr1 programmers, the group and the directory. Let's check it. It's okay. I'm also setting the desired permissions on the directory. I want only the owner and the group to have access to it. Change mode 770 and the directory. Now it's perfect. I'm becoming one of the programmers by executing su and the username su pr1. I'm pr1 and I'm moving to the shared directory and creating a file. And we notice that the group owner of the file is the primary group of the creator and the other users in the programmers group will not be able to change the file, to work on it. Of course, I could give the permission to the other category, but this is a security issue and I don't want it. So this is not good. Now I'll set the sgid bit on the directory. To set sgid, I'll prepend 2 to the existing permissions. I'm exiting to be root and I'm setting the permissions. chmod 2 and the existing permissions. Or if you want to use the symbolic mode, use g+s. To verify if sgid bit is applied or not, use the ls or stat commands. Simply look at the position of the execution permission for the group. The letter S at that position means that the SJD bit is set. If you see a capital S instead of a small s, it indicates that there is no executable permission applied to that directory. However, this is not common at all. After setting SJD, I'm becoming a user of the group, moving to /programming, and creating a file and a directory. So su pr2, for example, the other user. And I'm moving to that directory. And touch source2.cpp. And mkdir golang python. See the difference? The new files and directories have the group owner, the group of the parent directory, that with SJD bit set, instead of the primary group of the creator. On the group position, have a look at the differences between these two lines. This is in fact what SJD does. Now anyone in that group, and only in that group, can work with the file. Maybe it seems like a small detail, but it's really important if you want to have shared directories at the group level. Let's take a look at the last special permission, which is called the sticky bit. The sticky bit is applied mainly to directories, and if it's set on a directory, then a user may only delete files that he owns or for which it has explicit write permission granted, even when he has write access to the directory. This is designed for directories like /tmp, which are world writable, but where it may not be desirable to allow any user to delete files at will. This allows you to create a directory that everyone, including the processes the users launch, can use as a shared file storage. The files are protected because, again, no one can delete anyone else's file. Let's take a look at an example to see how the sticky bit works. As root, I'm creating such a shared storage directory. So I'm becoming root mkdir /temp. And I want it to be world writable. Anyone can have its own files there. Chmod 777 and the directory. Now, a random non-privileged user is coming and creating some files in that directory. So touch file1 and file2. And just to be sure that no one else is able to remove his files, the user changes the file's permissions to 600. So chmod 600 and the files. Normally, no other user should be allowed to delete these files. The file's permissions do not allow anyone to read or write the files, but the parent directory's permissions allow that. As we've already seen in the file permissions section, if a user has permissions on a directory, he can remove all the files in that directory, even though the file's permissions would not allow it. So, a second non-privileged user is coming and trying to remove one of the first user's file. I'll pick a random user. Tor. So, su tor. I am Tor. I'm moving to that directory and trying to remove a file. rm-rf file1. And the file was removed, which is not good. Now, as root, I'll set the sticky bit on that directory. I'm exiting Tor and be root again. To set the sticky bit, prepend 1 to the existing permissions. So chmod 1 and the existing permissions. Or if you want to use the symbolic mode, run chmod o plus t and the directory. To verify if the sticky bit is applied or not, run the ls-l command. Simply look at the position of the execution permission for the others class. The letter T at that position means that the sticky bit is set. If you see a capital T instead of a small t, it indicates that for the others class, there's no executable permission applied to that directory. However, this is not common at all. Having the sticky bit set on /temp directory, I'll try as a non-privileged user to remove the file of the first user. I'm becoming Tor again. And I'm moving to /temp directory. And I'm trying to remove file2.txt. And this time, the user cannot delete the file. This is what the sticky bit does. Also note that the displayed message is operation not permitted and not permission denied. Other shared directories with the sticky bit set are /var/tmp and /tmp. Users and processes can create files, and even though they can read and execute files owned by other users, they are not allowed to remove them at will. That's all about permissions. You now have a good understanding of what they do, how to change them, both using the numerical and symbolic mode, and check them. This is a key concept in Linux, so my advice is to take your time to deeply understand how file permissions work. Practice them as much as possible. On Linux, all files and directories are created with a default set of permissions. The umask utility allows you to view or set the base or the default permissions given when a new file or directory is created in Linux. It is used by mkdir, touch, and other commands that create new files and directories. Just to be clearer, I'm gonna create a new file and a new directory. So mkdir, my dir, and touch, my file. The file and the directory were created with some permissions. x0775 for the directory and 0664 for the file. Now the question is, why these specific permissions and not other ones? And the answer is that umask was used to create the file and the directory with those exact permissions. Let's see how it works. It's considered that the default creation permissions are 0666 for files and 0777 for directories. Take these values as they are. Now, the current permissions for the newly created files and directories are calculated in the following manner. The umask value is subtracted from the default permissions and the result will be the current permissions. To view the current umask value, simply run umask without any argument. So x value is 0002. Let's subtract the umask value from the default values. And we have for directories 0777 minus the umask value, so 0002 equals 0775. And for the files, 0666 minus 0002 equals 066 and 4. So the current permissions will be 0664 for the newly created files and 0775 for the newly created directories. These are the exact permissions of the file and the directory I've just created. You see the permissions? Let's suppose that from this point on, I want all newly created files to have 644 as permissions. That means 0666, the file's default value, minus umask equals 0644. This is a simple equation and we have to determine the desired umask value. And doing the math, we'll find out that the desired umask value must be 0022. You can change the current session umask value by running umask followed by the desired value. So umask and the desired value 0022. I'm creating a new file and directory. mkdir my dear one, and touch my file 1. And the permissions are the expected ones. 644 for the file and 755 for the directory. Note that changing the umask value has effect only on the files that will be created from that point on. The permissions of the existing files are not affected. And note that umask affects only the current shell session of the current user. If you want to make the umask value permanent for a specific user, then you should edit the user's shell configuration file such as .bashrc. Just open the file with your preferred editor and at the end write umask, a white space, and its desired value, like this. I'm going to the end by pressing capital G. I'm pressing O to enter the insert mode, and I'm writing umask and a new value. This is how you set umask permanently. Though note that it's not common to change the default umask value. Linux file permissions provide a basic level of security and access control. Apart from these permissions, Linux also has advanced access control features like ACLs, access control lists, and attributes. The attributes define the properties of the files. They depend on the support of the underlying file system, such as ext4, where the attribute data must be stored along with other control structures. Each file attribute can have one of the two states, set and cleared. The attributes are considered distinct from other metadata, such as file system permissions, owner, group, timestamps, size, and so on. The ls command does not display the file attributes. I'm not seeing the file's attributes. To list the attributes of the files and the subdirectories of the current directory, run ls a_tr. I've got this permission denied error because probably this file is owned by root. No, it's owned by the current user, but it has no permissions on it. I'm simply removing the file. I'm executing list attributes again. We see many hyphens and the E letter. Each letter you see indicates an attribute which is set, and the hyphen indicates that the attribute is cleared. For example, E means extend format, and it indicates that the file is using extents for mapping the blocks on disk. In addition to E, there can be several other letters in the output. Let's see the man page of CHATTR. So man, CHATTR, change attribute. To set an attribute, use the plus sign, which causes the selected attribute to be added to the existing ones, and the minus sign causes the attribute to be removed. Also note that most of the attributes can be set or cleared only by root. Let's take a look at the most useful ones. You see a list with all of them in this paragraph. A file with the A attribute set can only be opened in append mode for writing. Appending means adding to the end of the file. Only the superuser possesses the capability to set or clear this attribute. So sudo change attribute plus a user.txt ls a_tr user.txt, and we see that the append attribute is set. Now no one, not even root, can change the contents of the file. You can only append or add to the end of the file. It's not permitted, and not even root can do that. But I can append to the file. It was permitted. Another useful attribute is capital A, which means no access time updates. When a file with the capital A attribute set is accessed, its access time record is not modified. This avoids a certain amount of disk input-output for the system. This attribute can be set and cleared both by the file owner and root. Let's check the A time of the file. stat user.txt. This is the access time. And I'm setting the capital A attribute. I'm listing the attributes. The attribute was set, and I'm accessing the file again. Let's check if the access time was updated. And we notice that the A time of the file was not updated. And the last attribute I'm gonna show you is I, which means immutable. A file with the I attribute set cannot be modified. It cannot be deleted or renamed. No hard link can be created to the file. Most of its file's metadata cannot be modified, and no data can be written to the file. The file is frozen. Only the super user has the capability to set or clear this attribute. I'm setting the attribute to another file. Sudo change attribute plus I and the file name. And as root, I'm trying to remove the file. It's not permitted. Or I'm trying to change the file. It's not permitted. I'm trying to append to the file, so to add to extend. It's not permitted either. But is root allowed to change the file's permissions? It's not allowed. This attribute is useful if you want to avoid the accidental deletion or change of a very important file. Note that you can set these attributes recursively as well. Change attribute minus capital R plus I and the directory's name. And of course, I have to run the command as root. List attributes minus capital R D1. The capital R option will list the attributes of a directory recursively. It means that you'll show the attributes of the subdirectory's contents. They are immutable. Maybe changing the file attributes is not a very common administration task, but I think a basic knowledge is required just in case you run into them. Now if I want to delete the files, I have to clear the immutable attribute first. I'm clearing the attribute and then removing the files. In Linux, a running instance of a program is called a process, and it runs in its own memory space. Each time you execute a command, a new process starts. A process is an active entity, and it means that the binary code is running in the RAM at the moment, as opposed to a program or command which is considered to be a passive entity. It's just a file on the disk. A single program or command can create many processes when run multiple times. Just imagine that you want to copy two large files and you run the cp command once for each file. Each instance of the running command is a process. But not all commands create a process. At the beginning of the course, I said that there are two types of commands in Linux. Commands that are executable files on the disk and shell built-in commands. To check if a command is an executable file or a shell built-in, use the type command. Type ls. ls is an executable file. Type rm. Type cp. Type type. Type is a shell built-in, or type cd. cd is a shell built-in. Type umask, and so on. Only when running a command which is an executable file, a new process is created. If a shell built-in command is run, no process is created. In Linux, each process has a process ID and it's also associated with a particular user and group. The process has the access rights of that user and group. If an executable file that represents the command does not have the SUID bit set, then the process has the permission of the user who executes it. This is normal behavior and is very important related to the whole system security. If a non-privileged user runs a command, like cat, the process that starts has the same rights as the non-privileged user that executes the command. In this example, the cat command was not allowed to view the shadow file because the user student that ran the command does not have that permission. The student user has no permission. But if the binary file that represents the command does have the SUID bit set, then the process has the permissions of the owner of the binary file, no matter who executes the command. I've gone deep into permissions and SUID in the previous section. Take a look there if you need a short recap. For example, if a user runs the password command, the process has root access because the binary file has the SUID bit set and is owned by root. This is very important regarding processes and system security. If you wondered why Linux is more secure than Windows and there are no viruses, then this is the answer. Normally, any malware or virus a user installs and runs will have the user's rights in the system, and they are extremely limited. Just to make my point clear, let's suppose a virus gets into the system and wants to remove all the files. The user who got tricked to install the virus is not root, it's a non-privileged user. This is the Linux principle that says that you should not use root for common activities like browsing the web, reading mails, or editing documents. In fact, in many distributions, like Ubuntu, the root login is disabled. So, I simulate such a virus and try to delete all configuration files. I'm logged in as a non-privileged user called student. So, rm-rf/etc. And a star. I want to delete all the files. I'm hitting enter without any fear. As you can see, nothing has happened. The command, so the possible virus, couldn't do anything harmful to the system. You can replace rm with anything else you wish. Let's go ahead and talk about parent and child processes. In Linux, all the processes in the operating system are created when another process executes the fork system call. There's an exception, which is the first process that starts when the system is booting, and that's init or systemd, and has the process ID 1. This is init. It's the first process that starts and has the process ID 1. The process that used the fork system call is the parent process, and the created process is its child. In other words, a parent process is a process that has created one or more child processes. A parent may have multiple children, but a child process has only one parent process. When you execute a command like ls or who, a new process is created, and the shell, which is normally bash, is its parent. So bash was the parent of the process who. Other types of processes are zombie and orphan processes. The operating system maintains a table that associates every process to the data necessary for its functioning. When a process terminates its execution, the operating system releases most of the resources and information related to that process. A terminated process whose data has not been collected is called a zombie or defunct process. Normally, zombie processes are removed quickly from the memory and don't use any of the system resources. Orphan processes are the opposite situation to zombie processes, referring to the case in which a parent process terminates before its child processes. It's the situation when you close the terminal while there are still processes running in it. I'm executing a command that will take a long time. And I'm closing the terminal. The ls command became orphan. By default, all of those processes will receive the hang up signal and get terminated. We'll talk about signals later in this section. There's also the possibility to be adopted by another process such as init or systemd. We'll talk about this in another lecture when we'll discuss the no-hop command. In the context of processes, you'll also hear the term thread. What is the difference between a thread and a process? Multiple threads can exist within the same process, and they share resources such as memory, while different processes do not share these resources. Let's consider a word editor that's running. It's a process. Examples of threads in the same process are automatic spell check, automatic saving of the file while writing, and maybe auto-completion. Threads are basically sub-processes that run in the same memory context of a single process and make the application responsive. Threads may share the same data while executing. Now that you know what is a process and a thread, maybe you wonder what is a task. Although the term task is more used on Windows, on Linux there are commands like htop, which sometimes call processes tasks. So tasks and processes are synonyms. A common administration task is to check if a specific process is running and what are its properties. There are a number of commands that you can use to find information about the running processes, with ps, pgrep, ps3, and htop being the most commonly used ones. Note that any user, not only root, can see information about the running processes. Let's start with the first command, ps, which stands for process status. I'm running the ps command without any option. It's displaying the processes running in the current terminal, and there are only two, the bash shell and ps, the command I've just run. The displayed information consists of 4 columns: PID, TTY, time, and CMD. Let's take them one by one. PID is the process ID, a positive integer number that's automatically assigned and used by the kernel to uniquely identify each process. This is probably the most important information when looking for a process because it allows you to interact with the process. TTY represents the name of the controlling terminal for the process. Time is the cumulative CPU time of the process, shown in minutes and seconds, and CMD the name of the command that was used to start the process. This output is not very useful because it doesn't contain too much information. Maybe you want to see all the processes that are running. PS is a very complex tool with lots of options. The most frequently used options are -C to list all processes and -F to do a full listing format and display detailed information about the processes that are running. So ps -E. It's displaying all processes that are running, and ps -F full status information. It's displaying detailed information about the processes. And ps -EF, it's also very common. It's displaying all processes with detailed information. Let's see how many processes are running. And on my system, there are 181 processes that are running. I'll pipe the output of ps -EF to less. Let's take a closer look at the output. The user column indicates the user who runs the process. PID is the process ID, and PPID is the parent process ID, the PID of the parent. As time indicates the starting time, which is the time when the process was started. If you see a question mark in the TTY column, it means that the process has no terminal to which it is attached. It's probably a system service or a daemon. Daemons are the processes which run in the background and are not interactive. They have no controlling terminal. In Linux, the names of daemons end in D. Colloquially, when someone says the word daemon, you think of a server application that provides a service. Some well-known daemons are SSHD, which is the OpenSSH server daemon, HTTPD, which is the Apache web server daemon, named, which is a DNS server daemon, or MySQLD, which is a database server daemon. Another frequently used combination of options is AUX. OX. You can run the ps command in the BSD form without a dash before the options, or in the Unix form with a dash before the options. So ps dash AUX, or ps AUX without a dash, without the minus sign. Let's pipe the output to less. The extra columns you are seeing have the following meanings. %CPU is the CPU utilization of the process expressed as a percentage. %mem is how much memory the process is using. It's the ratio of the process's resident set size to the physical memory on the machine, expressed as a percentage. VSZ is the virtual memory size of the process in kilobytes. It includes all the memory that the process can access, including the memory that is swapped out, the memory that is allocated but not used, and the memory that is from shared libraries. RSS is the size of the physical memory that the process is using. It indicates how much memory is allocated to each process. It does not include memory that is swapped out, but it includes the memory from shared libraries as long as they are actually in the memory. It does include all stack and heap memory. And stat indicates the process state using a code. Possible values displayed are S for sleeping, R for running, Z for zombie, T for stopped, and I for idle kernel thread. A less than sign means high priority, and the uppercase N means low priority. This is the running process. Let me tell you a few words about the running process. A CPU core can run a single process at a specific moment. If you have a CPU with 4 cores, then no more than 4 processes can run simultaneously. Actually, it only appears that the operating system is performing the jobs simultaneously. In reality, it is running only one process per core at a time, but quickly switching between all of its ongoing tasks or processes. The Linux kernel will execute some instructions from process A, and then will set process A aside and executes instructions from process B. The concept of switching between queued processes is called process scheduling. The ps command also allows you to sort the output using the - sort option. For example, to sort the output by memory usage, you should use ps aux - sort equals %mem pipeless. It's sorting in ascending order, and if you want to sort the output in descending order, add a hyphen before %m. It's in ascending order, and now I'll sort them in descending order. For example, the GNOME shell consumes 11% of the memory. Let's see some other useful options. If you want to see only the processes of a specific user, use the -u option. ps -f -u student. Or -u root. I'm seeing all the root's processes. It's very common to filter the output of the ps command with grep. For example, you want to check if a specific process, especially a daemon, is running or not. Let's see if sshd is running. ps -ef pipe grep sshd, and it's running. You can get another output depending on your particular case. Now, I'll show you something important. Let's suppose you want to check if a process called xyz123 is running. Of course, it's not, but let's check it anyway using ps and grep. Even though no such process is running, the grep command found and returned a line from the output of ps. What's happening here is that when executing the commands using the pipe, 2 processes were created, ps and grep. One of them is grep, and it appears in the process list as the command that was executed, so as grep xyz123. So in fact, grep has selected itself from the process list. So when you search for a process this way, if the process is running, you'll get in fact at least 2 lines, one of them being the grep command, which selects itself. Because this construction, ps pipe grep, is very common, there's another command called pgrep, which comes from ps grep and looks up for a process using its name. Let's see if sshd is running. pgrep sshd or pgrep python 3. So pgrep is looking through the currently running processes and listing the process IDs which match the selection criteria to stdout, so to the terminal. If you want to see both the process IDs and the names, add the -l option. Like this. This is the PID, the process ID, and the process name. Note that it's not looking for the whole name of the process. It's looking also for partial names. You can also search for the processes owned by a specific user. pgrep -u root sshd. I'm searching for processes named sshd which are owned by root. So we've seen so far that ps is a complex command with lots of options, and in most cases it satisfies our requirements. However, you should know that there's another command called ps3 which displays a hierarchical tree structure of all running processes. I'll pipe its output to less because it doesn't fit well on the screen. ps3 pipe less. ps3 merges identical branches by putting them between square brackets and prefixing them with an integer that represents the number of branches. This makes the output more readable and visually appealing. To disable the merging of the identical branches, use the -c option. ps3 -c. The threads of a process are found under the parent process and are shown with the process name in curly braces. This command has a bunch of options as well, and if you are interested you can take a look at its man page. In the previous lecture, we've talked about how to get a static view of the running processes using the ps command. In this video, we'll be discussing top, which provides a dynamic real-time view of the running system. Note that the top command has been around since the beginning, and there are some variants of it. In this tutorial, I'll show you the top utility which comes with the latest Ubuntu version. I'm running the command top. The default display contains two areas of information: the summary area and the task area or process list. By default, top updates its display every 3 seconds, and you'll notice a slight flicker when it does it. If you want to exit, press Q, which comes from quit. I'm running it again. The summary area is intuitive. The first line shows the time, how long your system has been running, the number of users logged in, and what the load average has been for the past 1, 5, and 15 minutes. For a healthy system, these values should be less than 1. The second line shows the number of tasks or processes and their states: running, sleeping, stopped, or zombie. The third line displays lots of information about the CPU state percentages based on the interval since the last refresh. I won't explain to you each value at this moment because they are well documented in the man page of top. Just search for CPU states in the man page and you'll find detailed information about each value. Take a look here. The next line shows information about the physical memory, how much is free, used, and buffered or cached. The values are shown in megabytes. And the last line shows the total amount of the swap memory. After this summary comes the process list. You'll see the running processes highlighted. For example, top and the GNOME shell are running, so they are highlighted. Now it's xorg. Now it's top. We already know the significance of the column headings in the process list from the ps command. You can dive deeper into it by reading the descriptions of fields section of the man page. They are well documented here, in this section. You can press the up or down arrows to move up and down and view all processes. I'm moving down. And now up. While tab is running, you can press some letters, which are interactive commands. Press H to see a help summary and Q or ESC to exit this screen. Let's see the most useful commands. When I say press a specific letter, by default it's the lowercase one. If it has to be uppercase, I'll tell you explicitly. If you have a multi-core CPU, press 1 to change the display and see individual statistics for each CPU. If you run Linux in a VM, it probably has access to only one core. When you press such a command again, it will turn the option off. In fact, these commands are like switches, on and off. You can press T to change the CPU displays to simple ASCII graphs and show the percentage of the usage for each CPU. You can press T multiple times for different views. Press M to change the memory and swap lines to different display options. You can press it multiple times as well. By default, tab refreshes the output after every 3 seconds, but you can tweak this by pressing D. It will ask you to enter the new delay value. Just enter any value, including values less than 1. And hit enter. Now the refresh is of 1 second. Or 0.2. Or 0.4. I'll put it back to 3. You can also refresh it manually by pressing the space key. I'm refreshing it manually. Sometimes you want to see clearly the running process and the column used to sort the process list. Press Y to highlight running processes in the process list and X to highlight the column used to sort the process list. You can toggle between bold and text highlighting by pressing B. I'm pressing B. Now they are highlighted. The sorting column and the running processes. So press Y, X and B multiple times. In this mode, if you want to change the column used to sort the process list, just press the less than sign, like this, or the greater than sign to move to the column on the left or right. I'm moving the sorting column. Now I'm sorting the processes by rest memory. I can reverse the sort order by pressing capital R. So Shift and R. It's in reverse order. I'm pressing it again and now they are in descending order. If you want to change the size units, press E. Now they are in megabytes or in gigabytes, terabytes, petabytes and bytes. I've pressed E multiple times. Because sorting is really important, there are 2 shortcuts. Press capital P to sort by processor or CPU and capital M to sort by memory. Maybe you want to see which processes occupy the largest amount of memory. By default, tab is displaying processes for all users. Press U to see the processes of a single user. You'll be prompted for the username or user ID. For example, student. I want to see only the processes of this user. We can also change the columns displayed by pressing capital F, I'm pressing it, to enter the fields management screen. Fields that are displayed have an asterisk beside them and are highlighted in bold. Press the up and down arrows to move through the fields list. If you want to select or deselect a field, press the space key. For example, I want to display the parent process ID and effective user ID as well. If you want to change the field's order, press the right arrow key to select the field name and then move it up or down using the up or down arrow keys. I want to move this field up to the top. I'm pressing the right arrow key, I have selected the field, and now I'm moving it using the up arrow key. X on the first position. When I'm done, I press ESC, and the changes are reflected in the process list. If you make some changes to the way tap is running and then exit tap, when you start it again, the changes will be lost. I'm exiting tap and starting it again. See that the columns PPID and effective user ID I've selected before are not displayed anymore. To save the configuration, so it will still be in effect when you start tap again, press capital W, which stands for write. I'm pressing M to change the way the memory is displayed. And now I'm pressing capital W. And the configuration was written. I'm exiting tap and starting it again. And the change is there. Take a look at how the memory is displayed. At the end, I have a challenge for you. When tap refreshes, its display goes so fast that you cannot see what each process is doing or what has changed between refreshes. The challenge is to make tap produce 3 iterations with a delay of 1 second between each iteration and save the entire output to a text file. Pause the video and try it. You can even search on Google for the solution because no one knows everything and often you'll just have to get things done. Now you can resume the video if you are done with it or want to see my solution. When running tap, you can specify command line options as well. So I'm starting tap like this. Tap -D1 -N3 -B and the command redirection. So greater than tap underline processes.txt. And I'm hitting enter. Let me explain to you the options. -D means the delay, -N the iterations, and -B starts tap in batch mode, which could be useful for sending the output from tap to other programs or to a file. Let's see the file. The file contains 3 iterations of tap with a delay of 1 second between them. Here, it's just between iterations. Now you can even search for a specific process to see it dynamically, to see the differences between each refresh, like grep r/syslogd and the file. There were no changes for this process between iterations. At the end of this lecture, I want you to be aware of another program called htop, which is another interactive process viewer. It's similar to tap, but easier and more appealing visually. Unfortunately, it's not installed by default on Ubuntu or CentOS. To install it, just run as root apt install htop. Sudo apt update. It's always recommended to run apt update first. && sudo apt install htop. When it's done, type htop and hit enter to start it. This is htop. You can use the F keys to configure it. When you want to exit, press Q or F10. htop is very nice, but tap is installed everywhere and there are cases when you are not allowed to change anything on a live server. So even if you prefer a different monitoring tool, it's a good idea to have a good understanding of tap because sooner or later you'll encounter it. In this lecture, I'll show you how to interact with processes. Sometimes you'll have applications that become unresponsive or consume lots of resources and you want to stop them. There are several commands that allow you to terminate the processes and kill is the most used one. The kill command sends a signal to a process or a group of processes, causing them to act according to the signal. When the signal is not specified, it's default to 15 or sig term. To get a list of all available signals, run the kill command with the -L option. Each signal is identified by a number and a name. For example, this signal is identified by number 15, sig term, or term. But what are in fact these signals? A signal is an asynchronous notification sent to a process that determines how the process should behave when the signal is delivered. This is a list of all implemented signals. For example, if a process gets the term signal, then there's an invitation for the process to enter into the terminated state. I've just said the word invitation on purpose. That's because the process can decide to ignore some of the signals. Let's get started with some examples. I'm opening an application like gedit, which is a text editor. From the terminal, I'll send the int signal to the process, and there are 3 ways to do that using the kill command. By the way, when you press Ctrl and C, the foreground process running in the current terminal will be delivered the int signal, which means interrupt. The first step in sending a signal to a process is to find the process ID. So pgrep -l gedit. This is xpid. The first way to deliver the signal to a process is to use the number that identifies the signal. In this case, 2, which means sigint or int. So kill -2 and the process ID. The editor will get terminated. It's gone. And the second example, I'm starting Firefox. Now, I want to find its PID. A quick way to find the PID of a process is by running the PID_of command. So, PID_of Firefox. And it printed out the process IDs of all Firefox processes. There are more. And the second way to deliver a signal to a process is to use the signal name. So kill -int int x the interrupt signal and the process ID. I'll copy and then paste the process's IDs. Note that the signal name must be all in caps. So if you want to provide more process IDs to the kill command, just specify the process IDs separated by a space. And it's gone. And the last way is to use the sig prefix and the signal's name. I'll do it again. I'm starting Firefox. It started. To avoid copying and pasting the process IDs, you can use a command substitution like this. So kill -sigint sigint and a $, a pair of parentheses, and the command PID_of Firefox. This construction will replace the PID_of command with X output, which is the process IDs. I'm hitting enter, and it's gone. We'll dive deeper into this in the bash script section. So all of these kill commands are equivalent. This one, or this one. Note that non-privileged users can send signals only to their own processes, while the root user can send signals to other users' processes. Another useful signal is hop or number 1, which is used to reload a process. In the next example, I'll send the hop signal to the SSH daemon to make it reload X configuration. In Linux, a server reads X configuration only at startup. So if you make any change to the server's configuration, you have to reload it so that the new changes come into effect. The SSH daemon is running, and I'll check it using the systemctl command. So sudo systemctl status SSH, and it's active and running. If it's not running, try to start it by running systemctl start SSH. Like this. And if it's not installed, try to install it by running sudo apt install SSH. I'm opening another terminal, and see the tail or the last lines of the SSH daemon log file in real time. So tail -f and the path to the log file. It's var log auth.log. The process ID of a server is normally found in a file typically located in /var/run directory. Here. The name of the file is the name of the daemon. So this is the file where the process ID of the SSH daemon is saved. This is its process ID. I've got the same result running pgrep, and I'm sending the hop signal to it. So sudo kill -1 and the process ID. Take a look at the other terminal. You saw in the other terminal how the service was restarted. By the way, you can also use a command substitution like I've already shown you. It's the same. The last two commands are equivalent. You should also know that a process can catch some signals and ignore them. For example, when sending the term signal to a process, a few different things can happen. The process may stop immediately, the process may stop after a short delay after cleaning up resources, or the process may keep running indefinitely. So it simply ignores the signal. The process can determine what it wants to do once the term signal is received. While most applications will clean up their resources and stop, some may not. That's why the term signal is also called a soft kill. For some processes that ignore the term signal, it may be necessary to send the kill signal, which is number 9 instead. This one. This signal cannot be caught. This is also known as a hard kill. If you want to stop an application that simply ignores the term signal, then you could try to send the kill signal to it. So kill -9 or -kill and the process ID. Besides the kill command, you can also send signals to processes using killall and pkill. The killall command kills all processes with a particular name. Maybe an application is running several times and you want to kill all instances of that application. I'm starting a few instances of sleep. Sleep, 1, 2, 3, and %. I'm starting it in the background. And another one. By the way, sleep pauses or delays the execution for a given amount of seconds. There are two processes running. Now, I want to terminate all sleep instances. Of course, I can also find all the process IDs and run kill, but it's easier to run the killall command. It does the same as the kill command, just that it takes the name of the process instead of the process ID. It will then kill all the processes that share that name. So kill -15, this is the default anyway, and the name of the command, sleep. Of course, it's killall, not kill. We are talking about killall. And the processes were terminated. Killall does not accept partial names. If you want to kill a process using a partial name, use pkill instead. I'm starting a few instances of sleep again. They are running. If I run the killall command using a partial name, it won't work. Killall SLEE. It's not working. But I can run pkill providing a partial name. So pkill SLEE. And the processes were killed. At the end, I have a warning. Kill, killall, and pkill are extremely powerful commands. If they are misused, they can bring a server down. If you are new to these commands, it's recommended to learn very well how to use them on a non-production system. Let's continue our discussion on processes. There are basically two types of processes: foreground and background processes. Foreground processes are started by the user and not by the system services, and while they are running, the user cannot start another process from the same terminal. By default, every process that you start runs in the foreground. It gets its input from the keyboard and sends its output to the screen, to the terminal. To simulate an expensive task, I'll run the sleep command, which pauses or delays the execution for a given amount of seconds. Sleep 15. A foreground process was started and I have to wait until it terminates. I cannot start another process from the same terminal. So I'm waiting for 15 seconds. And it's done. Now I can start another process by running another command. Let's move to the background processes. They are non-interactive and are started or executed by system services or by the users. While they are running, you can start other processes within the same terminal. To start a background process, you add an ampersand at the end of the command. I'll execute the sleep again, this time in the background. While the process is running, I don't have to wait until it completes to start another one. The process is still running because it takes 20 seconds, and while it's running, I can run other commands in the same terminal. The sleep process is finally done. Note that even though you start a process in the background, it still redirects its output and errors to the terminal where it was started from. I'm executing the ls command in the background. The process was running in the background, but the output was printed to the same terminal. Because these background processes are non-interactive and do not require human intervention, it's common to redirect both the output and the errors to a file. Like this. ifconfig, I'm redirecting the output to a file, output.txt, and the errors, if there are any. Cat output and cat errors. The errors file is empty. If you want to run a command in the background and you are not interested in either its output or errors, you can redirect both the output and the errors to /dev/null. Let's see an example. I'm pinging google.com and I'm running the command in the background. -c1, I'm sending just one packet, google.com. We'll see that the output is printed in the terminal. Now I'll redirect both the output and the errors to /dev/null, so nothing will be printed out. Greater than dev null, the output and the errors. I'm redirecting the errors to the same file, so the same as the output. And I'm running it in the background. And nothing was printed out. It may look confusing, but it's very simple to understand. /dev/null is a special file called the null device and colloquially is called the black hole because it immediately discards anything written to it. By the way, if you don't have an active internet connection to ping google.com, just ping your loopback interface IP address. This IP address. When starting a process in the background, you'll see two numbers printed in the terminal. Each background process is identified by a job ID besides its process ID. The first number is the job ID and the second one the process ID. If you hit the enter key and the process has already finished successfully, you'll get the same job ID and the word done. If, from the same terminal, you start more processes in the background, you can list their job and process IDs using the jobs command. I'm starting two processes in the background. And I'm running the jobs command. It's displaying the job ID between square brackets, the process state, and the command that has created the process. If you add the -l option, it will display the process ID as well. Note that the jobs are maintained by the current shell, so the job ID is local to the current shell, or you can have the same job ID in different shell sessions. But the process ID is maintained by the system kernel and has a global scope. You can bring a background running process to the foreground anytime by running the fg command. Fg stands for foreground. I'm running a new command in the background and then I'll bring it to the foreground. Sleep 10 %. And jobs. X job ID is 1. So fg, the %sign and the job ID. And the command was brought to the foreground. It was done quickly because it waited only for 10 seconds. But you can use a larger number. You can suspend the process running in the foreground anytime by pressing Ctrl and Z. I'm starting a new process, this time in the foreground. And I'm suspending it by pressing Ctrl and Z. Note that the process was not terminated or discarded from the RAM, but suspended or temporarily stopped. I can see the process in the process list. It's there. I can resume it anytime in the background by executing the bg command, or in the foreground by executing the fg command. In this example, I'll resume it in the background. First, I'm listing the jobs. And I'm resuming it by running bg %1. It was resumed in the background. Or I resume the process in the foreground. I'm running the sleep command again with a random number. I'm pressing Ctrl Z. The process was stopped. I'm listing the jobs and I'm resuming it in the foreground. fg %1. Now it was resumed in the foreground. Let's move on and see what happens to a process if we close the terminal, log out or disconnect if it's a remote connection. So, sleep 1, 2, 3. And I'm closing the terminal. I'm opening it again and search for the process. And we notice that the process is not running anymore. It was killed. Let's do the same, just that this time we'll start the process in the background. It was started in the background. I'm closing the terminal. I'm opening it again and searching for the process. And it's gone. I've got the same result. The process was killed. When you close a terminal, log out or disconnect, the HUP signal, which stands for hang up, is sent to the process, and the process will get killed. This becomes problematic because if you run a command over SSH and your connection drops or you log out, the session is terminated and all the processes executed from the terminal will receive the hang up signal and stop. There are lots of programs like backup scripts that take a lot of time to complete and you don't want to wait for them. To avoid this issue, you use the no-hop command, which will make the process to ignore all the hang-up signals. The syntax for no-hop is no-hop and the command you want to execute in the background without getting impacted by the terminal closing or by the disconnection. So, no-hop, sleep, 1, 2, 3, and %. I'm closing the terminal and I'm opening it again. And I'm searching for the process. And it's there. This time the process is still running. It was not terminated. Take a closer look at this command. The output displayed on the screen is no-hop ignoring input and appending output to no-hop.out. You normally run a command using no-hop and then disconnect. When you return, you want to see its output. No-hop redirects the command output to a file called no-hop.out. The file is created in the current working directory, or if the user running the command doesn't have the right permission in the current directory, the file is created in the user's home directory. This is the file. Let's see an example. No hop, ifconfig, %. And cat, no hop.out. The file will contain the output of the command. If a process is started with no hop and its parent, which is the bash shell, gets terminated, the process will be adopted by init or systemd, which runs as the first process on boot and has PID 1. Note that there are several alternative programs that you can use to avoid a command to be terminated when you close the terminal or get disconnected. Some of such well-known programs are Screen and tmux. Take a look at them because they are really useful. In this lecture, I'll show you how to get the needed information about the network interfaces. Basically, there are two commands, ifconfig and ip. ifconfig, part of NetTools package, has been there for a long time and is still used to configure, display, and control network interfaces by many Linux administrators, including myself. However, there's a new alternative, the ip command, from iproute2 package. Note that NetTools is not installed by default on Ubuntu Desktop Edition, and if you want to use the ifconfig command, you have to install it. We've already done it at the beginning of the course, but if you don't have the ifconfig command, you can install the package by running sudo apt install nettools. iproute2 package is already installed on most modern Linux distributions. In this video, we'll dive into both ifconfig and ip commands. These commands can be used to both display and configure the network interface settings. Let's get started. I'm splitting the terminal in two, one for ifconfig and the other one for ip. To display a list of all network interfaces and the associated IP address, run ifconfig -a. Or IP address show. I've got the same information but in different formats. The -a flag of ifconfig makes it display the information about all interfaces, both enabled and disabled. If you omit the -a option, ifconfig will show only the information about enabled interfaces. Let's take a closer look at the ip command. Address is the object you want to manage, and show is the command executed on the object. It's possible to use a short format for the object name. It's common to see commands like ip addr show or even ip a show. It's the same. You can also omit the show command entirely because it's the default. So ip a is a valid command. If you want to display only IPv4 or IPv6 IP addresses, use ip -4 address and ip -6 address respectively. Let's take a closer look at the output. Both commands, ifconfig and ip, display a similar output. I'm running them again. And ip a. We are seeing the name of the interface, LO for the loopback interface, and ENP0S3 for the Ethernet interface. You can see other names like WLO1 or WLAN0 if you use a wireless interface. Then we see the IP address, the network mask, the broadcast address, the MAC address, and if the interface is running or up. It's running. It's up. The ifconfig command is also displaying how many packets and bytes were received and transmitted on each interface. Let's talk about the interface name. The modern Linux distributions, including Ubuntu and CentOS, use predictable network interface names. Let's take a closer look at the name of the Ethernet interface, which is NP0S3. These predictable names consist of two character prefixes based on the type of the interface. EN for Ethernet and WL for wireless LAN. Then comes the type. This is a network interface on a PCI card where S is the slot number and P the port number. So port 0 on slot number 3. Old Linux releases used something like ETH0 or ETH1 instead. To get information about a specific interface, run ifconfig and the name of the interface. Like ifconfig enp0 s3. Or IP address show dev and the interface name. IP address show dev enp0 s3. You can also run the short form. So IP a s dev and the interface name. To properly communicate on the internet, your system also needs a default gateway and a DNS server. ifconfig can display neither the default gateway nor the DNS server, but there's the route command from the same package called nettools that does it. So route or route -n. The -n option will make the command to display the names in numeric format. The capital G in the flags column indicates that the line is displaying the default gateway. So this is the default gateway, 10.0.2.2. And it's the same with the following IP command, IP route show. Let's move to DNS. On the latest versions of Ubuntu, the DNS is under the control of systemd resolve daemon. This is a service that provides DNS name resolution to local services and applications, and it can be configured with Netplan, the default network management tool on Ubuntu. We'll talk about Netplan and how to statically configure a network interface including DNS name servers in another lecture of this section. To see the DNS server used by the system, run the following command. systemd -resolve --status. Scroll down and you'll see the DNS servers used by the system. We'll take a short break, and in the next lecture, I'll show you how to configure network interfaces on the fly. Let's see how to configure network interfaces on Linux. When configuring network interfaces using IP or ifconfig commands, you must execute the commands as root, otherwise you get an operation not permitted error. So, to make it easier, I'm temporarily becoming root in the terminal by running sudo su. Do not run the following commands on a remote system to which you are connected using SSH, since you are going to disable and enable interfaces, change IP addresses, and so on, and your SSH connection will drop. Run the commands on a Linux machine to which you have local access. Let's see how we can set interfaces up and down. So, ifconfig, the name of the interface, enp0 s3, down. The interface is down and it's not displayed by the ifconfig command. Use the -a option to display it. And we notice that's not running, so it's down. And I'll activate the interface. ifconfig, the name of the interface, and up. We see the interface is running. Let's do the same using the IP command. iplink, set the name of the interface, enp0 s3, down. And iplink show, dev, and the name. And the interface is in the down state. I'm activating the interface. I'll use up instead of down. And I'm checking it. Now the interface is up. Let's go ahead and configure an IP address on the interface. Note that the configurations set with the IP and ifconfig commands are not persistent. After a system restart, all changes will be lost. For permanent settings, you need to edit a distro-specific configuration file. For example, on Ubuntu, you have to use netplan for static configuration of the network. We'll have an entire lecture on this later in the course. ifconfig, the interface name, the IP address, and the network mask using the / notation. And optionally, I can add the up keyword. Let's check it. And we see the new IP address. And now, with the IP command, the first step is to remove the existing IP address from the interface. So IP address, del, the existing IP address and its mask, df, and the interface name. And the next step is to add the needed IP address. Just write add instead of del, and the IP address you want to set on the interface. For example, 222 at the end. And it was changed. Let's see the routing table, including the default gateway. For that, as we've already discussed in the last lecture, we run route -n. The capital G in the flags column indicates that the line is displaying the default gateway. This is the default gateway. And the same with the IP command, iproute show. Let's see how to change the default gateway. If there's already a default gateway configured, then we have first to remove it. So route del default GW and the IP address. And to add a new one quickly, I'm running route add default GW and its IP address. And with the IP command, if there's already a default gateway configured, I'm removing it. iproute del default. And I'm adding a new one. iproute add default via and the IP address of the new default gateway. Let's check it. Perfect. And finally, let's see how to change the MAC address of an interface. The first step is to disable the interface. So ifconfig enp0s3, the name of the interface, down. The interface was disabled. And ifconfig, the name of the interface, hw, ether, and the new MAC address. I'll write a random MAC address. And ifconfig enp0s3 up. And we see the new MAC address configured on that interface. And the syntax for adding the MAC address using the IP command. iplink set df, the name of the interface, address, and the MAC address. I'll copy and paste this value and change the last digit. And iplink show df enp0s3. The MAC address was changed. Note that the configuration is valid only up until a new restart. As time passes, IP will replace ifconfig even though it's still here to stay for a while. In the next lecture, I'll show you how to set up a static network configuration on Ubuntu. In this lecture, I'll show you how to statically configure a network interface. Typically, laptops and desktops have their IP address assigned dynamically by a DHCP server, which in most cases is the router. However, a server requires a static configuration to avoid the single point of failure problem of using a DHCP server. Since the release of Ubuntu 17.10, netplan is the default network configuration tool to manage networks. It uses YAML files that are located in /etc netplan. Netplan currently supports two renderers or backend services to control network interfaces on Ubuntu-based systems. They are Network Manager and systemd networkd. Network Manager is mostly used on desktop machines, while systemd networkd is used on servers without a GUI. When you use Network Manager as the renderer or backend service, you'll use the Network Manager graphical user interface to manage the interfaces. In this lab, if you're running Ubuntu in a VM in VirtualBox, set the network into bridged mode so that Ubuntu has direct access to the LAN. Go to Networks, Network Settings, and here select Attached to Bridged Adapter. It's like a standalone machine connected to the LAN. Let's see how to set up a static IP address using the Network Manager renderer. To set up a static IP address on Ubuntu desktops, click on the network icon in the top menu, here. Then select Wired Connections, Wired Settings, and then click this icon. Go to IPv6 or IPv4, depending on the protocol version your LAN is using, and choose Manual for IPv4 to set a static IP. Write the IP address, the network mask, the gateway, the DNS servers, and when you are ready, you just click Apply. It's really simple. Let's move ahead and see how to configure the network interface on a server if there's no GUI available using the systemd networkd renderer. The first step is to disable the Network Manager. The network interface can be managed either by Network Manager or by networkd, but not by both of them at the same time. I'm becoming root, sudo su. I'm root. I'm stopping Network Manager. Systemctl, stop, Network Manager. It was stopped. I'm disabling Network Manager so that it won't start after the system restarts. And I'll check its status. It's inactive. And to check if it will start at boot time, run systemctl is enabled Network Manager. Use the correct spelling. Okay, and it's disabled. The next step is to create a YAML file in /etc netplan. And if you don't use the Network Manager renderer anymore, my advice is to remove the existing YAML file for Network Manager that exists in /etc/netplan. That file could interfere with your static configuration. So vim etc netplan and the file name. You can name it something like 01 netconfig.yaml. Inside the file, I'll paste some lines. Let me explain to you the configuration you are seeing. Each netplan YAML file starts with the network keyword, and then at least 3 required elements. The version of the network configuration format, which is 2, the renderer, which is networkd, and the device type, in this case is Ethernet. But if you use a wireless card, there will be Wi-Fi's. Under the devices type, in this case Ethernet, you specify one or more network interfaces. My Linux VM has only one interface called ENP0S3 that will be statically configured. So DHCP4 will be false. Then I specify the IP address, the default gateway, and the name servers. Take this file as an example and use it in your own LAN, changing it accordingly. You'll find it attached as a resource to this lecture. I'm saving the file. If you want to configure the network interface using DHCP, then you can only write DHCP4:true under the name of the interface, so under NP0S3. You'll end up with something similar to this. When you are done editing the YAML file, save it and exit. To apply the changes, run as root, netplan, apply. To verify the changes, run ifconfig, and we see the new IP address that was statically configured, and route -n to see the default gateway. And we see that the changes were applied. Let's open again the YAML configuration file. This one. YAML uses 2 spaces for indentation. If you are not consistent, you'll get a syntax error. For example, if I add only 1 space here, the YAML file will have errors. I'm saving the file and executing netplan apply again. And there's an error. I'll make it right again. There are some good online YAML validators if you have errors and do not know exactly where they are. This is, for example, a good one. I'm copying the contents of the file and paste it in the validator. I'm clicking validate and it's a valid YAML file. But this one, it's not valid. Anyway, I'll attach more examples to this lecture so you can see YAML configuration files for netplan for many situations, including how to configure Wi-Fi networks. Let's talk about testing and troubleshooting the network. The most useful utility for testing and troubleshooting network connectivity issues is ping. Ping works by sending ICMP echo request packets to the specified destination IP address and waits for a reply. When the destination receives an echo request packet, it will respond back with an ICMP echo reply. Ping is also available on Mac and Windows, but with other options. The basic syntax for the ping command is ping, some options, and the destination IP or domain name. If you run ping without any options, it will send echo request packets continuously until you stop it by pressing Ctrl and C. For example, ping ubuntu.com. It's sending echo request packets continuously. I'm stopping it. Let's take a closer look at the output. The ping command has resolved the domain into an address, this one. So the public IP address of ubuntu.com is 91.189.91.44. Maybe you wonder, why are you seeing this name? elvira.canonical.com and the IP address between parentheses. If that IP address belongs to ubuntu.com, what's with the other domain name? The answer is that an IP address can be set to multiple different domain names, and ping performs a reverse DNS resolution asking the DNS server configured on the system what's the domain of that IP. The DNS server responds back with one domain, which is different from ubuntu.com. It's this one. If you want to prevent ping from doing reverse DNS lookup, add the -n option. And we see that the destination is reachable because it's responding back. If you ping an IP address which is down, you'll get back no response. Like this. It's not responding because it's unreachable. I'm stopping it by pressing Ctrl and C. To specify the number of echo request packets to be sent before ping will exit, use the -c option followed by the number of the packets. For example, ping -c4 ubuntu.com. It will send 4 packets. Let's take a look at a line. 64 bytes is the packet size. ICMP underline sequence equals 1 is the number of the packet. You can use this to detect issues with bad routing. For example, getting back packets 1, 3, 2, 4 and 5 would mean each packet is taking a different route. Basically, you want these to go in order, although you cannot control it. TTL is the time to leave value in the received packets. This is normally the number of hops or routers between the source and the destination. The ping time, measured in milliseconds, is the round trip time, or RTT, needed for the packet to reach the remote host and for the response to return to the sender. And less is better. And some guidelines. a time less than 30 is excellent. 30 to 50 milliseconds is average but still okay. 50 to 100 milliseconds is somehow slow, and the value greater than 100 means a slow response, and probably you cannot run real-time applications like voice or video over IP. Let's see some other options. By default, ping waits 1 second before sending the next packet. We can change this interval using the -i option. So ping -i 0.4 -c 5 and the destination google.com. It's sending the packets faster. Only the super user may set this interval to values less than 0.2 seconds. A non-privileged user is not allowed to send packets so fast. But root is allowed. If you only want to get a summary, use the -q option, like this. It's only displaying a summary. 0% packet loss. You can also discover the path a packet takes by sending pings with incrementing TTL values. When a router receives a packet with a TTL value of 1, it will discard the packet and notify the source with an ICMP time exceeded packet. So using a TTL value of 1 means discovering the first router towards destination. Let's see what is the first router towards ubuntu.com. So ping -t1 -c3, I'm sending 3 packets, -n, I do not want a reverse DNS lookup, and the destination, ubuntu.com. And this is the first router. Let's find out the second router. This is the second router. It's a router with a private IP address, so it's probably a router inside the service provider's network. This is the third router, the fourth router towards destination, and so on. Probably it's already outside my service provider's network. Ping is a complex command with lots of options. Take a look at its man page. There are so many options. Now let me show you an easy and quick way to troubleshoot connectivity issues. If there are any connectivity issues, follow these steps. First, ping the default gateway of the LAN. So route -n, I want to see the default gateway, and I'm pinging it. If ping is not working, then you have a problem in your own LAN. Maybe you are not authenticated to the wireless access point. If you use a wireless connection, you don't have the correct IP address set, or maybe the router is not correctly configured. If it's working, go to the second step. Ping a public IP address on the internet. Take something stable like the public DNS server of Google, which is 8.8.8.8, or the public DNS server of Cloudflare, which is 1.1.1.1. It's working. And the other IP address? And it's working. If it doesn't work, then there's an internet connectivity issue. You can check if your router is properly configured, or you can even call your service provider and make a complaint. If the router is properly configured, probably the problem is not yours. If it's working, go to the third step. Ping an internet domain, something that's stable like google.com. If it's not working, then you have a DNS issue. Check that you are using the correct DNS server and there's nothing that's filtering the packets and so on. Probably there's a configuration error related to DNS on your side, or maybe the DNS server is down. You can change it to 8.8.8.8, the Google public DNS server, and try again. The troubleshooting process is considered to be a complex one, and many aspects can get into the equation. The steps I've shown you are in most cases appropriate for home or small networks. SSH, also known as Secure Shell, is a network protocol used by system administrators to securely configure a remote system over an unsecure network connection. It's in fact the most useful network protocol used for the remote management of servers, routers, switches, or other networking devices. SSH involves a client and a server. The SSH client creates a secure connection to the SSH server on a remote machine, and then the connection will be used to execute commands on the server. Let's install OpenSSH, which is the most used SSH server on both Ubuntu and CentOS. On Ubuntu, I'm running as root. apt update && apt install OpenSSH server and OpenSSH client. It's installing or updating it. Okay, and on CentOS, I'm running sudo dnf install OpenSSH server and OpenSSH clients, ending in an S. They were installed or updated. When the installation is complete, you can verify the status of the SSH server by running systemctl status ssh on Ubuntu and systemctl status sshd on CentOS. So, on CentOS, systemctl status sshd. It's active and running. And on Ubuntu, it's active and running as well. The difference is that on CentOS, the systemd unit is called sshd instead of ssh on Ubuntu. D at the end comes from daemon. You can also take a look at and search for it in the processes list. So ps-ef pipegrep sshd, and it's running. And the same on Ubuntu. The daemon is running. The name of the process is sshd on both Ubuntu and CentOS. To check if it's enabled or set to start at boot, run systemctl is enabled SSH. And it's enabled. It means it will start at boot time. Let's connect to the SSH server. In the next example, Ubuntu will be the SSH server and CentOS the SSH client. Before continuing, my advice is to check the network connection between the SSH client and the SSH server using ping. Let's see the IP address of Ubuntu. And I'm pinging it from CentOS. And it's working. If it's working, go on. If it's not, troubleshoot the network connectivity problem and continue with SSH only when ping is working. There are many SSH clients, PATI and the OpenSSH client being the most used ones. In this lab, I'll use the SSH command, which is the OpenSSH client program. On the client machine, I'm running SSH, the username, student, and the server's IP address. The username used for authentication should exist on the server, not on the client. Keep this in mind. The first time when a client is connecting to an SSH server, you'll see a message like this. The client uses a cryptographic fingerprint to identify the server and prevent possible man-in-the-middle attacks in the future. The host key is randomly generated when the SSH server is set up and is used to identify the server you are connecting to. It will be saved on the client in a file called known_hosts in .ssh directory in your user home directory. And I'm accepting it. And I'm entering the password. And it's working. I'm on the server and I can configure it. To disconnect from the server, type exit or press Ctrl and D. You can also specify the username that will authenticate on the server using the -L option, like this. -L and the username. It's the same. If you get any errors and cannot connect to the server, pause this video and start the next one where I'll show you how to troubleshoot SSH connections. Now, I suppose it's working and we go on. Let's see other useful options. To connect to a port other than the default 22, use the -P option and the port number. I'm exiting the connection and I'm connecting again. So -P and the port, 22 in this case. Note that the SSH client has its own configuration file, which is /etc ssh_config. This is the configuration file of the client. Normally, you don't change anything there, but you could, for example, specify another default port, specify the encryption algorithm used, a default username, and many more. Now, at the end, I'll show you how to connect to the SSH server from Windows using PuTTY. PuTTY is an open source and free application that must be installed. Download and install it from this link. I've already done it. This is PuTTY. Then open PuTTY, write the IP address of the server 192.168.0.20, the port, if it uses another one and not the default 22, give a name to the session and save it. Later, when you want to connect to the server, just open the session using its name. I'm searching for the saved session, Ubuntu 20.04, and I'm opening it. And it's asking for the user and the password. So student and the password. And I'm on the server, on Ubuntu. We'll take a short break, and in the next lecture, I'll show you how to troubleshoot SSH. In this lecture, we'll continue our discussion on SSH and I'll show you some troubleshooting tips. If you cannot connect to the SSH server, the first thing you should do is to check that the SSH daemon is running on the server machine. Run systemctl status SSH to see its status. It's active and running. To start, stop or restart the service, run systemctl restart SSH to restart the service, systemctl stop SSH to stop the service. Now it's stopped. Let's see its status. It's inactive. And systemctl start SSH to start the service. Now it's running. If on the client part you get a message similar to this one when trying to connect and authenticate to the SSH server, then you should double check that you are connecting to the right server. This message can be displayed if, for example, the IP or MAC address of the server have changed. If it's the right server, then you can get rid of the message by removing the server key from the known hosts file. The file resides in a hidden directory called .ssh in the user's home directory on the client machine. This is the known hosts file. Go there and remove the server's key. I'm removing the host key and I'm saving the file. Now, when connecting to the server, the new message about the server's identity will be displayed. This message. Accept it if you know it's the right server. If the SSH connection is still not working, check if the port 22 on which the server listens is open. So from the client, scan the port 22 on the server. Use a simple command like telnet or nmap. If the telnet command is not installed, install it by running dnf install telnet. Of course, on Ubuntu you should run apt install telnet. It was installed, and I'm checking the server's port. So telnet, the IP address of the server, and the port, and it's open. It has successfully connected to that port. Or using nmap. I'm installing it. dnf install nmap. Don't forget to run it as root. nmap -p22 and the server's IP address. If it says X down, add the -capital P and lowercase n options. And the port 22 is open. If the port is closed, but the SSH daemon is running on the server, and I suppose it's running, and you've checked that, then you should check if there isn't a firewall on the server that's dropping the packets. The Linux firewall is called netfilter iptables, and you can check if there are any firewall rules by running as root iptables -vn capital L. Check if the policy is set to accept, and there are no rules that drop the packets. There will be an entire in-depth section on netfilter and iptables later in the course. In this case, the policy is set to accept, and there are no firewall rules. If you see any rule or you suspect a firewall issue, then you should know that your Ubuntu distro could have something called UFW, which stands for Uncomplicated Firewall. UFW is a user-friendly frontend for managing iptables firewall rules, and its main goal is to make managing firewalls easier, or, as its name says, uncomplicated. On Ubuntu, UFW should be disabled by default, but you can check its status by running UFW status verbose. Of course as root. And it's inactive. To enable, respectively disable UFW, run as root UFW enable. I have enabled it. I'm disabling it. You can list all application profiles available on your server by running UFW app list. And to configure the UFW firewall to allow incoming SSH connections, type the following command: UFW allow SSH. Okay, if there isn't a firewall problem but you still cannot connect, then you can run the SSH client in verbose mode by using the -v option, like this. SSH -v, the username, at the server's IP address. It causes SSH to print debugging messages about its progress. This is helpful in debugging connection, authentication, and configuration problems. Multiple V options increase the verbosity. I'm using double V. It's more verbose. And if the problem still persists, check the server logs. On Ubuntu, the logs are saved in /var log auth.log. This is the log file. And on CentOS, the log file is located in /var log secure. This is the log file of the SSH server on CentOS. We'll take a short break, and in the next lecture, I'll show you how to properly secure the SSH server. See you in 2 seconds. SSH has become the de facto standard for remote access. However, a default installation of SSH isn't the most secure one, and there are a few simple steps that can dramatically improve security. In this lecture, I'll show you how to secure the OpenSSH server. The server configuration file is located in /etc ssh and it's called sshd_config. This is the server's configuration file. To change anything related to the server, you have to edit this file. After editing the file, you have to restart the server so that the new changes go into effect. Before you start making any changes to the server's configuration, I'd recommend you to make a backup of the file. I strongly recommend this, especially if you are a beginner. Note that there's also a file called ssh_config, this one, which is the configuration file of the SSH client, and sshd_config is the configuration file of the SSH daemon. This D comes from daemon. So I'm opening sshd_config, of course as root. Each line that starts with a hash sign is interpreted as a comment. Each line can consist of a configuration option, a white space, and a value for that option. In this file, the keywords are case insensitive, and arguments that contain spaces are to be enclosed in double quotes. And as it's explaining in the file, the strategy used is to specify options with their default values, but leave them commented out. If you want to overwrite a default option, you have to uncomment that line and change the option. Take a look at this line, which is commented out. The default value for the option port is 22, the port on which the server is listening. And if I want to change the default port, then I have to uncomment the line and change the value of this option. Not all available options of the SSH daemon are present in this file. And if you want to read more about what a specific option does, then open the man page of sshd_config and search there for the option you are interested in. Like this. I'm searching for the option called Allow Users. And I see the description of the option. Let's get started. These are my top recommendations for securing the server. Use a non-standard port for the server. By default, the SSH daemon is listening for incoming connections on port 22. For a hacker to determine that SSH is running on your machine, he'll most likely scan port 22, change it to a random port, and you'll avoid being seen by casual scans, but not by targeted attacks. Of course, this is security through obscurity, and this is not considered a good security practice in general because changing the port does not make your server more secure. A hacker who's targeting you could scan all the ports using a tool like Nmap and find the new port. However, in the case of SSH, when the vast majority of attacks are automated and not targeted, this is highly recommended. I'm uncommenting the line and changing the port to something random. Don't forget to make the required changes to your firewall rules to allow the new port, if it's the case. My second advice is to disable direct root login. One of the most dangerous security holes you can have in your system is to allow direct login as root through SSH. No matter how strong the root password is, there's always the possibility that a hacker can find the password using a brute force attack. If you need root access, log in as a normal user and use the sudo or su commands to run commands as root. I'm searching for permit root login. This line. The direct login of root is disabled by default, but you should check it anyway. Its default value is prohibit password, which means that root can log in directly using another authentication method, not the password. It could use public key authentication, for example. This is acceptable, but I prefer to change it to no. My third advice is to disable password authentication entirely if that's possible and enable only public key authentication. This is considered way more secure. This is not the simplest task, so there's a dedicated section on how to do it later in the course. If it's not possible to disable password authentication on the server, then use only strong passwords, and that means random passwords with a length of at least 10 characters, consisting of letters, digits, and special characters. Do not use dictionary words or combinations of such words, no matter the language. Another advice is to limit users' SSH access. By default, all system users can log in via SSH using their password or public key, even if there are only a few administrator users that really need to access the system remotely. This setting will limit the impact of an ordinary user having a weak password. Add the Allow Users option and then a list of allowed users separated by space. Note that this option is not in the file, so I'm simply adding it. Allow users and a list of users. Another advice is to filter SSH access at the firewall level. If there are only a few admins that use SSH for remote management, then accept connection to the SSH port only from a limited list of source IP addresses. These will be the source IP addresses from where the admin will connect, say home and work. Permit an entire network if the source IP address changes or is dynamic. Supposing I want to permit SSH access only from 2 IP addresses or networks, then the following iptables rules are required. I'm becoming root. And iptables -a input, -ptcp, -d port, and the SSH port, I've changed the port to 2278, -s, and the IP address that will be permitted. I'll write a random one. -j accept. Accept written in capitals. And the second rule for the second IP address that will be permitted. And finally, iptables -a input, -ptcp, -d port 2278, -j drop. Now, only SSH connections coming from these 2 IP addresses will be permitted. If you want to allow an entire network, use the network address instead of the IP address. Take a look at the iptables section where I'm diving really deep into it. Another advice is to use SSH protocol version 2. This is the default for the latest versions of OpenSSH, so you don't have to do anything. Just don't change it to version 1. Then you should configure an idle timeout interval. This is the interval in seconds after which, if no data has been received from the client, the SSH daemon will send a message through the encrypted channel to request a response from the client. For example, if the idle timeout interval you are setting is 300 seconds, once the interval has passed, the idle user will be automatically logged out. Let's check if the option is already in the file. And it's there. So client alive interval 300 and client alive count max 0. You can search for these options in the man page of sshd_config anytime you want. You can also take a look at the max auth tries. I'm searching for max auth tries. This specifies the maximum number of authentication attempts permitted per connection. And max startups. This option specifies the maximum number of concurrent unauthenticated connections to the SSH daemon. There's also login grace time that could be of interest. The server disconnects after this time if the user has not successfully logged in. And my final advice is to always use the latest version of OpenSSH. Take all the steps described in this video and you'll end up with an SSH server that is secure enough for most enterprise setups. It's time to talk about SCP, which stands for Secure Copy and allows you to securely copy files and directories between two hosts using SSH. This command will copy over an SSH connection, and it's very useful for a lot of things that require files to be transferred over the network. It's in fact the tool of choice when you want to copy files around in a network, and that's mainly because it uses SSH, which is probably already available, and it is secure as well. SCP is part of the OpenSSH client package. The SCP command can be used in 3 different ways: to copy from your computer to a remote server, to copy from a remote server to your computer, and to copy from a remote server to another remote server. In this third case, the data is transferred directly between the servers. Your own computer will only tell the servers what to do. Before going into SCP, check that you have SSH access to the remote SSH server you'll copy the files to or from. In this video, Ubuntu will be the server and CentOS the client. And I'm checking SSH. I'm checking that it works. SSH, the user, and the server's IP, so the IP address of Ubuntu. And it's working. I'm not continuing. Let's get started with the first example. I'm copying a local file to the remote system. First, I'm creating a file. I'm gonna copy this file. I'm writing the command and then I'll explain it to you in detail. scp-P22, the file, student at the server's IP address, :tilde. So, capital P specifies the port on which the server is listening. It's the default 22, then it is not necessary to specify it. Let's take a look at the second part of the command. It indicates the destination. There's the username that's authenticating to the server, and the IP address of the server. It is followed by a colon and the destination directory on the server, which in this case is tilde, the home directory of the user, of this one. Note that no space is permitted before and after or before and after the colon sign. I'm hitting enter. It's asking for the password. This is the password of the student user on the server. And the file was copied. Let's check it on the server. Look, this is the file. Let's see another example. If you want to copy the file under a different name on the destination, you need to specify the new file name, like this. So tilde slash, let's say ip_CentOS.txt. I'm entering the password and hitting enter. And it was copied. Look, this is the file. It's the same file. If you want to copy a directory, you should add the -r option, which comes from recursive. I'm creating a directory, my dear one, and I'm moving the file to that directory. And I'm gonna copy this directory to the remote server. So, I'm adding the -r option, which is mandatory, and I'll change the source. This is the source, the directory that will be copied. and the destination is tilde, the home directory. It was copied. Let's check it on the server. Look, this is the directory. Great! Another useful option is -p, which preserves the modification and access time. So I'm adding p. This is useful. Also be aware that to be able to copy files, the user that runs the scp command must have the read permission on the source file, and the user that authenticates, so the user before the @ sign, this one, must have the write permission on the destination directory on the target system. In this example, the name of the user that runs the command is the same as the name of the user that authenticates to the server, but they could be different. Be careful when copying files with the same name and location on both systems, because scp will overwrite the files without any warning. Let's see another example. To copy a file or a directory from a remote to a local system, use the remote location as source and the local location as destination. I'm copying the password file from /etc directory on the remote server to the local machine on the desktop. So, scp, the source, which will be the remote location, student, at the IP address, colon, and the source file. I'll use a correct path on the server, etc password, and the destination, home, student, desktop. And the file was copied. The file is on my desktop. In fact, the colon symbol is how scp distinguishes between local and remote locations. If you want to copy a directory, use the -r option. Just as before. I'll copy the desktop directory from the server to the client. And I'll copy it on my desktop. Take care not to overwrite your original desktop directory. And it was copied. On the desktop, there will be another directory called desktop that was copied from the server, from the Ubuntu machine. This one. With scp, you can also copy files between two remote systems directly. You'll need to have access to both systems from the machine on which you execute the scp command. And the command will be something like this. scp user1 at the IP address of the source, colon, and the path to the source file. Then user2, the IP address of the destination, colon, and the path to the destination directory. And you'll be prompted to enter the passwords for both user1 on the first system and user2 on the second system. Note there's also a protocol called SFTP or SSH file transfer protocol, which, like SCP, uses SSH for network file transfer. Compared to SCP, SFTP includes extra capabilities such as resuming interrupted transfers, directory listings, or remote file removal. So SFTP is more complex than SCP, but SCP is in general faster. Note that SFTP has nothing to do with the classical FTP protocol. There are some GUIs available for SFTP so that you can transfer files from one machine to another using SFTP and SSH in graphical mode. A well-known implementation of an SFTP client is WinSCP for Windows, or FileZilla, which is a cross-platform client and works on Windows, Linux, and Mac. At the end, I'll show you how to transfer files between Windows and Ubuntu using FileZilla. I'm downloading FileZilla for Windows. And I'm installing it. The installation process is very simple, just press next a few times and finish at the end. It was installed. This is FileZilla. Now I'll write the IP address of the server. This is my Ubuntu VM, the username student, password, and the default 22 port. And I'm connecting to the server. Okay, this is the server. On the right side, you see the server side. I can, for example, copy this file, ip.txt, from the server to the client, so to Windows. For example, I'm going to the desktop, and I'm copying it there using drag and drop. And it was copied on my desktop. This is the file. You can copy a file from the client to the server in the same manner. This is the file I have copied. Okay, that's all about SCP. Thank you. Now I'll present to you probably my favorite Linux command, rsync. Rsync is a fast and versatile utility that synchronizes files and directories between two locations that can be local or remote. Think of rsync as a very complex command with tons of options that is widely used for backups and mirroring. It's like an improved copy command. I, myself, use rsync for personal and professional backups frequently. When you have rsync available, you don't need a complex commercial application for most types of backups. Rsync is pre-installed on all major Linux distributions and on macOS. Let's get started with a basic example. Suppose you want a backup of the /etc directory where the entire configuration of the system resides. Instead of copying the directory using the cp command, you can use rsync. The basic syntax is rsync, some options, one or more source files, and then the destination directory. The user that runs the rsync command must have read permissions on the source location and write permissions on the directory location, and that's why I'm running the command as root. So, sudo rsync -av, the source, etc, and the destination. For example, in tilde, the user's home directory, /etc -backup. The -a option is telling rsync to run in archive mode, and it means it will copy directories recursively, preserve symlinks, the owner, the group, and the permissions. It will copy the files as they are. The v option indicates to run in verbose mode. Rsync will print out everything it does. As the destination directory does not exist, rsync will create it. I'm hitting enter, and after entering the password, I'll see how it's copying the files and directories. When it's done, it's displaying a short summary. Though it looks it does the same as cp, in fact it doesn't. If I run the command again, it won't copy the same files and directories. In fact, it won't copy a single file. It will do nothing. Rsync finds files that need to be transferred using a quick check algorithm that looks for files that have changed in size or in last modified time. Since no file was changed, rsync does nothing. This is more efficient compared to the cp command, which would have copied again each file. By the way, if you don't want to display output messages, use the -q option, which stands for quiet instead of v. It won't print a thing. Now, let's suppose something has changed in the source location, like for example the user has changed its password, and that means that the shadow file was changed. Let's change the user's password. Okay, the password was changed. And I'm running the same rsync command again. I'll use V instead of Q. I want to be verbose. And I'm hitting enter. And we notice how it found the file that was changed and copied only that file, the shadow file. This is a big improvement. Let's see what will happen if new files are created in the source location. As root, I'm creating a new file in /etc. And I'm running the rsync command again. And, as we've expected, just that file was copied. Now, I'm removing the file from the source location. I'm running the rsync command again, expecting to remove the file from the destination location as well. But the file was not removed from the destination. It's in the destination directory. To make rsync remove such files, add the ---- delete option. This is useful for mirroring when you want two directories to always have the same contents. I'm adding ---- delete. And the file was removed. Until this point in the course, we gave no importance to a trailing slash in a directory name. So cd/etc/ is the same as cd/etc without a trailing slash, or ls/etc/ is the same as ls/etc. So a trailing slash doesn't matter. However, rsync gives different treatment to the source directories with a trailing slash. Let's see the rsync command again. If you add a trailing slash to the source directory name, it will copy only the contents of the directory to the destination directory. In my previous example, there was a trailing slash, and that meant that it copied the contents of /etc inside the destination directory, inside etc backup. If the trailing slash is omitted, rsync will copy the source directory itself inside the destination directory. So this command will copy the directory /etc in the destination directory. I'm hitting enter. And in the destination directory, which is etc-backup in user's home directory, this one, a new directory called etc appeared. This one. This is in fact the source directory that was created by rsync. Sometimes you want to exclude some specific file types from synchronization. When I back up my personal files, I want to exclude the files that are extremely large, like movies, or files that are not important to me. Let's create a new directory tree. Let's consider this directory tree. To exclude files and directories, use the --exclude -files option. In the directory tree, there are two other directories and a few regular files inside. And I'm creating a new one, movie1.mkv. Okay, I want rsync to exclude from synchronization movie1.mkv, dir1, and all files of type png. To do that, I'm creating a new file, and on each line, I'll write a file or directory name to be excluded. So vim exclude files.txt. All the paths are relative to the source location. movie1.mkv, dir1, and the trailing slash. To exclude a directory, use a trailing slash after its name. And I can also exclude based on a pattern that matches the file or the directory name. For example, to exclude all png files, I'll add such a line, star.png. I'm saving and exiting the file. Perfect. And I'm running the rsync command using the --exclude -from option. -exclude -from equals, and between quotes, the path to the file. In the current directory, exclude files.txt. The source, my project, and the destination. It will create a new directory called backup in the current working directory. And I'm hitting enter. And we see that rsync has excluded the files and directories specified in the exclude file. It's important to use a correct path to the file, and I recommend you to use an absolute one that's always valid. So it would be better to use an absolute path here, like home, student, and the name of the file. This command will be valid no matter the directory you are in when you run it. It's much better. If you want to quickly exclude a file or a directory, there's also the ---- exclude option, which takes a file or directory as argument in the command line, like this: rsync -av -exclude equals, and between quotes, a file or directory name to exclude. You can also use patterns, like star.png. The PNG files were excluded. And to exclude multiple files or directories, simply specify multiple exclude options. I'm removing the backup directory. And I'm running the rsync command again. I'm adding a new exclude option, like this: ---- exclude equals, let's say, a.pdf. The file will be excluded as well. And you see, it was excluded. That's all about rsync for the moment. Remember that rsync is a very complex tool with tons of options, and you can see them all in its man page. In this lecture, I've shown you the most useful ones, the ones that I'm using often. We'll take a short break, and in the next video, I'll show you how to synchronize files and directories over the network using rsync and SSH. Let's continue the discussion about my favorite Linux command, which is rsync. Rsync can also be used to synchronize local directories to a remote system if you have SSH access to that remote system. This should be your first choice when you want to backup or mirror your server configuration over the network. All of the options we've seen in the previous lecture for local sync are still available. The basic syntax is very straightforward and is similar to SCP. Let's get started. I'll run rsync on CentOS, which will be the client, and synchronize it to Ubuntu, where the SSH daemon is running. So SSH access from CentOS to Ubuntu is necessary. The first step is to check that SSH is working. I want to keep any problem isolated. And it's working. Let's backup or synchronize the /etc directory where the entire configuration of CentOS. The user that runs the rsync command should have read access to each file on the source location, and the user that connects to the remote server should have write access on the destination. So on CentOS, I'll run the rsync command as root. In /etc, there are files that can be read only by root. So sudo rsync -av -e/ssh, the source /etc, and the destination. I'll use the same format as in the case of SCP. So the user at the server's IP address, colon, and the destination directory, etc CentOS. You notice that the syntax is similar to SCP. The destination part is indicated as the username that will connect to the remote server, at the IP address of the server, colon, and the remote path or where the files will be copied. Note that no space is allowed between the username, the IP address, and the remote path. I'm hitting enter, and it will start copying the files. That was the sudo password, and now the authentication to SSH. It's done. If I run it again, it won't copy anything because the source and the destination directories are already synchronized. Nothing was copied. But if I change anything in the source location, only the changes will be copied. Let's add a new group. Group add DevOps. Of course as root. And I'm also creating a new file. I'm running rsync again just to check that only the modified files will be copied to the destination, overwriting the old ones. Great, only those files were copied. If you want to delete the files that were deleted in the source directory from the destination directory, add the -- delete option. This is useful for mirroring when you want two directories to always have the same contents. Without this option, it will not remove such files. I'm removing the file that I've just created. This one. And I'm running rsync without the -- delete option. I'm running in fact the same command. It will not delete the file. You see, the file was not deleted from the destination, and I'm adding the -- delete option. Take care not to add the option between -e and SSH. And the file was deleted from the destination. If you want to specify an SSH port other than the default 22, then after the -e option, put everything between quotes and use any option of the SSH command, like this. This is how you specify another port. Now let's transfer data from the remote to the local machine. All I have to do is switch the source and the destination. So rsync -av -e SSH, the source, and this will be the remote server. For example, I'm copying this directory, my project. So student at the IP address, colon, tilde, and the name of the directory, my underline project. And I'm copying it in the current directory. And the directory was copied. Note that all other options that we've discussed in the previous lecture, like excluding files, are still available. Okay, that's all. Making a good backup and testing it is probably the first thing a good sysadmin should do. In case of a disaster, you'll be fully covered. In this lecture, we'll be discussing the wget command. This is a GNU command line utility for downloading files from HTTP, HTTPS, and FTP servers. It provides a number of options allowing you to download multiple files, resume downloads, limit the bandwidth, mirror a website, and much more. The wget package is pre-installed on most Linux distributions, but in case you don't have it, simply install it by running apt install wget on Ubuntu or dnf install wget on CentOS. Let's see the first example and download Kali Linux as an ISO file that can be later installed. By the way, Kali is a Linux distribution used for defensive security and ethical hacking. The first step is to get the URL of the file. You normally go to the website, find the URL, check that it goes to the right file, and copy it to the clipboard. So right-click on it and copy the link location. In the terminal, write wget and paste the URL from the clipboard. Note that in the terminal, the shortcut is Ctrl-Shift-V to paste from the clipboard. I'm hitting enter and it's started downloading the file. See how wget is showing the progress bar alongside with the file name, file size, download speed, and the estimated time to complete the download. Once the download is complete, you will find the downloaded file in the current directory. Now I'm interrupting the download by pressing Ctrl and C. If you want to save the file into another directory, use the capital P option. For example, mkdir kali wget minus capital P, the destination, and the URL. I'm pasting the clipboard. Okay, I'm interrupting it because it takes some time. If you want to limit the download speed so that wget does not consume the entire available bandwidth, use the --limit rate option. By default, wget will consume as much bandwidth as it can. I'm gonna limit wget to 100 kilobytes per second. After the command's name, I'm adding the option --limit rate equals 100k. I'm hitting enter. Take a look here. See how the download speed was limited to 100 kilobytes per second. Use K for kilobytes, M for megabytes, and G for gigabytes. Let's go ahead and see how to resume an interrupted download. By default, if the connection drops while wget is downloading the file, next time when you try to resume it, it will start from the beginning. I'm interrupting the download and start it again without the limit rate option. And when it has already downloaded 100 megabytes, I'll stop it. If I resume it, it will start from scratch. I'm resuming the download. And it has started from scratch. This behavior is not good for large files. To resume a download, use the -C option. I'm starting it again, and at 100 megabytes, I'll interrupt it. I'm adding the -C option. Okay, and I'm resuming it using -C. And you see how the download is continuing from where it was left, so from 100 megabytes. If you want to download multiple files at once, you can use the -I option and the path to a file which contains each URL on its own line. In this example, I'll download these two images from kali.org. First, I'm opening the image in a new tab. And I'm copying the address, the URL. On Linux, I'm creating a file. For example, images.txt, and I'll paste the address of the image. I'm pasting from the clipboard. And I'll do the same for the second image, for this one. I'm saving and exiting the file. And I'm running wget -I and the path to the file. It's in the current directory, so I'm writing its name. And wget has downloaded both images. They are in the current directory, in the user's home directory. For a huge download, like an ISO file, you may want to put the download in the background using the option -B. I'm running again the command that's downloading the ISO file, and I'm adding the -B option. It's running in the background. You can always check the status of the download using tail -F and the log file. This is the name of the log file, wget -log. You see its progress. I'm stopping it, pressing Ctrl and C. I'm killing wget. Even better, you can use no-hop to make it immune to the terminal closing. It will not receive the hang-up signal if you close the terminal or your SSH connection drops. So, no-hop at the beginning. This is even better. Sometimes you want to create an offline copy of a site that you can take and view even without internet access. Using wget, you can do it easily. Let's see the options. wget ---- mirror ---- convert links ---- adjust extension ---- page requisites ---- no parent and the site's address. For example, http://example.org. Let me explain to you the options. Mirror, among other things, makes the download recursive. Convert links will convert all links, including CSS style sheets, to relative paths so they will be suitable for offline viewing. Adjust extension will add suitable extensions to the file names such as HTML or CSS depending on their content type. And page requisites will also download things like CSS style sheets and images to properly display the page offline. And no parent is necessary not to ascend to the parent directory as well. It's useful to restrict the download to only a part of the site. You can also shorten the command and run it as wget -mk and the URL. Note that there are two P letters. The first one is for page requisites and NP is for no parent. When troubleshooting network connectivity issues, one of the first things you should do is check if the server application is listening on a specific port on the machine. In this lecture, we'll talk about the netstat and ss commands used to find out which services are listening and on what ports. Let's display all open ports by running the netstat command with some options. It's recommended to run the command as root. So sudo netstat -tupa and then. Let's take a look at the options. -t shows TCP ports, -u shows UDP ports, -p shows the process ID and the name of the program which is listening, -a shows all ports, both listening and not listening, and -n shows numerical addresses instead of trying to determine symbolic host and port names. In the local address column, if you see something like 0.0.0.0 as an IP address, it means that the process is listening on all IP addresses of the host. And these triple colons are in fact IPv6 addresses. It's common to check if a specific port is open by filtering the output using grep. Let's see if port 22 is open. netstat -tupan pipe grep :22. And we see it's open and that SSHD is listening. Let's check port 80. And it's not open. It's closed because the output is empty. And of course, I can also filter on other criteria. I'm installing nginx, which is a well-known web server if it's not already installed, and starting it. Sudo apt install nginx. It's done, and I'm checking its status. Sudo systemctl status nginx. It's running. Now, let's check if port 80 is open. And it's open. Let's move on and talk about a similar command, which is ss. This is a newer command which probably sometimes in the future will replace netstat. ss stands for socket statistics and shows the information similar to netstat. It can display more TCP and port state information, and it's faster than netstat. The common options are almost the same. So to get a list of all listening ports, run ss -tu pan. Another useful command is lsof, which stands for list open files. To get a list of all the files that are opened by any process in the system, run lsof without any option. So lsof. There's a lot of output, and maybe not all is very useful. It's more convenient to use specific options to get the required information. For example, let's see all the files opened by the processes of a specific user. lsof -u and the username. These are all the files opened by the student user, or by root. It's better to run it as root. You can also use a negation to see all files opened by anyone except a specific user. Let's see all the files that are not opened by the user root. Sudo lsof -u caret. This means negation and the user root. Great. Or to list all files opened by a specific process, use the -c option, like lsof -c nginx. Let's see all the files opened by nginx. And these are the files. Now let's get back to ports and check listening ports using lsof. I want to see the files which have opened TCP ports. I'm running the following command: sudo lsof -i TCP -s TCP written in capital letters :listen. -i-TCP and -s TCP :listen shows only the files that opened TCP ports which are in the listen state. And you can add the -n capital P option to see both ports and host names in numeric format. Now you are seeing 22 instead of SSH. Sometimes you see an open port and want to find out which file has opened it. Then you should run sudo lsof -i-TCP : and say 22. I've chosen a random open port, -s TCP : listen, and -np. And it's showing that SSHD has opened port 22 of type TCP. Note that netstat, SS, and lsof are used to display open ports on the current system, also known as localhost. This is the system on which you are running the commands. To check what ports are open on other systems, you have to scan the ports on that system. You can use the telnet command or a professional port scanner like nmap. For example, from Ubuntu, I want to check if port 22 is open on CentOS. And I'm running telnet, the IP address of CentOS, this one, and the port 22. And the port is open. But port 25 will be closed. You can check the ports on any other machine to which you have an active network connection. For example, telnet, google.com, 443. And it's open. But 22 probably will be closed. It's closed. I'm getting no response back. Let's move to nmap, which is a professional port scanner. First, you have to install it by running sudo apt install nmap. The basic way to run nmap is nmap and the IP address of the target. It will scan the most used ports and display a summary. So sudo nmap and the IP address of CentOS. We are waiting. It's almost done. And it's saying that port 22, on which SSH listens, is open. Or if you want to scan only a specific port, then use the -p option. Let's see if port 80 is open on linux.com. And it's open. A web server is listening on that port. I can add the -S option to scan its version. But port 81 will probably be closed or filtered. Even if port scanning is not illegal, my recommendation is to scan only your own hosts and networks. Nmap is a very complex application and will have a dedicated section on it called Information Gathering and Reconnaissance later in the course. Most applications on Linux are open source. We are provided with the source files of the application, and in order to run it on our platform, we have to either compile the sources or install it from a binary package. A binary package in the Linux context is an application package which contains executables, as opposed to source code. The executables are the outcome of the compilation process. In this lecture, we'll discuss how to manage the software applications on Ubuntu and other Debian-based distributions like Linux Mint, MX Linux, or Kali using dpkg. Deb is the installation package format used by all Debian-based distributions. This is in fact an archive that contains other files including the executable application that was already compiled. By the way, the name Deb comes from Debra, which is the wife's name of the Debian founder. I'm downloading Google Chrome, which comes as a Deb package. Instead of installing it, I just want to see its contents. I'm saving the file. Perfect. It was saved in the downloads directory in the user's home directory. Here. Instead of installing the program, I want to see its contents. I'm clicking with the right mouse button on the file and then select Open with other applications. And I'm clicking on Archive Manager and select. This is the contents of the deb file. And we see that inside the deb file, which is an archive, there are two other archives. One archive contains metadata information about the version, the release, the dependencies, and so on, and the other one contains the application files. Package management operations can be performed with different tools available, from the lowest level command dpkg to apt or graphical frontends like Synaptic. dpkg provides the low-level infrastructure for package management. The dpkg database contains the list of the installed software on the current system. It can work with local deb package files and does not know about repositories and does not solve dependencies like apt does. Note that other advanced tools like apt will call dpkg behind the scenes, so they are in fact based on dpkg. If you have a local downloaded application as a deb file, you can install it using dpkg. I'm moving to the directory where Chrome was downloaded, so cd downloads. This is the deb file. Let's display information about the Chrome deb package and then install it. dpkg --info and the name of the file. And we see lots of information. And to install the package, run dpkg with the -i option. Only root can manage applications on Linux. So sudo dpkg -i and the name of the deb file. It's extracting and installing Google Chrome, the Chrome browser. It was successfully installed. I can start it. If you want to install more packages at once, you don't have to run the dpkg command multiple times. Just provide all deb files as arguments to a single dpkg command. This is especially useful if there's a circular dependency. Take a look at this image. Package A depends on package B, which depends on package C, which in turn depends on package A. In this case, you need to give all three packages in the same line to dpkg. Let's return to the terminal. To get a list of all installed packages, run dpkg --get -selections. These are all installed programs on the system. Or if you want to see the package version, the architecture, and the short description, run dpkg -query with the -l option. So dpkg -query -l. And you can filter the output using grep. So grep chrome. It has displayed information about Chrome. The first two letters, I in this case, indicate the desired state which is installed and the package status which is installed. A Debian package is an archive that contains other files. If you want to list all files installed on your system from a package, run dpkg with the capital L option and the package name. The first step is to find the exact name of the package. So I'm running dpkg -query -l pipe-grep chrome. This is the exact name of the package. I'm copying it to the clipboard. And dpkg -L and the package name. I'm pasting it. These are all the files from the package. Let's see another example. dpkg query -l pipe-grep ssh. This is the name of the OpenSSH server package. So dpkg -L and the name of the package. Great. If you want to see to what package a specific file belongs to, then use the capital S option. Suppose an important file got corrupted and you want to reinstall the package. Let's see to which package the ls command belongs. Which -a ls. And dpkg -S/bin ls. I'm taking the second path. And we see that the package that contains the ls command is called coreutils. And to see all the other files from this package, run dpkg -L and the package name, coreutils. I'm piping the output to less. And we notice that this package contains the core utilities of the system. cp, mkdir, mv, rm, touch, and so on are some of the most used and well-known Linux commands. To remove an already installed package, use the -r or --remove option and the package name. Let's remove the Chrome browser. Sudo dpkg -r and the name of the package. Google Chrome stable. Note that the -r option does not remove the configuration file as well. If you reinstall the package, you'll have the same configuration. If you want to remove both the application and the configuration files, use the capital P or --purge option. So dpkg -P and the name of the package. And of course, run it as root. You've just learned the basics of package management using dpkg on Debian-based distributions. However, dpkg is a low-level tool that neither works with repositories nor solves dependency problems. The recommended way of managing packages on a Debian-based system is to use the apt tool. We'll take a short break, and in the next lecture, we'll discuss apt. The recommended way to manage software packages on Ubuntu and other Debian-based distributions is to use apt, which stands for Advanced Package Tool. This is an advanced interface to the Debian packaging system which provides the apt-get and apt-cache programs. Note that on the newest versions of Ubuntu and other such distributions, the apt-get and apt-cache tools were merged into a single command simply called apt. However, apt-get is still available. In this lecture, we'll discuss the new tool apt, which has a fancier colored output and it's more pleasant. Unlike dpkg, apt does not understand deb files. It works with packages that are downloaded from repositories and calls the pkg directly after downloading the deb archives from the configured sources. An apt repository is a web server which contains a collection of packages with metadata that is readable by the apt tool. So to use apt for package management, an internet connection is required. Having an apt repository allows you to perform package install, removal, upgrade, and other operations on individual packages or group of packages. Repositories are essential for storing, managing, and delivering software on Debian and Ubuntu systems. A special kind of repository hosted on servers like Launchpad are PPAs. PPA stands for Personal Package Archives. Such a repository is maintained by people who are not official Ubuntu developers. Let's go to the terminal and see some practical examples. Only root can manage packages, so all commands should be executed by root. As to make things easier and to not prefix each command with sudo, I'm temporarily becoming root by running sudo su. I'm root in this terminal. apt uses an index or a local database that holds records of available packages from the repositories enabled in the system. To update the package index, run as root apt update. This will pull the latest changes from the apt repositories. It's recommended to run this command each time before installing or upgrading new packages. Note that the command doesn't install or update any software application. It just updates an index. To install a new program, run apt install and the package name. I'm installing the Apache web server, apt install Apache2. Apache2 being the name of the package. It will install the specified package and all its dependencies. It's displaying a summary about its operation and prompting for yes or no. If you write yes, it will download and install those packages. I'm installing it. It failed to start the server because probably another web server listens on port 80. Address already in use. So I suppose that's nginx from the previous lectures. Let's check it. Systemctl, status, nginx. Nginx is active and running. So port 80 is already used. I'm stopping nginx. And I'm starting Apache. Systemctl, start Apache2. It has started successfully. Let's check its status. It's running. I can connect to the server. So I'm connecting to localhost. Great. It works. If you want to install multiple packages with one command, specify them as a space-separated list. For example, apt install gparted vlc. Gparted is a graphical application to manage disks, and VLC is a media player. In fact, I won't install them. Using apt, it's also possible to install a program from a local deb file. Just run apt install and provide the full path to the file as argument. Let's go to the directory where the Chrome browser was saved. Home student, downloads. And I'm installing it. Apt install and the path to the file. Home student, downloads, Google Chrome stable. It's installing Google Chrome. It will call dpkg behind the scenes. I've got permission denied, so I have to prefix the command with sudo. So sudo apt install and the path to the file. If you don't provide the full path, the apt command will try to retrieve and install the package from the apt repositories, so from the internet. So if I just provide the file's name, I'll probably get an error. Unable to locate package. So always provide the full path when installing an application from a deb file using apt. To get a list of all packages that can be upgraded, run apt list -- upgradable. If the package already exists, apt install will upgrade it to the latest version. So apt install Python 3 apt. It already exists and it will update the program to its latest version. If you want to upgrade the system as a whole, run apt full -upgrade. This will remove some installed packages if that is needed to upgrade the whole system. If you want to run this command from a shell script, then pass the -y option, which means assume yes as answer to all prompts and run non-interactively, like this. To remove an installed package, run apt remove and the package name, apt remove apache2. Provide multiple packages separated by spaces to remove them all. The remove command will uninstall the given packages, but it may leave some configuration files behind. If you want to remove the package including all configuration files, use purge instead of remove. So sudo apt purge apache2. It was purged. Take a look at this message. Whenever a new package is installed on the system, the package dependencies will be installed too. When the package is removed using apt remove or apt purge, the dependencies will not be removed as well. You can always remove these dependency packages since they are no longer used. To remove the unneeded dependencies, run apt auto remove. Auto remove written in a single word. By default, Ubuntu keeps every package that has been downloaded and installed in a cache directory on the disk. This is the cache directory. var cache apt archives. This is the directory that contains all installed and upgraded packages. Let's check its size. It's pretty big. To clear out the local repository of retrieved package files, run apt clean. It removes everything but the lock file from that directory. Let's check the contents of the directory again. And it's empty. It's only the lock file there. Let's go ahead and see how to get information about the available or installed packages. To list all available packages, run apt list. There are tens of thousands of available packages in the repositories. Let's see how many there are. So pipeless wc -l. There are a lot. To search whether a specific package is available, filter the output with the grep command. For example, grep postfix. This is a well-known email server. And it's available. To find packages whose description contains a word or a phrase, run apt search and the phrase between double quotes. For example, transparent proxy. And it found a few packages. To get a list of only the installed packages, add the -- installed option. So apt list -- installed. These are all installed packages on the system. Let's see how many there are. 1722. To find information about an available or uninstalled package, including its dependencies, download size, and the description of its contents, run apt show and the package name. For example, apt show apache 2. Okay, or apt show zzuf. There are also graphical package managers, Aptitude or Synaptic being some of them. They enable you to install, upgrade, and remove software packages in a user-friendly way. Let's install and start Synaptic. Sudo apt install Synaptic. It was installed and I'm starting it. This is Synaptic. You can search for, remove, or upgrade packages in a graphical way. In this video, you've learned how to use apt to manage application packages on Ubuntu and other Debian distributions. Thank you. Welcome back. Now you have a good understanding of how to install binary packages using a package manager both on Ubuntu and CentOS. Even though this is the recommended way to manage software packages on a modern Linux distribution, there are times when you will prefer to compile the application from the source code. Let's see what are the benefits of compiling from source code to installing using the package manager. One advantage of compiling from source is that you can compile applications with certain options which may be missing or disabled in the standard distribution package. Suppose you want to install an FTP server and the IPv6 support is disabled in the binary package. When the server was compiled from source into the binary package by the distribution maintainer, IPv6 was not added. What you can do is download the source code and compile the server with IPv6 enabled. Vice versa is also possible. Maybe you are not using IPv6 at all, but it was enabled in the binary package. This means thousands of code lines with possible bugs were compiled in the final application to have a feature that you don't actually need. Another advantage of compiling from source code is that you have faster access to the latest version of an application. Imagine that a security bug was just discovered and the development team has just released the source code of a new version with the vulnerability patched. There may be some time between this moment and the time the distributor launches a binary package such as a deb file. And in the meantime, you are not protected. If you want to have access to the latest release version, you have to compile the software. This is at least temporary until the binary package is released. To make it clear, let's check the latest version of the Apache web server on apache.org, the official website. And it seems that the latest version is 2.4.43. Now let's check the latest version of the server available in the official repositories of the latest version of Ubuntu. apt show apache 2. And it's 2.4.41. We notice that if we install it from a binary package, we won't have access to the latest version of the server. Also, compiling the sources makes it easy to have multiple versions of the same program installed, not to mention that you can choose an exact version of a package which may be already removed from or not yet present in Ubuntu repositories. In my case, I have several versions of Python in /opt directory as I need it to run some older software. Compiling the source code has disadvantages as well. The package manager will be completely unaware of the changes you have made. So it won't be possible to update or remove the application using the package manager. You have to check it manually from time to time to see if a new version was released and compile the new version again. If you are not careful when compiling to install the program in a separate location, you can break your system. And compiling is not the easiest job. If you can install and then use an application in a matter of seconds when using the package manager, compiling the same application could be troublesome. You have to download the source code from the official website, check its integrity, solve any dependency problems, and so on. Let's draw a conclusion. As your first option, always consider installing from standard repositories using the distribution package manager, and after that, take into consideration to compile the sources only if you know exactly why you need to do this. Probably you won't compile software from source code on a daily basis, but as an effective sysadmin, you need to know how to do it in case you really need it. In the next lecture, I'll show you how to compile from source code. In this lecture, I'll show you how to compile software from source code using a hands-on approach. Let's see what are the prerequisites. Typically at your job, you'll need to compile servers, and these are programmed mostly in C and C++ programming languages for maximum efficiency. To be able to compile the source code, you need the GNU Compiler Collection, or GCC, which is a collection of compilers and libraries for C, C++, and Objective-C. The default Ubuntu repositories contain a meta package named Build Essential that contains the compilers and lots of libraries as well as other utilities required for compiling software. Using apt, I'm installing Build Essential on Ubuntu. Sudo apt update && sudo apt install Build Essential. This will install in fact plenty of other packages, including GCC, G++, and Make. I've already done it before. GCC is the GNU C compiler. G++ is the GNU C++ compiler, and Make is an utility used to build a collection of source files and transform them into the final product. If you are running CentOS, then there's a package group called Development Tools that contains all the required components. On CentOS, I'm installing Development Tools. Sudo dnf group install Development Tools. It will install in fact plenty of other packages as dependencies. We'll start by compiling a single C source file, and then we'll compile a more complex application. I'm creating a basic Hello application in C. Using Vim, I'm creating a file with .c extension and pasting the following code. hello.c. This is the typical structure of a very basic C program. I'm saving the file and then compiling it into an executable. Compiling means transforming the source code, which is human readable, into machine code. So GCC, the source file, -o, the binary, hello. The command has created a binary file called hello in the current working directory. This is the executable file I've just compiled. Let's run it. /hello. Hello world. You've just seen that compiling a single source file is very easy. Now let's compile a server. I'll take one of the most well-known FTP servers, the ProFTPD, which means Professional FTP Daemon. The first step when compiling a program is to get its source code. This is available because it's open source, so anyone has access to the source. Go to the official website, proftpd.org, and download the latest release. This is 1.3.7a, and I'm clicking with the right mouse button on the gzip archive. And I'm selecting copy link address. And in the terminal, I'm writing wget -c, and I'm pasting the contents of the clipboard. I'm downloading the source code. The file was downloaded in the current directory. This is the file. The second step, which is optional but highly recommended, is to check the integrity of the file, especially if you install it on a production server. You can do it by checking its hash or digital signature. The author publishes the hash on its webpage, and I'll calculate it locally as well. If they are the same, then the integrity of the archive was verified. Let's see its hash. This is the MD5 hash, and I'm calculating it locally as well. MD5 sum and the file. Let's compare the hashes. I'm copying it and pasting it in the terminal. I've got the same hash, so I assume that's okay. The third step is to extract the archive. It's compressed as a tar archive, so I'm running tar -xzvf and the file. A new directory that contains the source code of the server was created in the current one. I'm moving to that directory since all following commands will be relative to that directory. By the way, the source code is in the src directory. In this one. This is the source code of the server. In this directory, we see there's an executable file, a script called configure. This is very important since it does two things. It's checking if the requirements and dependencies of the program you are compiling are satisfied, and it's configuring how the program will be compiled, which options will be enabled, and which ones will not. If, for example, you don't have the GNU-C compiler installed, or if a required library is missing, then configure will show you the error. Troubleshoot the problem and run configure again until there will be no error. Don't go further with the compilation process if configure throws any errors. This script has lots of options to control how the program will be compiled. To learn about its options, run /configure --help. By the way, it's recommended to run configure as a non-privileged user and only the final step of the compilation process as root. I'm executing the script using // and the script name because I want the shell to execute the script from the current directory. Let me show you something. If I simply run configure, the shell will search for it in the path and will not find it. And you'll get the error command not found. So run it by prefixing its name with /. I'm running the script. It has displayed a lot of output, so I'll pipe it to less so that I can navigate through the output. Pipe less. Let's take a look at the most important options. ---- prefix and the directory specifies where the software will be installed. If you don't use this option, the application files will go to the standard directories like /bin, /usr, /bin, /etc, and so on, and overwrite any other files with the same name. This could break your system. My advice is to always use the prefix option when compiling a program. You can fine-tune your compilation with many options which are specific to each program. What I want to show you is how to compile or not some features into the final product. Let's search, for example, for SSL. And there's an option called Enable SSL, which is by default no. This means that without specifying this option, the FTP server will be compiled without SSL support, so it won't support encrypted connections. If you want it to support SSL, then give this option to configure. This is applicable to any other option. Let's search for IPv6. I'm searching backwards. There's Disable IPv6, which disables IPv6 support, and by default the option is not given or IPv6 is not disabled. If you know you are not using IPv6, you can disable it using this option. Okay, I'm quitting less. I'm running the configure script only with the prefix option. -- prefix equals opt prefTPD. You can install it anywhere, but it's recommended that programs that are compiled and are not controlled by the package manager to be installed in a directory under /opt. opt comes from optional software. Also note that you don't have to create the prefTPD directory by hand using mkdir. It will be created automatically. I'm hitting enter. See how it's checking the environment. It's looking really nice, like in a hacker movie. If you get any errors, solve them and run configure again. Move to the next step only when the configure script finishes without errors. The common errors are related to missing dependencies. When you compile software by yourself, you have to take care of the dependencies as well. We are waiting for it to finish. There's no error, so I can go ahead with the next step. The next step is to run make. This is a GNU utility that will build your application. This means it will take a collection of source files and metadata and transform them into the final product. It does the real compilation by invoking the GNU C compiler multiple times. To compile the program, make will use a file called makefile that's in the current directory. This is the make file. This file was generated by configure at the prior step and contains details about how the final product should be. I'm executing make. See how make is invoking GCC behind the scenes multiple times. If compilation encounters some problems, then the errors are thrown on the console. They are in general fatal. Try to solve them, run make clean, and then make again. I hope there will be no errors. Great! Once the compilation is done successfully, then all the required binaries are created. Run make install, this time as root, which is the final step. This will create the directory where the software will be installed, in this example, /opt/prefTPD, and move all the files there. And it's done. The FTP server was installed by compiling the sources and can be run. At this moment, the sources are not necessary anymore and I can remove them. Let's move into the server's directory. The directory contains everything related to the server I've just compiled. There's no other file outside this directory, so to remove the server, just remove this directory. Let's start the server. I'm moving into the sbin directory, which resides in the server's directory. Take care not to move into /sbin. This is another directory. And the file named prefTPD is actually the server. I'm starting the server by running the file as root. In Linux, a server can be started only by root. Normally, a server runs in the background as a daemon, so I'm adding an end at the end. And sudo to run as root. The server has started. We can search for the process by running ps -ef pipe grep pro ftpd. This is the process. Or pgrep -l pro ftpd. It's running. To stop it, run kill and its process ID, or pkill and its name. I'm stopping it. And of course, as root. Let's search for the process again. It's not running. It was stopped. The server was killed. Note that you cannot control a server that was compiled using systemctl like you do for one that was installed using the package manager. You start it by running the executable and stop it by running the kill command. To test that it works as expected, I'll start it in the foreground in debug mode using the -n option. When I want to stop it, I'll press Ctrl and C. So sudo /proftpd -n. The server started in the foreground. This is just for testing. Let's connect to the server using an FTP client. There are lots of good FTP clients out there, FileZilla being a cross-platform one. However, for this simple test, I'll connect to the server using the browser. I'm opening Firefox, and I'm connecting to FTP, // and the server's IP address, localhost. And it has connected and asking for a username and password. I'll enter a system username and password. So student and its password. And I'm hitting enter. It has displayed the home directory of the user. It's working just fine. The main purpose of this lecture was to show you how to compile standard applications, not to configure the ProFTPD server. But if you want to change the way the server works, you should know that its configuration file is this one, opt proftpd etc proftpd.conf. This is the configuration file of the server. There were a lot of talks because I want you to deeply understand how to compile programs, but actually we can do anything with only one command. I'm downloading the server again. I'm showing you the fast way. The server's source code. I'm extracting the archive. I'm moving to that directory. And I'm running a single command. Configure --prefix equals opt proftpd1 &make sudo make install. You should run all the commands as root, or at least the last one, which is make install. And that's all. This is how you compile and install the server with only one command. It will run the first command, which is configure. If it doesn't return any error, it will run the make command. And if make does not throw any error, it will run make install. If any command in the chain returns an error, the next command will not be run. Okay, that was a standard compilation guide which is applicable to most well-known applications. However, there are applications that need to be compiled in a custom way. In that case, you have to read the documentation of the program. It is normally a file called install or readme in the source directory. In this lecture, we'll talk about cron, which is one of the most useful utilities when it comes to Linux administration. It allows you to schedule commands or tasks, also known as cron jobs, at a specific time. Cron runs as a daemon and is used to automate repetitive tasks like backups, monitoring disk space usage, updating the system with the latest application versions, sending emails, rotating logs, and so on. I think there's no Linux server that does not run at least a few cron jobs. The word cron tab has three different meanings. The text file that contains the user's cron jobs is called the user's cron tab. There's such a file for each user, and on Ubuntu, the files are located in /var, spool, cron tabs. Of course, only root can access the directory. And there's the command called cron tab used to manage the cron tab files. This is the command. And there's also a configuration file for the system-wide cron jobs called cron tab located in /etc. This one. There are two types of cron jobs, system-wide and individual user cron jobs. Let's take them one by one and start with the individual cron jobs. Each user has a cron tab file, which is short for cron table, where all scheduled cron jobs of that user are specified. These files are located in a subdirectory of var spool cron. The exact location can depend on the Linux distribution. Being text files, you can edit the cron tab files by hand using a text editor, even though they are not intended to be edited directly. It's recommended to use the cron tab command instead. This will open the file using your preferred or default text editor and validate the file's structure on exit. Let's go ahead and dive into the cron tab command. To display the contents of the cron tab file of the current user, run cron tab -l. At the beginning, the users have no cron tabs. To edit the current user's cron tab file, run cron tab -e. E comes from edit. You will be prompted with some editors to choose from if there's no default editor set. I'm choosing Vim. Note that the lines that start with a hash sign are comments. Each task to run has to be defined through a single line that consists of 6 fields separated by a white space. The first 5 fields define when the task will be run, and the last field represents the command or the script to run. The cron jobs can be scheduled to run by minute, hour, day of the month, day of the week, or any combination of these. You don't have to memorize the time fields because they are described on the last line. Minute, hour, day of month, day of week, and the command. The first field indicates the minute, the second the hour, then comes the day of the month, the day of the week, and finally the command. If for a specific field you use an asterisk, a star, it means always or any value for that field. For example, an asterisk in the day or the week field means every day or every week. Note that the minimum time unit used by cron is the minute. If you want to schedule a task to run every 15 seconds, then you cannot use cron. Create a bash script with a white loop and run the script instead. Let's try some examples. Let's suppose you want to run a backup script every day at 6 a.m. So the minute 0, the hour 6 a.m. and 3 stars. And the command, for example, root backup.sh. This is the path to a bash script. I'd also have some remarks. The hour is given in 24-hour time format, so between 0 and 23. Do not use PM or AM. If you want to run the command at 4 p.m., you write 16 in the hour field. This is the hour field. The day of the week, which is the last time field that specifies the time, can be between 0 and 7, where 0 equals 7 equals Sunday. So if I run the backup script to run only on Sundays at 6 a.m., I'll write 0 or 7 in that field. Like this. The script will run on Sundays at 6 a.m. Let's see another example. Suppose you want to run a script that monitors the free disk space every minute. So, every minute means star for the minute, star for the hour, 3 other stars, and the path to the script. For example, check space. .sh. It will run every minute. Another example. If you want to specify a list of discrete values for repetition, use the comma operator. For example, I want to run the task at 4, 6, and 10 a.m. So, the minute will be 0, and in the hour field, I write 4, 6, 10. Another one. If you want to specify a range of values, use the hyphen operator. Let's say I want the task to run on weekdays between 9 and 5 p.m. once per hour, so during working days and hours. And that means the minute and now the time interval. 9-17. It means between 9 and 17 or 5 p.m. Every day of month, every month, and in the last field, I write 1-5 5. It means from Monday till Friday. And the path to the command or to the script. For example, root, I don't know, firewall.sh. And another one. You can also use the slash operator to specify values that will be repeated over a certain interval. For example, if you have */3 in the day field, it means the action will be performed every 3 days. Let's write such an example. 24,21 */3. I have 3 fields, so I need another 2. And the path to the script. In this example, the task will be run every 3 days at 4 and 21 at minute 10. There are also several cron macros used to specify the most commonly used intervals. Yearly or annually will run the specified command once a year on the 1st of January at midnight. Like this, at yearly and the path to the script. Happy New Year. Monthly runs the specified task once a month at midnight on the first day of the month. And weekly runs the specified task once a week at midnight on Sunday. And daily runs the specified task once a day at midnight. Daily. And hourly runs the specified task once an hour at the beginning of the hour. And finally, at reboot, runs the specified task at boot time. Let's see a practical example. I want to append the current date and time to a file every 2 minutes. First, I'll comment out all the lines I've written. They were just examples. And I'm writing */2, it means every 2 minutes, and then 4 stars. And now the command date, $sign, and the path to a file, date and time.txt. And I'm saving the file and exiting. So WQ. To see that it really works, I'll display the cron log file in real time using tail-f. So tail-f var log syslog. This is the cron log file on Ubuntu. On CentOS is var log cron. This is the name of the file on CentOS. And we'll see shortly how cron runs the command. I'm waiting for at most 2 minutes. And we see this line. The cron task was executed. I can also display the contents of the file that was created by cron. So cat tmp date and time.txt. And we see there the date. To remove your cron tab file, run cron tab -r. I'm not removing it. Note that root can edit, list, or remove other users' cron tab using the -u option and the username. For example, I'm becoming root and create a cron tab for the student user. So sudo su, I'm root, and cron tab -e -u student. And it opened the cron tab of the user student. And I'm adding something randomly. I'm saving the cron job and then removing it. So cron tab -r -u student. Now the user student doesn't have any cron tab. An important remark is that cron sets and uses its own environment variables. The path variable is of special importance because if the command you are executing is not present in the cron specified path, you'll get an error, and this is very common for beginners. Use an absolute path for the command or the script to execute. Keep this in mind. Root can also set some restrictions in regards to which users have access to their own cron tab files. Man cron tab. take a look at this paragraph. There are two files of importance, cron.allow and cron.deny. These files will decide which users are allowed to use the cron tab command. As you can see, scheduling cron jobs is easy. However, there are a few web-based cron tab syntax generators available to make this even easier. Two such websites are crontab.guru and crontab-generator.org. You can play around to learn cron jobs examples. Just enter your desired dates and times and it will instantly generate the cron tab line for you. At the end, let me tell you a few words about system-wide cron jobs. Besides the user's cron jobs we've just seen, there are some system cron jobs that will be run as root. How does it work? You simply move your scripts inside some directories. These are the directories: /etc, cron.daily, hourly, monthly, and weekly. And the scripts will be executed every hour, day, week, or month. For example, if I move my script to cron.hourly, the script will be executed hourly. Then, etc cron tab specifies when exactly will these cron jobs be run. For example, all scripts inside the cron.weekly directory will be run on Sunday at 6:47 am. Cron jobs are intended for servers or machines that are running continuously. If the system is down when the cron job is scheduled to run, the task is lost. It will not be run when the machine starts. In the next lecture, we'll talk about anacron, which can be used to execute commands periodically without assuming that the machine is running continuously. Anacron is similar to cron, just that it's usually used on systems that are not up all the time, such as desktops or laptops. Anacron does not expect the system to be running 24/7 like a server. When you want a background job to be executed automatically on a machine that is not always up, you should use anacron instead of cron. For example, if you have a backup script scheduled to run every day at 10 p.m. as a regular cron job, and if your laptop is not up at 10 p.m., your backup job will not be executed when the system starts. It is skipped until the next schedule. However, if you have the same job scheduled using anacron, you can be sure that it will be executed once your laptop starts. If cron runs as a daemon, anacron is just a command that has to be run in order to execute the scheduled tasks. In fact, anacron is run automatically each time the system starts. Also note that anacron is run by root, so the tasks will have root privileges and the frequency of the job execution is expressed in days, not in minutes, like in the case of cron. The file which specifies the anacron jobs is etc anacron tab. Let's open the file as root. There are already 3 jobs which are in fact related to cron. By the way, run parts is a command which runs all the executable files found in a directory. For example, this line means that all executable files or scripts found in /etc/cron.weekly will be executed with a frequency of 7 days. Let's see what's the format of a line which in fact represents an anacron job. There are 4 fields. The first field is the period in days. It specifies the frequency of the job execution expressed in days. For example, a 1 in this field means run it every day, and a 7 means run it every 7 days or weekly. In this field, you can also use something like at daily, at weekly, or at monthly. The second field is the delay in minutes. It specifies how long anacron will wait before executing the job. The delay feature is intended to keep the system from being overloaded with lots of jobs if anacron determines it needs to run several commands when it starts up. It won't run them simultaneously, but with a delay. The third field is the job identifier. It should be unique for each job and is the name of a file that will be created under /var/spool/anachron directory. This is called the job timestamp file and will contain a single line that indicates the last time when this job was executed. This identifier has also the purpose to identify the job in the messages or the log files. And the last field is the command that will be executed. Let's schedule an anachron job. The anachron tab file should be opened by root. And at the end, I'm adding a new line, which is in fact a new job. I want it to run every 2 days with a delay of 1 minute. So 1 minute after the computer starts or anachron is executed manually. The name of the job will be backup. And the job will make a backup. So the script will be root backup.sh. However, for this example, I'll use a simple command just to check that it works. So date =sign /tmp anachron.txt. And I'm saving the file. Okay, the file is read-only because it wasn't opened by root, but there's no problem. I'm copying the line to the clipboard, exiting the file without saving, and opening the file again as root. And at the end, I'm pasting the line. Perfect. Now, I'm saving and exiting the file. Before running anachron, I can check for any syntax errors by running anachron -T. If there are any errors in the anachron tab file, it will print out a message indicating the error. And as root, I'm running anachron -D. Don't forget to run it as root. And it says the job backup will be run in 1 minute, so we are waiting. Normally, anachron jobs are run in the background and nothing is printed on the screen. However, when you test it, you want it to run in the foreground so you can see its output. That's what option -D does. It doesn't fork anachron to the background. The name of the job is backup, so the job timestamp file is called backup and it was created in /var/spool/anachron. Let's check it in another terminal. Sudo cat var spool anachron. And you see here the file. By the way, the job was executed. Let's check the contents of the file. And you see the timestamp. This is the date when the job was executed. This is how it knows how to execute the job again, in this case tomorrow, after a day, or when the computer will start, if it's down tomorrow, all day long. If I run anachron again, it will say that it has no jobs to run. All the jobs have already been executed. In this lecture, I'll show you how to mount and unmount file systems in Linux. As you already know, on Linux the structure of the file system is hierarchical, much like an upside-down tree. The root directory, which is a /, lies at the base of the file system, and all other directories are spreading from there. This is the root directory. If you want to access a file system that's on another partition or disk, you need to mount it or logically attach it to an existing directory of the unique file system. That directory is called mount point. To mount or to attach a file system in the directory tree, use the mount command. If you run it without any argument, it will display all currently attached file systems. The output is really large because it includes virtual file systems such as sysfs, tempfs, proc, and so on. We are not interested in the virtual file systems for the moment. This is, for example, the partition that is mounted on the root directory. To display only certain file system types, use the -T option. For example, I want to see only ext4 file systems. This is the default file system type for most modern Linux distributions. So mount -L -T ext4. L comes from list and T from type. And it has displayed only partitions of type ext4. Or only FAT32 partitions called vfat on Linux. Let's mount a new file system in a given location or a mount point. I'm gonna insert a USB stick. Note that in order to access USB disks in VirtualBox, you have to install VirtualBox extension pack. I've already shown you how to do that in the installation section at the beginning of the course. I'm inserting the disk. It was inserted and Windows has mounted automatically. To access it in Ubuntu, which runs in VirtualBox, in the running VM, go to Devices and select the USB stick. This is the disk. Okay, if you run Linux as the main operating system, you don't have to do that. By the way, on Ubuntu, when you insert a stick, it will be automatically mounted in /media, the username of the user who's logged in, and another directory with the name of the USB stick. I'm running mount again. This is the USB stick mounted on media. /media, the username, the name of the stick, and this is its contents. Sometimes it's not mounted automatically, like in the case of a disk partition, or you want to mount it in another place or with other options. In Linux, a storage device is logically represented as a special char device in /dev. In this example, it's SDB. This is the name of the file. This is a char device file that represents the USB stick. To find the name of the device file, you run as root fdisk -l. This is the file. You can also run the dmesg command to find the name of the device. Look, it's SDB. And lsblk is another alternative that will list all block devices. Having the name of the device file, we can mount it in any directory that already exists. I'm creating a new directory on the desktop. mkdir, home, student, desktop, and USB. It was created on the desktop. This is the directory. And I'm running the mount command. Note that only root can mount partitions using the mount command. So sudo mount, the name of the device file, /dev sdb, and the mount point, the directory where it will be attached. So home, student, desktop, USB. And it was mounted. We can access its contents in that directory. This is its contents. Note that you can mount the same physical device in different places. In this example, the USB stick is mounted on both /media and on the desktop. It's mounted on two different directories. The mount command will auto-detect the file system type. However, some file systems are not automatically recognized and need to be explicitly specified. Use the -t option to specify the file system type, like this. -t and its type, vfat. This is FAT32. Of course, it says that's already mounted. When you want to unmount a disk or a partition, run the umount command and the mount point. Umount and the mount point. Don't forget to run it as root. Note that the command is umount and not unmount, and you only give the mount point directory as argument. And you are allowed to unmount partitions only if they are not used. So close any open files or directories on that partition. Alternatively, you could try a lazy unmount using the -l or -- lazy option. It will unmount a busy file system as soon as it's not busy anymore. -l. It's not mounted. I've already unmounted. If you want to specify other additional options, use the -o option. let's mount it read-only. So sudo mount -o ro dev sdb and the mount point. I cannot mount it read-only on the desktop because it's already mounted read-write in /media. So first, I'll unmount the partition from /media. And now I'll mount it read-only. Great, it worked. Mount -l-t vfet. RO means that it was mounted read-only. You can only read the partition, you cannot modify it. If you realized that by mistake you have mounted it read-only, you can remount it with other options like this. -o rw, it means read-write, comma, remount. It was remounted read-write. Let's see how to mount an ISO file. Many downloadable operating systems, including Windows and various Linux distributions, are distributed as ISO images. To mount such an image, start by creating the mount point at any location you want. For example, mkdir ~/ISO. Then mount the image using the mount command and the -o loop option. Like this, sudo mount path to ISO file, the mount point, and -o loop. This is how you mount an ISO file. At the end, I want to give you some tips about disk partitioning. You can always use the fdisk command, which is the standard utility used to manage disks and partitions. However, at least for beginners, this is not the easiest task. You can get in lots of troubles and the risk of losing data is huge. My advice is to make a backup of the most important files before working with disks and partitions. And if you run a graphical interface, use a program called gparted instead. Gparted is a free partition editor for graphically managing your disk partitions. First install gparted using sudo apt install gparted. Once it was installed, simply start it as root. Sudo gparted. This is the application. This is the graphical interface of gparted, and after selecting the disk, you can perform many actions with partitions such as create or delete, resize or move partitions. In this video, we'll talk about another useful system administration command called dd. It is a command line utility which purpose is to convert and copy files. Compared to the cp command, which is used to copy regular files and directories, the dd command can be used to read and write from special device files. Remember that hard disks are represented in Linux as special device files. For example, in my case, the partition where the root directory is mounted is called SDA5 and is represented as a special file named SDA5 in the /dev directory. So dd can work directly with these device files and is used for tasks such as backing up the boot sector of a hard drive, cloning a disk or a partition to another one, or creating a bootable USB stick. Let's get started with some practical examples. Note that sometimes dd is humorously called disk destroyer due to its drive erasing capabilities, so be careful and make a backup of your data before continuing with the examples in this lecture. They could destroy all your data. The command line syntax of dd is slightly different from other Linux commands as it uses the syntax option equals value for its command line options. In the first example, I'm going to backup or clone an entire partition to a file on another partition. I'm going to insert and use a USB stick for these examples. Remember that if you run Linux in VirtualBox, you need to install VirtualBox extension pack on your guest OS, which is probably Windows, to have support for USB devices. Then go to Devices, USB, and select the USB flash disk. Okay, and it was automatically mounted. All the following commands must be run as root, so I'm temporarily becoming root, running sudo su. Let's see the device file, which represents the USB drive. I'm running fdisk -l. And we see that the file is /dev/sdb. Note that it could vary on your system. There's also another command named lsblk that lists block devices. And I'm running the dd command. So dd if equals the name of the USB stick file /dev/sdb, of equals home, student, let's say backup usb.img, and status equals progress. I'm hitting enter. if means input file and of means output file. You need to use the GNU dd command from core utils version 8.24 or above to use the status equals progress option. What we notice is that even though the USB stick is empty, look, it's empty, this is its contents, the command is copying data and you wonder what's copying. The dd command works with blocks and is in fact cloning the device by copying everything, both empty and occupied space. So if you have a partition of 10 gigabytes and 9 are free, the dd command will copy 10 gigabytes to the destination. This is one of the main differences from the cp command. I'm interrupting the command by pressing Ctrl+C. And when you want to restore the disk using the image file, you just use the image file as the input and the disk or partition as the destination. So dd if equals the image file, home student, backup usb.img, of equals, for example, /dev, and I'll use the same USB disk, so sdb. Status equals progress. Okay, it's working. You can also add the sync option to copy everything using synchronized input-output. And I'm writing conv equals sync. It's using synchronized I/O. I'm interrupting it by pressing Ctrl+C. Let's see another example. This time, I'm cloning a partition to another one. With dd command, you can clone the entire hard disk or just a partition. Of course, the destination partition should be at least the same size as the source partition for this to work. I'm gonna clone the partition where the root file system is mounted to the USB stick. So fdisk -l to see the name of the partition. And it's SDA5. This is the source partition and the /dev sdb will be the destination. I'm running the dd command. dd if equals /dev sda5, of equals dev sdb, and status equals progress. Okay, it's working, but it takes some time, so I'm stopping it. In the next example, I'm going to backup and then restore the master boot record of the disk. A master boot record, or MBR, is a special type of boot sector at the very beginning of the disk. The master boot record holds the information on how the logical partition containing file systems are organized on that medium. It also contains executable code, which is usually referred to as a boot loader. So the MBR represents the first sector of the disk with the size of 512 bytes. By default, the dd command reads one block of input, processes it, and writes it to an output file. You can specify the block size using the BS option. So dd if the input file equals /dev sda. This is the name of the disk, not the name of a partition. And of equals For example, /root mbr dot from data, and bs equals 512. This is the block size, and count equals 1. It will copy only one block. And the block was copied. This file in the root home directory is a backup of the master boot record. Now, in case something bad happens, then you can restore the mbr from the file like this. dd if equals /root mbr dot of and the name of the disk /dev sda. bs equals 512 and count equals 1. And I'm hitting enter. I've just restored the master boot record from a file. In the last example, I'm gonna show you how to create a bootable USB stick using DD. I have already downloaded this ISO file, xlinux mint 20. The first step is to find out the name of the device file for the USB drive, and I'm running lsblk. xsdb, as we already know from the previous example. To make the USB drive bootable, it should be formatted with a file system. On most Linux distributions, the USB flash drives are automatically mounted when inserted. Unmount the disk if it's mounted using the umount command and run the command that will format the drive. So umount /media student and the name of the drive. It will be unmounted. And I'm formatting the disk using a shell command mkfs dot and the file system. Let's say vfat. And the path to the device file, so /dev sdb. It's formatting the drive. It takes some seconds, maybe more than 10, but it will be done soon. The next step is to run the dd command as follows: dd if equals and the path to the ISO file, so home student downloads, and the name of the ISO file. OF, the output file, will be the name of the USB stick, so dev sdb. BS equals 4 megabytes, and status equals progress. And I'm hitting enter. That's all. After a few minutes, you'll have a bootable Linux Mint on your USB stick. Let's see how to get information about the system hardware and see what's inside your computer using the command line. There are many reasons you might need to find out details about your computer hardware. For example, you want to upgrade your system hardware or want to find out why some applications do not run as smoothly as you expect. In virtualized environments, the information displayed by these commands reflect the configuration of the guest operating system, which is typically different from the physical host system. So, for these examples, I'm gonna connect to a remote physical machine that runs Linux as the main OS using SSH. SSH-P, the port on which the SSH daemon is listening, the username, and the IP address of the SSH daemon. Okay, I'm in, and I'm temporarily becoming root in the terminal, as these commands must be run as root. And I'm root. Let's take a look at the first command, which displays an overview of the system's hardware. I'm running ls-hw. This is a small tool to extract detailed information on the hardware configuration of the machine. It can report the exact memory configuration, the firmware version, mainboard configuration, CPU version and speed, cache configuration, bus speed, and many more. It displays a lot of output, so it's recommended to pipe it to less or redirect the output to a file. If you need the output in another format, like say JSON or HTML, just pass the -JSON or -HTML options. So -JSON. And the output will be in JSON format. JSON is a data exchange format used to exchange data between different applications and programming languages. And the HTML version. lshw minus HTML. And I'm redirecting the output to a file. Let's say hw.html. Okay, this is the output file. It's HTML code. You can simply open the file using the browser. Very nice. Or if you are interested only in a summary of the hardware information on the system, press the minus short option. Another command which displays information about all hardware elements is inxi, and I run it using the minus capital F and X options. Very nice. Note that this command is not available on all Linux distributions. Another useful command is lscpu. It displays information about the central processor unit and its architecture. To get the same information but in another format, run lshw minus capital C CPU. To filter the output and view only the information you are interested in, pipe it to grep. For example, to only view the CPU's speed in megahertz, run lscpu pipe grep minus I mhz. And to display the output in JSON format, run lscpu with the minus capital J option. This is JSON format. Let's go ahead and see how to get all possible details about the computer's memory. To list all memory modules and their capacity, run the dmi decode command. And I'll press the -t memory option to get only information about the memory. And if you want to see only the memory size, pipe the output to grep and search for size. Pipe grep -I, I'm searching insensitive size. There are two memory modules of this size. Or for the maximum memory you can install on the system, search for max. So the maximum capacity is 16 gigabytes. Keep in mind that DMI decode lists information about the RAM memory installed on the system. It's not displaying information about the amount of free or used memory of the running system. But you can always run top or free -m to see the amount of memory used or free. To list all PCI buses and details about the devices connected to them, like the VGA adapter, the graphic card, network adapter, USB ports, SATA controllers, and so on, run the ls PCI command. Of course, you can always filter the output using grep. For example, I want to see information only about the wireless card. So grep -I wireless or grep -I VGA. To list the USB controllers and details about the devices connected to them, run the lsusb command. For example, this Logitech is in fact an USB mouse, which is attached. And you can add the -v option, which comes from verbose, to print out detailed information about each USB port. There's a lot of information. Let's move on and see how to get information about the hard disks. You can run the same lshw command we've seen before with the -C and disk option, like this. Or to get a single line displaying each disk, run lshw -c disk -short. You can also run lsblk to display information about all block devices, including the hard disks and partitions. To get more information, including size, file system type, the number of sectors, and so on, run fdisk-l. Or fdisk-l and the name of the disk. For example, /dev sda. And it's displaying information only about this disk drive. With the help of fdisk command, you can view, create, resize, delete, change, copy, and move partitions on a hard drive using its own user-friendly text-based menu. Another very useful command is hdparm. This is used to get or set SATA drive parameters. For example, to get details about a specific SATA drive, run hdparm with the -i option and the drive as argument, /dev sda. This is the first hard disk drive, and this is the second one. To request identification information directly from the drive with more details, use -I instead of lowercase I. So I'm using the capital I option. hdparm can also be used to benchmark or check the performance of hard disks in Linux. For example, on this machine, there are two hard disks, SDA and SDB. SDA is an SSD drive, and this larger one is a classical SATA 3 drive. Let's test their performance and see the differences. Let's do a timing test and see the disk read speed. So, hdparm -t --direct and the name of the disk file, /dev sda. I'm hitting enter and waiting for the command to be done. These are the results for the first disk, the SSD one, and let's see the output for the second one, for SDB. By the way, --direct will bypass the page cache, causing the reads to go directly from the drive into the hdparm command buffers. It's a so-called raw input-output, and -t means perform timing of device reads for benchmarking and comparison purposes. And we notice that the SSD drive is much faster than the SATA one. It's almost 4 times faster. Okay, let's go on. To show information about the wireless devices, run iw-list. There's a lot of output, so it's a good idea to pipe it to less. Most of the commands we've seen so far get the information from the files inside /proc, which is a virtual file system. You can always display the contents of those files to get specific information about the hardware components. For example, cat/proc CPU info will display information about the CPU, or cat proc meminfo will display information about the memory. There's also cat/proc partitions to see the disk partitions, or cat/proc version to see the version of the running kernel. By the way, there's also the uname command that's displaying the version of the running kernel. Uname -r. This is the running kernel's version. You can also run uname -a to see more information. Finally, I'll show you a command that shows battery status and other information. This is useful if you are connected with SSH to a remote laptop and want to check if it works on battery or is connected to the AC power source. This tool is not included in Ubuntu, so I'm installing it. apt install acpi. Okay, on my machine it was already installed. And to see the battery status, I'm running acpi -bi. So my battery is full. And this is its design capacity. If you want to see everything the command can show, run it with the -V option, acpi -V. That's all, thank you. Most modern Linux distributions are using systemd as the default init system and service manager. Starting with Ubuntu 18.04 and CentOS 7, systemd has replaced the old sysvinit script system. However, it's backward compatible with the old sysvinit. In this video, we'll start diving into systemd. Its name comes from System Management Daemon, and it is a Linux initialization system and service manager with many components such as on-demand service management, logging, boot manager, and many more. Systemd is the Linux initialization system during its boot and startup process. The Linux boot process has the following phases. First, the system powers up. Then the bootloader, which is grub, loads the kernel. Then the kernel loads an initial RAM disk that loads the system drives and looks for the root file system. Once the kernel is set up, it begins the systemd initialization system. Systemd starts with process ID 1 as the first process, then takes over and continues to mount the host's file systems and start services. Let's take a look at the processes that are running. ps-ef pipeless. This is systemd. In the process list is displayed as init for backward compatibility. However, this is systemd. So systemd is initializing the system at boot time. Compared to the old init, which started the services sequentially, systemd starts the services in parallel. This is a more efficient and faster way of initializing the system. Let's run systemd -version. This is X version, and to show how long the boot process took, run systemd analyze. It may be used to determine system boot up performance and statistics. And to print a list of all running Unix ordered by the time they took to initialize, run systemd analyze blame. Good. Systemd introduces the concepts of systemd Unix, and there are several types, such as a service unit, mount unit, socket unit, and slice unit. Unix are defined in unit configuration files, which include information about the unit type and its behavior. For service management tasks, the unit file contains instructions about how to start, stop, or restart the service. The unit has the suffix .service. We'll take a short break, and in the next lecture, I'll show you how to control systemd and its services. See you in 2 seconds. To control the systemd system and service manager, use the systemctl command. Let's go ahead and see how to manage services using systemctl. This is a very common sysadmin job. First, using apt, I'll install nginx, a well-known web server. I'll execute many commands as root, so I'll become temporarily root in this terminal by running sudo su. Execute each command as root by prefixing the command with sudo or by becoming root as I did. So apt update and then apt install nginx. If it's already installed, the command will either try to update it if there's a new version or does nothing. It's installing the web server. To find the nginx service status, run systemctl status nginx.service. This is displaying the service state and the first few log lines. Nginx is active and running. By the way, systemd is smart enough to know that you probably want to operate on a service, and you can leave off the .service suffix. So you can simply run systemctl status nginx without the service suffix. It's the same. I'm connecting to the web server using the browser. It's running on localhost. Perfect. To stop the service, run systemctl stop nginx. Now it's inactive or dead. Let's refresh the web page. It's not working anymore. To restart a running service, you can use the restart command. So I'm starting Nginx, systemctl start Nginx, and now I'm restarting it, systemctl restart Nginx. This is very important since on Linux the configuration of a server is read only when the server starts. This means that if you change anything, you need to restart the server so that the new config comes into effect. If the application is able to reload its configuration files without restarting, you can issue the reload command. Systemctl reload and the name of the service, Nginx. If you are unsure whether the service has the functionality to reload its configuration without restarting, you can issue the reload or restart command. Reload -or -restart. This will reload the configuration in place if possible. Otherwise, it will restart the service so that the new configuration is read. To configure a service to start at boot time, use the enable command. Systemctl enable Nginx. To check if a service will start automatically at boot time, use the isEnabled command. Okay, the command is enabled. It ends in D, and it's enabled. To disable the service from starting automatically, use the disable command. Systemctl disable Nginx. Now it's disabled. Keep in mind that enabling a service does not mean that it starts now in the current session. The start, stop, and restart commands refer to the current session, what's happening to the service now, and the enable and disable commands refer to what will happen at boot time. For example, I can stop Nginx now, but configure it to start automatically next time the system boots up. So systemctl stop Nginx, systemctl enable Nginx. Let's see if it's enabled. It's enabled, so it will start automatically when the system boots up. But at the moment, the service is stopped. Let's go ahead. To prevent a service from being started automatically or manually, use the mask command. So systemctl mask Nginx. Let's see its status. It's masked. The command has marked the service unit as completely unstartable by linking it to /dev/null. I cannot start it. Systemctl start Nginx. And I can neither enable it. Failed to enable unit. It's masked. To unmask a unit, making it available again for use, simply utilize the unmask command. Systemctl unmask Nginx and systemctl start Nginx. It's running. To see a list of all of the active Unix that systemd knows about, use the list -unix command. So systemctl list -unix. These are all Unix. And to see all the Unix that systemd has loaded, regardless of whether they are currently active or not, you can use the -all flag like this. -all. Okay, these are the most operations you'll perform on a service using systemctl. Thank you.